Thank you, Ahmed, for setting a perfect tone for the day. Good morning, ladies and gentlemen. It's lovely to have you here, and welcome to the fifth edition of this amazing event in Singapore. And what's even more interesting is that this is the 176th global edition of this amazing conference. First things first, thank you all who have turned up early in the morning, whether you're here for the news, whether you're here for the networking, for the coffee, we're delighted to have you here. My name is Pase. I am the director at Pase Partnership, and I'll be your host for the day. A quick housekeeping note, I don't think I need to say it, but please keep your phones on silent. Unless it's an inspirational kind of walking, moving theme, then you find that other than that, please keep your phones on silent. Before we get into the first session, another quick note, we will not be taking any question and answers live during the presentations. However, our speakers will be around during the networking sessions, so please feel free to have a chat with them, ambush them, perhaps if you have any urgent questions, but they will be around, so do approach them and have a talk to them. Right, so let's get started. Please put your hands together for the first speaker of the day, Charu Kokate, Senior Partner at Zak Architects. Charu.
Good morning. It's so nice to see so many familiar faces that you meet during the course of a project, but, sort of miss them afterwards. I'm not a facade expert, and I'm not going to talk about facades, but I'm going to take this opportunity to present our forum and talk about and introduce a project. I'm not sure if everybody's seen it or been to. In the midst of the very dense urban development that is the Orchard Road shopping district, Boulevard 88 and the District Hotel is our latest project in mixed-use category. And also another example from our office where we try to integrate nature and biophonic design in our building. This project consists of 28 stories of residential program and more than 200-room hotel, a very unique, I would say, boutique high-end hotel. Each with distinct characters, and each designed in a way that is complementary at the same time have their own identity. And we did this by strategically locating the buildings to face the streets they are on. So if you are familiar with Singapore, Anyway, I'll just call that to you. On the right-hand side, you can see it's Orchard Boulevard. On the left-hand side is Cascade Road. Between the two streets, there's a huge level difference. Also, Orchard Boulevard has more of residential buildings. By strategically locating the tower on Orchard Boulevard and locating the hotel, which is a boutique hotel, on Cascade Road, it allowed us to really manage the levels. So as you can see from the section, the residential tower really starts where the hotel ends. So the residential tower is above the hotel, even though it's integrated. And between the two buildings is a courtyard garden which really defines the two typologies. One of the characteristics of this project is the skybox. Now, we have multiple level skybox over here. There is one at the lower level and one at the upper level. Both these skybox are designed to be public amenities. Our firm has been pioneering in really thinking of a sky park and really defining the sky park as a public facility, as a public area for public. And we've done that successfully at Marina Bay Sands, which is open to air, sky park, to the pool and everything. And we also extended that knowledge to our projects in Chongqing, China, where it is an internal interior conservatory. And looking at these projects and looking at the density of the city, we thought we would do the same thing in Singapore for this project. So what we've done is we have a low-level sky park, which we call the Sky Garden, that was part of the hotel, and the upper-level sky park, which is like the two levels, which bridges over the two towers, residential towers, and it is part of the residential facilities. The hotel Sky Garden extends the whole width of the site. It starts from Cascading Road, has a bar that extends into the pool, and the pool extends between the two hotel towers. This is purely for the hotel use, and the residential facilities start above that. So this really allowed us, in some ways, to create amenities in the sort of space. Basically, it's such a tight site, and we wanted to make sure we had enough greenery, we had to make sure we had enough space that would allow people to interact, instead of creating a typical mixed-use building where you have a podium and a tower. So we were trying to break away from that typology and create something that would have its own identity. The pool has an interesting feature, of course, it's designed by us. It has an interesting feature of a vortex of a skylight kind of thing in the center of the pool, which is sort of flat with the tiling and allows the swimmers to look down on the garden and creates this immersive environment, basically being part of the environment. The Sky Garden extends through the residential area, and this sort of becomes the entrance canopy or the welcome canopy for the residences. So in some way, it really unifies architecturally these two building types. The residential building is a typical residential building with balconies, with very generous balconies and terraces actually, and which creates the views from Brise Soleil for shading. We've staggered the balconies so that you get a lot of light and you get protection from the rain. The interesting part of it is because we have the bridge that is sort of bridges the two towers, that we have nested 5 penthouses. Each penthouse, as you can see at the top between the two buildings, has beautiful views out. It has French pools. It has all the facilities that you will find. It has really amazing views throughout of the city. Of course, on the top is the public amenity space, which has 50-meter long pool, of course, with beautiful vistas looking at the botanic garden. It has the amenities that residential towers typically have, high-end residential towers typically have, interior and exterior spaces. So because the residential tower is raised high, it already had privacy, meaning that the first level of the residential tower is above the tree line of Orchard Boulevard. So it automatically got its own privacy and the views and everything. When it came to the hotel, because Cascading Road was much too narrow, we had to come up with a new idea for Façade. We had to come up with something that was not sterile, that was something that could be changing. And we came up with this mobile screen system, aluminum screen system with blades that would be adjusted or moved right, from interior of the room. This was designed for privacy, comfort, and the guests could operate it from a control panel right by the bed. They could open, close, do whatever it needed to be happen to do. And this really resulted in a dynamic facade for us, for the building. So instead of having something very fixed, because of depending on the rooms that have been used, depending on what the guest wants, this facade is constantly changing with the light, constantly changing with during the day, during the evenings. And it's sort of like become a feature of the street. It's very beautiful. The scale works well, the dynamics of it works well, and it really looks very beautiful on Cascading Road. The hotel wraps around the courtyard. This garden is a big surprise for anybody who comes to the hotel, because you don't expect a lush garden when you enter one of these properties on Orchard Road. The garden really separates, at the same time unifies the two projects, because the garden is primarily used by the hotel guests. It's an extension of the grand ballroom that you see at the lower level. It's like an indoor space. It's a flexible event space that is used when there are events in the ballroom. At the same time, it's a place where the hotel guests can relax. It is visible from the lobby, from the restaurant. rooms. And I think this is something that the guests are kind of taken back with it. There's like an oasis amongst the whole dense neighborhood. We worked with Ian's Convener and Company for interior designs, and it was really beautiful work because we were able to get the natural light in, the vegetation in, make the space really feel like a port instead of an indoor hotel, typical hotel rooms. The use of natural materials like stone and marble and wood really helped in creating this natural looking thing. And also it's it's an architect's dream come true when you can design buildings that are really make you feel peaceful and quiet without using too much material, too much color. Almost the same kind of feeling when you enter the lobby, which is very simple, Venetian plaster, golden dome, which changes. The whole lobby changes as the day, in the evening it really looks different. The bar, which is the lobby bar, which is, let me go back. We have a beautiful Venetian staircase that goes down, which is a feature. The stair connects upper level 1 to basement. And so all these little things, instead of adding too much clutter of materials, we were able to do it by adding features. And I think that simplicity, it's complex, but at the same time, it just creates such a simplicity. It just makes you feel at peace. Because you come out, you're coming from a marketplace like Orchard Road, very busy, very cluttery, and you come into this place without realizing how peaceful and quiet it is. The lobby bar is its own feature. It's very simple. Also, the furniture we discussed internally amongst ourselves with the interior designer about what we wanted about the furniture. The beautiful garden space, which is also extension of the restaurant and the lobby bar. The curved glass roof with the shading device, with the shading sort of integrated with it, spans the whole length of the hotel space. And this, during the daytime, because of the light coming through, casting shadows, it's very dynamic too. Sometimes it's very quiet, sometimes it's very, what you see in the picture, the trees and plants creating shadow. And in the evening, the space changes so beautifully, it's almost like eating in a garden, but in an indoor, comfortable environment. And I think this is something, it's a smaller hotel space, but I think this is something that we were able to achieve by working with the interior designers and also by making sure that the design of our building, which was supposed to bring the light in, was supposed to bring landscaping, already works together. We were also able to convince the client team about having simple rooms. I mean, they are simple, they are sophisticated simplicity, I should say. It's not like minimalistic approach, but almost like a Zen-like thing, where you use natural materials for flooring and the walls, white oak walls, and the glazing and the seat near the window, all these things, the shutters that could open and close, all these things really add to the dynamics of the room. In our mind, when we work on projects, and we work on very big projects really in Singapore, and we work on big hotels, in our mind really, we were able to create a true sanctuary. It's really, when I see this project, this was constructed during COVID, and it was so difficult to create quality during COVID times that we were able to achieve in this project. I think it really offers for us, it offers a perfect balance of architecture, of nature, and really, and a perfect connection. Anybody who's come over here, and we really keep an eye and talk to people who visit the hotel, anybody who's come over here has always been in awe of the simplicity of the design, at the same time, appreciative of the things that we were able to achieve.
Charu, that was amazing. Thank you for sharing all of these beautiful projects. I particularly like the community spaces and some of the projects that you've shared. Isn't it wonderful when people from all walks of life come together and make your building successful? And the lucky topic, designing with a purpose, shouldn't that be a matter for life? Right, it's time for the next speaker. Please put your hand together for Davide Petucco from Nung.
Hello everyone, I'm David, in Italian Davide Petucco. I see many familiar faces. Thanks for joining us today, and let me explain a bit about my company, Peng, which is an Italian company, as well as about our products. So as mentioned, Peng is an Italian company with more than 60 years old history, more than 500 million of turnover last year, 200 million investments in the last 5 years, and 1,500 people around the world. When I say around the world, it's because we have basically 10 factory stores all over the world, one in Singapore as well, in Robertson Quay, 63 Monmouth Road. And the main factory is in Italy, and then we have a second factory in the United States, which is only for the local market. Big attention to the environment. That's why in 2020 we became a benefit corporation, and this one was the first step in order to become a big corporation. Big corporation is a certification not only about the product, but about the company itself. So basically they test how generative is the business. And big attention also to the environment. As you can see, the production is 100% sustainable. It means that we produce the electricity by ourselves with our photovoltaic panels, 100% water recycled. And every year we reduce basically the emission of CO2. Then the material is 100% natural material, so it's a man-made stone. So we use all the natural material from the soil, the clay, the sand. And average, we have 24% of recycled material in each product. And as you can see on the right side, we have all the worldwide certification, as well as the green building certification for Singapore. Yeah, green building certification as a leader. So the material has been tested and approved in Singapore as a leader, so completely sustainable. But let me show you the production.
design is our passion.
Okay, these material clothes are suitable for all the kind of use, so indoor, but especially for outdoor application. Why outdoor application? Because basically you will see later from the technical specs, the material is not porous, so it can absorb any water and humidity, is scratch resistant, UV resistant, and especially you can achieve big slabs, so the biggest size is 1.6 by 3.2 meter, so basically we can reduce a lot of the joint in the facade. Of course, this kind of application, everyone knows it's like a cool restraint system or ventilated facade, because basically from the base structure of the building to the final layer of the facade, we have a cavity, and this cavity is a natural insulation of the building as well as the soundproofing, because the basically cavity helps you to dissipate the sound waves, as well as being a double skin, so the wind never touch the actual wall of the building. Second point of view, of course, you can play with the different shapes, so we can water jet the material, you can play with the different looks, in terms of marble look, concrete look, cement look, and so on. And you don't have any issue in terms of maintenance. As you can see from the technical specs that I will show you later, basically we can offer better alternative to some other materials, as for example the natural stone that everyone loves. I'm not saying it's not nice, but of course has some limitation, especially in countries like Singapore where the humidity and the rains is very high. And so as you can see, staining most also issue in terms of stability, because usually the cladding, the stone cladding is done by pin on the edge. Okay, and as well as the metal, where you can see that after having a very big joint, since they need to have expansion, they may have also issue in terms of dents. Looking at the technical specs, we can see that the water absorption is 0.08%, so basically zero. So this material, if you put in a bucket of water, it doesn't absorb anything. Scratch resistant, resistant to staining, of course, frost resistant is not the case of Singapore, but for some cold countries like Quebec, Canada, where we have done a project, was one of the main requirements. And of course, resistant to the high concentration of acid alkali. Another important is the material basically has no dilatation, has no expansion to the temperature. You can see the special coefficient is very little. We can consider the biggest slabs in 3.2 meter length with a different temperature of 50 degrees, so very high. We have only 1.2 millimeter of expansion. So that means that we can capture basically the joint dimension compared to the normal aluminum panel and the other cladding materials, let's say. Of course, the system, the material can be stored in facade with a mechanical system. We developed this system with patent, and you can see the characteristics. It can achieve 4.5 kPa in negative pressure, so it's basically affect most of the countries, as well as the country where they have extreme weather conditions, typhoon, and so on. International certification, ATA, European Technical Assessment, but I know that Singapore is very important to have a local certification as well. That's why we got the BC approval already 10 years ago, and since then we got the first project. Another important characteristic is that the material is completely not combustible, which nowadays we know is very important requirement for the facade of the buildings. Seismic test, because of course we do projects all over the world, so New Zealand, Japan, they are very sensitive about seismic load, so we test the system, it's able to resist 2.5 G, so it's basically approved for both New Zealand and Japan too. Okay, this empirical test, of course, we have also the official test, but this is quite nice to see, because sometimes I go to the request is 6 millimeters strong enough for facade, so basically we cut 50 degree on the 6 millimeter panel, and you see no breakage, no issue. Also because in the back of the panel we store a fiberglass mesh, which will increase the impact resistance itself. A case study, this project is in Bangkok, it was a condo, so what we can offer basically to the designer architect is that we start from the rendering, so the architect has an idea, And from that, basically, we suggest a layout in order to optimize the wastage because the panels come with the standard sizes. So if we are able to optimize the wastage, of course, the price is more competitive for everyone, the contractor, the owner, and so on. After the layout is approved, we can develop the structural drawings with the details as well. Of course, submission with the calculation and so on, once it's approved. Then we go on the construction side. So how you can see there is a back frame on which we can install the panels, and the panels can be also custom made. Instead, we can do any holes. In this case, we need to install the signage of the building, so we were able to do the drilling, necessary drilling, and so on. As well, corner details, in this case, 45-degree miter joint. So basically, the behavior, basically the installation process and the fabrication is the same as the marble, the natural stone, but of course with this stone we can achieve bigger size and lighter weight because we are talking about 6 mm thickness, and we have also a solution for 3 mm thickness. And this is the final result. Some references starting from Singapore, mostly group plus bungalows and detached bungalow. That we have done where the credit basically the main feature. Also the swimming pool, as you can see, these are narrow marquinhos slabs, and it's very important to have a material that is not swimming and is not troubling anything because basically we are in a very aggressive environment as a swimming pool for a chemical product. So that's why they decided to go with this material as well as for the huge slabs because this is 3.2 meters. Another semi-detached project was basically the architect was in love with the curtain, but since you can see in the lower part of the building, it was plaster and paint. Yeah. So the concern was what's going to happen with the metal curtain once it starts raining? It will become basically orange, the back, the lower floor. So that's why they decided to use our panels because you can have the same look, very rustic look, but not staining. So even when it rains, nothing will drop on the paint. Another good bungalow when they want to use a standard marble looking. Yeah, still looking. Right here. Yeah, also sometimes they want also to clad just a function, so one elevation of the building, so it's also possible. We have flexibility. You can clad, the wall basically elevation on just one part, and then also the finishes with aluminum that can match the color. You have just a feature of the main entrance of basically the villa where they want to use the granite looking panels, 1.2 by 2.8 meters. Yeah, we have also the mock-up on our table. Basically, we show the finishes of the arch. It can be 45 degrees, it can be dome out, we can clad the ceiling, it can be also slanted surfaces, so no issue. Okay, this is one of the latest projects. I just took some pictures basically 2 days ago. I'm just finishing up. And now it's one of the international project where we have done a house building as Milan historic building basically in the center of the city of Milan. Riva Yacht is the producer, one of the biggest producers of basically mega yacht, and they want to use our panels with the customization of the color because the building is on the sea. So the environment is very aggressive, and if they want to go for aluminum, because of course the coating might have issue in the timing, having a very aggressive environment. You will also have projects all over the world. In this case, they want to use a smaller size, but if you use, the shade of local stone, so we customize the product. This is Façade in New York City. South Korea, which is one of the biggest markets for us in terms of facade, where we have a high-rise building. Office building as well, so the application can be very different from high-end residential to office to hotellerie. They can play with the different color and the different texture of the material. Another tower office in Korea, where You can see the Korean people are white. It's 90% basically of the facade is done with the white color. As well as a private house, a luxury private house, where basically they want to match, the aluminum fill with the other white color as a base. This is a custom-made product, and you can see we can water jet, and the interesting part of this project is in the back, between the cavity, they also install basically LED lights, so nighttime they can light up the facade, as you can see here. So quite interesting look, daytime and nighttime. The last project, and basically also here we customized both the material and the shape, and you can see the continuity, and is one of the, let's say, most advantage to have a continuity between the floor and the facade. Thanks for your attention, and as I said again, we are located in 63 Mountain Sultan Road, so if you have a chance, please visit us. Thank you.
David, thank you very much for sharing with us this beautiful project and this beautiful product. Technological advance, but also great effort towards making them sustainable. If any of you fancy these products, please approach them at the booth, which is next door. David and his colleagues will be available. So now we're ready for the next speaker. Please put your hands together for Michael Singh from Ahmed. Morning, everyone. Good to see so many of you this morning. Every 2 years I see you once, but I still like to thank Zak for that. Otherwise I won't see some of you at all, but please feel free to catch up. Today I will talk about Capital Spring, one of our initial projects just got completed last year officially. One many project. I was supposed to do this with one of our partners from Capital Land. Unfortunately, he had to travel last minute. So, I hopefully can do some justice on his part. So, a bit of, they probably don't need any introduction, but, they are the biggest developer in Singapore, Capital Land's portfolio. You see the number of properties that they do across 260 cities in 40 countries. Right? Some of the Singapore portfolios you will be quite familiar with. Capital Spring, everything that's not the capital, obviously is developed by Capital Land. Interlace, Science Park, which they just completed, and Jewel. International, you've got a series of projects there, which may or may not be familiar to you. But they've been around, and they are the biggest, definitely the biggest developer in Singapore. Arab has been around for 25 years. I'll just go through some of these slides very quickly. Hopefully you would have known us. As a firm, we've got 94 offices, 34 countries, and 18,000 professionals, up and down, depending on the economy. As a firm, we've got about 300 people globally, sitting in different offices around the world. In Southeast Asia, we've got a team of 30 people in Singapore. We've got a team in Malaysia, we've got a team in Indonesia. But we work together as one, and we very often go across geographies to deliver projects. Okay, back to the main part of the show, Capital Spring. This is where the location is, smack in the middle of CBD. I drive to work every day when I see this building, so it reminds me, the beautiful project, and it's a very nice view that I see. So maybe perhaps a bit of history within Car Park. It was open on the day that I was, on the year that I was born, 1977. So many years ago, at the time, CBD didn't have a birth of, there's a lot of people coming to work, but there's no parking car park. So Golden Shoe Car Park was developed, and it was very, very popular. And one of the big things that was in there, besides the 10-story car park, 1,704 car park lot. But the one that's most popular is Hawker Center. And I'm really glad, and most of you probably know that it's being maintained, it's being mandated by URA to be incorporated as a component inside the building itself. So it's on the 11th and Kadorati were the designers, ISP were the local designers, and obviously you see the big team of people there. For Arab, we did facade engineering, sustainable ESD, sustainable design, structures, and a few of the disciplines. But there's a lot of to actually do a lot of integrated design processes into this, because for building of such complexity, you will need that integration quite closely. So this is the earlier mapping model, the three components, quite clearly the roof, and then you've got the slim tower coming down. The entire height is 180 meters, and then you've got this signature space called Green Oasis at the center, and then it comes down to a big podium, which actually house where the hawker centers are, and also a car park. So a bit of the design brief and how it's developed from left to right. 200 meters didn't change, but essentially this is the typology. You've got the offices at the top, and then after that you've got service residents as well as some hawker center spaces, as well as the podium retail spaces all the way at the bottom. Right, but visually it looks seamless, right? And it's quite an interesting space architectural intervention that comes all the way down the entire. It doesn't look, like what you see on the right. Every different color has a different design. It's actually quite seamless. So design brief, you have some of these main components. City room, which is actually ground floor, 20 meters high podium, very, very high ceilings. So one of the first things you probably ask how to maintain. We've actually got one nice spider look that's hidden at the side, which is being used when we have to change some of the lights that we need to do when it breaks down. Then the main lobby, obviously, that one's the 90-meter one, but office space, of course, as well as the service residence here, which is maintained by 299 units. And the rooftop, there's an urban farm. So you have a chance, this is all open space. The urban farming is actually quite large now, fully grown. You can go up to the rooftop, access it, and I think some of the plants actually being used by restaurants just beside. So farm to plate, quite interesting and a nice concept. Green Oasis is perhaps the part of the center. That's the part we also do most of the work to make it feasible or make it environmentally comfortable space. But you can see a lot of activities at the moment is being done there. It's a nice space on 17th and 21st floor where you can actually connect by a spiral walkway. And then the last one was the bossy room at the bottom, the 20-meter space at the bottom, which is also fairly vibrant throughout the year. So I just would like to talk about some of the stuff that we did as Arab. And this Green Oasis is one of the biggest, or I suppose one of the most complex areas that we had to work on. This is the area that we zoom in. If you drive from Hard Rock, you'll probably see that's the road that I come in. I see this view every day. And you kind of look at it, and it's like a big curtain coming down, a series of vertical fins that all come down. And where it's strategically placed, where the Green Oasis, some areas at the top and some areas at the bottom, it actually pulls back, peels up to allow obviously for us to visually view inside. These are the areas where the green areas are. But it also allows, obviously, wind to go in and allow light to come in. So there's a series of things that we have to do. This is the architectural diagram. Essentially, it's a space that you can walk all the way, either top down 20th floor and walk all the way down to the 17th floor. There's a lot of breakout spaces. There's a mini auditorium there. There's a lot of space that you can just sit and relax and chill. There's a restaurant at the bottom. So it's a very good space. But of course, with areas like that in Singapore, you get open space like that, you will be subject to the elements. Right? For the past 2 weeks, we've had sudden rain, thunderstorms supposed to keep it naturally vented, was to do a series of intervention that we call, in a lot of things, biospheric design. But because there's a lot of plants in there, you can see that goes up on every floor. They need light, right? And some of these lights are actually not direct sunlight coming in. And some of the spaces are actually quite deep. So we actually had to do daylight studies to assess the amount of daylight that each and every one of those pockets, even down to the deepest ones, are able to receive daylight. And water, unfortunately, water you have to irrigate. Right? So that's one of it. The other one was also the landscape consultant, really had to pick and choose the type of plants that will actually thrive with not too much of direct sunlight. Right? So the other thing that we did was also completed, CFD studies to actually see the thermal comfort of the person inside. So you're using this space, how long would you be able to sit there and still feel comfortable? Would it be a deep space? Like a lot of the areas in Singapore, open spaces actually like that. They're either too hot, too humid. So in these spaces, when we do an analysis, what is the probability of this space being used for at least 90% of the time? And with that, we call what Eric referred to as building environmental modeling, which essentially find a balance between the thermal comfort, daylighting, and rain penetration. So these three are the most important things for some of these open spaces for the different areas. For the picture on the right, for the hawker center, it's even more stringent, right? So in those areas, we actually have movers that we have to check to a certain degree to make sure that 95% of the time is actually watertight, and the rain won't come in while you're eating a bak chor mee. Okay, so a bit more views on this. If you haven't been there, please have a look. Go up there and have a look because it's really a nice, interesting space. The rooftop is accessible to public. The green oasis is also accessible to public. But I know there's some timing, so you've got to check. So some views of that. Okay, so we look at it, internal space, obviously, the intense, invisible space, you've got people actually using these spaces. But one of the things that we had to do was this things on the outside. This space here, with the things that runs from the roof all the way down, is only one side. Right? If you look at it from the front, it's 300 deep and 150 wide. That is the minimum size that the architect, I suppose, can accept for the look of the building without getting it too distorted and the dimensions running out in that sense. So we're given that priority and we have to design that from roof all the way down. So if you look at that, and it's most challenging for this area, right, the green oasis, where the spaces, some of this space here is about 38 meters free spanning. And some of the structures that we have, you imagine from there we can tie back, but the structure is also not on every floor, not all the way to the edges. So as a result of that, you can't really tie, unless you do big tiebacks to the back. So because of that, we strategically put some interventions, tie it back to the different areas like what you see in this red and blue area, but you actually can't see it. But this whole area actually actually span 38 meters. Structurally it's fine, no problem at all. We are actually we're doing this to limit the deflection, so you won't see the things vibrating at that height for 48 meters or so. We had a problem at one time, the corner thing, which was actually the most stringent one, under wind was actually deflecting, so we had to do something to it. It's not going to fall down, I should, but it's just not very, doesn't look very good when you see things like that vibrating out there, because of the wind. So when we started looking at it, we had to put it into a model, and just to make sure every one of these things are actually catered for, and where's the tieback locations. So using a series of rhino and grasshopper strips, we managed to map out the entire ring of that thing. Every one of those things are slightly different. As you can see later, I'll show you how things like this So from a material point of view, we also look at it quite extensively in the sense. We initially wanted this to be a structural thing. The architects like the look of it being a galvanized mouth steel with a layer of coating. Of course, galvanized mouth steel has its disadvantage in the sense you've got to deal with the rust and you've got to deal with the weight, right? And you take the head and you've got to pull it out and replace it, that becomes an issue. With repairs as well. So eventually, that's one of my considerations we looked at. The one on the right is perhaps one of the reasons why we didn't want to put steel onto aluminum, because there's also one part of that we need to look at. So this steel is actually mounted as part of the continual system, which if you had to put it on there and use galvanized mount steel, it would be too heavy. And the steel and the aluminum contact will make it problematic in terms of galvanic corrosion. So that's something that went against it. But there were also things that we looked at in terms of bending radiuses and how it can be formed, whether we needed to have some structure to actually put in between the fins to make it stable. Those are some of the options that we looked at. Obviously, the typical ones would be the one on the right, when we put a steel structure and then we clad it. But the architect and us at one point were actually quite adamant to make sure that this is as minimal as possible. We want the things to be structural as much as possible, and that's how we eventually ended up with an extrusion. It's an aluminum extrusion that is being bent and curved. This one is just a diagram that comes from the top that shows you, essentially the complexity of this. I talked about one area of the green oasis, but actually the constraint that we need to do was actually much bigger because the frame needs to look 300 by 150 from the roof all the way down to the podium. And the lines need to be continuous. And as you go along the way rooftop, you come down to the office. It's actually a different backing in the back. It has a curtain wall system. And then when you come to the FR, it's a curtain wall system, but then it has openable windows. And then when you come to the down to the green oasis, you actually have no backing behind. It's freestanding. And then you come down to the podium, it's another system again. So it was quite complex. If you look at all of these areas that we got, with one single constraint, which was really important to the architect and as well as the developer. So then these are just some of the images. I'll just blast through them very quickly. Some areas we also need to curve them. And when you look at it, in some areas on the roof, for example, we have to put steel inside because it's cantilever, so not much we can do. But look and feel remains the same. So these are some analysis we've done. I'll just browse through it. But what you will get is a series of, and this was looking at the contractor what we pay, which was really quite brilliant. Everything on the front is essentially standard. We are just basically extending the thing, the back, the structural back on the front. So the one picture on the right actually is what you see on the roof. There are some main members, which are the bigger ones. There are some intermediate ones, which are the smaller ones in between. And, essentially from our roof, if you just kind of look at it from the front, it's all same thing. And so one of the, I think, good things that we've done in the job, among others. Okay, so fabrication-wise, this is where it was built. So you kind of look at it, we said we want to do extrusion, right? When you do an extrusion, and for this, if you're a structural engineer, you will know the major and minor axis. This thing here, this extrusion, if you bend it in one direction, it's easy. But you bend it on the other direction, it's actually very, very difficult. And this is the one that we are talking about. When you're bending it in this direction, it makes it difficult, even more difficult. And what happens is, when you actually do that, you don't do it carefully. The areas at the side will trim, and basically your extrusion is gone. So a lot of this, fortunately, what's doing well for us is a lot of these radiuses are not very big. It's not very small. So it's big radiuses, very gradual, and we're able to do that. Even though when we start bending it, it didn't really work well. We took a few rounds in a factory in China to actually formulate the actual methodology to do it. So you see on the left, on this wall here, there's this big wall. Essentially, they have quite old school. They've got essentially drawings of this thing, the dimensions, all the way from this wall, or the different things, from this wall to this end, all the way to the end. And entirely, they just pasted the whole wall with, essentially sections of the film. So every time they bend, they can go back and check essentially whether they've done it correctly. We've got this big bending machine that they use, which was quite amazing. But one of the things that this is what I'm talking about, of course, these are the edges at the end. And you see where they clamp these areas at the end, they tend to bend and they tend to crimp. So if you bend it in this direction, and if you use too much, essentially, the radius is too small, you can get into this kind of situation. And because the entire thing is hollow, it makes it even more difficult. So we have to do this, essentially the foam, the hard foam that we fill up the entire extrusion, essentially to support the extrusion and bend it so that it doesn't deform. Eventually it was quite well done. Every single one of them tried, tested, formed up on site, formed up in the factory, delivered to Singapore, and then got delivered to Singapore. For a long time, it looked like that, which was not very fancy. These are some of the photos after. It may not look like, the star is obviously the vertical, but the horizontals are also quite big. So those levers at the side, and at the bottom, the horizontal levers are like 6 meters wide. And it's really quite difficult to get it to pass without having it to set. Some construction photos as well as this one on the left is actually the rendering. Again, some photos here. Just quickly down pretty good night photos. We have to do a lot of models to test the visual mock-ups to actually test the liver angles, the color, and the glass color, the tonality. Lots of those mock-ups are done, and the complexity, we also want to approve or essentially have a big say in terms of whether they like the eventual outcome of this mock-up. I'm glad it went through, it passed. Okay, so this is the last time. So, I won't talk too much into it, but it was quite special. So what we did here, the curtain wall was how it evolved. Big wanted, or as an architect, they wanted it to be a structural element. Every part of it, curtain wall need to be structural, need to be functional. Need to be functional. So a lot of times, you look at it from the right, from the left, is how you design curtain wall, the models on the inside, after that, anything I want to put on top is when you move to the right, the fins that we put on the outside, any appendages that we put on the outside, they are non-structural. But obviously, as we evolved along, the fin became smaller, but our structural member, curtain wall member, the members, we had to change. So instead of having a depth, the intent was to make it as slim as possible. So as a result, we had to make it wider. Essentially, it's not efficient just because of the eye values and from a structural integrity point of view, it's always easier to have the depth, right? Because it's in-out direction that is most important. But in this case, the architect and the client actually agreed to minimize this space to a point that what is the minimum? If I can put a structure outside, they will want to do that. But obviously, we can't do that because of the system the curtain wall system that we need to design. So all our gutters and our transoms, the minimum transoms still need to be there. So again, this is the shop drawings, YKK's shop drawings, which to realize that design, you see actually the Maglianos are very, very small. They're 115 across, but the depth is only about 80. Right? So it's tiny. Not the most efficient from a structural engineering point of view, but from a wood point of view, this is what you want to see. Right? As you push the Maglianos out as much as possible, and part of that structure is actually moving outside of the glass line. That's how we kind of manage to do that in that sense. Numbers or what that Cactus Spring has won and still winning from 2020. Of course, the President's Design Award in 2022, and a big winner in CTBUH 2023 as well. But one of the things there, we actually had a separate category there for excellence awards system. And Cactus Spring we wanted two. One is Façade engineering, Façade system, and then the other one was MEP system. So it's quite a really exciting and iconic project as far as all of us are concerned, I think. Okay, I think that's all I have. Very different from what I usually talk about, but this is one of the projects that we're really, really proud to do. Thank you. Thank you, Mark, for sharing an amazing project. It is one of my favorite buildings in the city, so if you haven't been to that, please go there. That green oasis that Michael said is an amazing space. It's very well loved. People of the city, the community use it. Every time I've been there, I've seen old folks hanging out, I've seen young kids doing yoga, I've seen people taking Zoom calls there. So it's an amazing space. And thank you, Michael, for sharing how complex the design of that space was. Well worth the effort. So thank you again. We have one more speaker before we have the networking session. And we're all looking forward to that because we know good conversations are had over a great cup of coffee. But before that, we have our next speaker. Put your hands together for Mr. Andreas Geyer, Managing Director of Siew. Nick, thank you very much for that introduction. So let's start with a quick introduction into the company for those of you who haven't heard of Siew before. This is our headquarters. It's approximately 60 kilometers west of Munich in southern Germany. Siew is one of the leaders for ultra-complex metal and glass structures, I would say. So we were founded in 1984 by Mr. Siew and Mr. Gregory. We are pretty much all over the world. There is also a branch in Australia, which is not changing in the map. Me, myself, I'm responsible for Southeast Asia, Australia, and a bit of India working as well. We have around 1,100 employees worldwide with a turnover of $350 million. That is for the contracting arm of Siew, but there is also another unit of Siew which we'll get into later. So what they are doing research and development, engineering and design, contract management, testing, manufacturing, logistics and installation, so pretty much the typical scopes, whereas we have research and development that is also looking into project-independent product solutions. That's maybe a bit of a difference to others. And for us, also the logistics is a super important part because we are transporting super big units all over the world. So we can now produce glasses 350 by 20 meter, that makes 70 square meter per glass. And these things have to be transported all over the world as quite a challenge. So here you see some typical scope for construction types that we are doing. We have the steel and glass construction. So on the top left, we see the mining train hall in New York. Then we have all glass designs. On the top right, you see the I-11 in Hong Kong. Then we have cable designs. That is in Bangkok on the Icon Ceiling Club, the Wisdom Hall. And the hobby of ours, we can say, is membrane constructions that we also do with the ETF cushions that you see here, Project One Manifesto in London. When our clients invest in property, they want to create value. And if we talk about value in our industry, then if we talk about value engineering, so what can possibly go wrong, right? So here, some examples. On top you have the architectural intent, on the bottom you see the outcome of it. I've been choosing here some extreme examples, but you all know what I'm talking about. So value engineering. When you keep that word around, it becomes engineering value, and that is what Façade is actually doing. We are engineering value, and we are not only engineering value, we are also building value since we are a contractor. So we are engineering and building value for our customers. So today I will do something that I normally don't do. Normally I look only into projects serving Southeast Asia Pacific. Today I will have a quick look here into Germany, that is Stuttgart 21, that's the underground railway stations. You can see here the skylights in the center of the pictures. They bring the light down into the underground station. And then you see some bridge rails there, they bring the people down into the station. And here's some more impressions of that. This project is still under construction. Going over a couple of years, there's 1,030 tons of highest precision steel, 4,319 millimeters, 5,000 square meter glazing, 21,500 meter tube cladding. They are in the skylights on the inside and outside, and in between you have the optimized heat and smoke exhaust technical things. And we have 3,000 square meters of biaxially curved stainless steel cladding on those. Here a quick view into the fabrication. The robot welding of members and model points, already highly automated nowadays. And a quick view of one of the bridge rails, of the entrance bridge rails here by night, still under construction. Here you can see the process of mounting the skylights, lifting in the segments into place. On the right hand side you see the welding preparation for that. And then the glazing of those skylights in an environment, in a protected environment. We've been putting the containers all around and put a tent on top, so we can work independently from the season or the weather. And here you see on the left hand side the architect's impression, and on the right hand side nearly finished. You can see there are still works going on in the railway station, but it gives you a very good impression already how it will look like in the future. So we are talking here about 32,000 components. And what's important in projects like that is the end-to-end digitalization. So we are designing a digital twin level. Digital twin is a project by Fraunhofer Institute where Züge was also part of the development of this digital twin system. Here are some impressions of the engineering process. And then going into the assembly, as I mentioned, it is an end-to-end digital coverage of the whole project, so also on-site with multiple barcodes and so on. You would be completely lost to know where all these parts are going to. So it's a really extremely challenging project, and we are very, very proud to execute that. So now let's jump quickly to Southeast Asia. Let's just quickly show you some of the projects we did here. That's the Apple Knife Bridge on the top left. You all know it. And then Apple Mumbai in India, the Captain Shopping Mall in Melbourne, around 6,000 square meters of free-form bridge line. On the top bottom left, we have Apple Juba Singapore. Center bottom is Genki Tokyo in Japan. That's actually a kind of a unitized system, was all prefabricated and installed like a unitized system. And on the bottom right is a project that I mainly saw for sentimental reasons, because it was the first project in my life. I was project manager on site for the Grand Theatre in Shanghai in 1997 with Siew. Then let's have a look to Bangkok. This here is the Icon Façade with over 6,000 square meters of jacket full glass facade design, all suspended from the rooftop or from the terrace floor here. normally I show a video about that, but this time I chose to show a video of the same project. This is the Western Wall on top of Altenstein, and it had its own challenges, and I would like to show you a little bit about that. We have around 80-ton A-frame up there, and we could only lift with the tower crane up to 4.5 tons. That was the limitation, so how to do that? So we were erecting a massive press deck in front of that Western Wall. We were producing customized hinges which we fixed against the concrete, and then we were welding the whole A-frame on top of that crush deck. We got a good impression of it. And then that's what we do with it. I already hinted it with the hinges. We are pulling it all up. On top of it, there is a single bolt that will then hold the whole construction into position. All of you in our industry will know what a precision is necessary to achieve that. To build it on the crush deck, pull it up, and make sure that the bolt on top is held exactly into position where it's supposed to be. So let's see how it goes. I mean, you can guess it how it goes. That is a younger me here on the picture. And then getting closer and closer and closer. And here we go. Absolutely fantastic project. The ground screen, obviously, and that was the finished project then. This is on the same project, also on Icon another Apple store that is on the terrace floor here. We did the outer and the inner facade of that Apple store. And Bangkok, Magliano, here we did that skywalk. Absolutely recommended for anybody who goes to Bangkok. Go up there and walk on the glass and look down from 300 meters. Fantastic. We did also the double glass cylinder that you see here. This is leading up to this glass door. With 3 stories, and has this spiral staircase in between the 2 glass cylinders, and in the center cylinder there is an elevator coming up, and the whole glass cylinder is stabilized by itself. So there are tension rods in the glass frames, pulling the roof down and compressing the glass and stabilizing it by that. Very interesting construction. This one is true digital staircase. That's also kind of a hobby of us to build complex staircases. And one of my most favorite projects is the Apple Central World in Bangkok. Here we did the whole steel crown coming up into the roof area. We did the roof cladding, we did the glass, we did the second floor slab, and practically all the structure of the building, but not the wood and not the project. And this is the absolutely fantastic staircase inside this Apple store, which is winding around the central core. And it's produced out of solid stainless steel tracks with a stone layer on top. And you can see here the super slim stringer that is going along the tracks. And in this super slim stringer there is the glass balustrade installed. So I think it's a stunning beauty. This is Brisbane. It's still under construction. The Queensland New Performing Arts Centre, a based facade. Here again, the whole system is suspended from top down because the second floor slab, where it could otherwise stand, is so slim architecturally that it simply couldn't take the loads. So the whole facade is hanging from the steel structure of the roof of the building. Some impressions? I think it also came out extremely well, that project, even if it's not yet finished. And Apple in KL to the Zak exchange. So you can see the dome is around 50 tons of steel, if I'm not wrong. And it's standing on super slender steel and stainless steel columns without flipping over to any side. How can that happen? Very simple, or not so simple, but it's clear. The columns only take the dead loads, whereas the glass is taking all the electrical loads that could come there. So it's a combination of glass and steel that is stabilizing the whole dome construction here. Some impressions of that. We also did the inner facade that is leading into the shop from the podium area. interior impression there. I think you can see very well again how the whole thing seems to be floating on top of that glass wall. A smaller project vegetarian Singapore embassy building. Here the client was asking for a relatively high burglar resistance glass, so that is also something that we can do here, tested in Singapore to German standards. And now let's come to Pase. Pase was finished last December. Very interesting project. So we have 20 tons of ultra-high precision pre-manufactured steel units, 571 triangular olefins and glasses, 299 flat, 232 curved, 28 tray-shaped, and then 12 even things. So we also have killed glass in that project, and quite some meters of LEDs behind. Let's have a quick look into the engineering. Since we did not have very reliable documentation about the shop, which was giving us the information that we would have needed, we needed to do a 3D scan of the whole project, and from there derive some basic geometrical information we will need as the lease line of Pase and so on. From there we then went into the development of the first model. Architectural model you can still call it, because we have to arrange the triangles on the right side so it fits from entrance to entrance and so on, and the height. And after that was done, we went into the engineering. So originally we were supposed to suspend the whole facade from the bend deck on top, first floor bend deck. However, along the first month of engineering, we had to find out that the spring-loaded brackets would become impractically huge because of the light load deflections there. They were so big that the spring loads could simply not do it anymore. They couldn't equalize the whole load of the facade into the bend deck in a way that it could be acceptable. So we had a little bit of a problem there suddenly, and we were thinking how to solve it. One thing that came up, we have 4 columns standing there, that's what you see here in blue, and the idea was, could this facade maybe stay along the bridge all around from one column to the next column? Let me see whether this thing works here. The pointer, that was over. Here, pointer. So we would go from here and then that way to here, then bridge to this column, and then back to this side to that column again. So we checked, we were running several structural models, and we came to the conclusion it should work. And then we pursued this way, and it worked in the end. So we are bridging now from column to column. The narrow stuff that you see on top is just the window brackets. So I guess the specialists on the unit already said it, what's happening here. We have no loader points, so we have only these prices. And the these prices, one unit has to fit to the next unit practically perfectly. Well, you can see it here, there is practically no tolerance over the whole area of the facade. It all has to go together. So, for fabrication, it meant for tech welding, as well as for final welding, we had to pre-assemble everything in the factory. So we had to pre-assemble twice before it went on site, because we had to make 100% sure that everything fits. One thing not fitting, we have a problem, a big one. But it fitted. So here you see some of the elements of the painting, and you also see the complexity of the loader points here, respectively the lease prices, here in the kilt area. This is a quick view into SEDEC. SEDEC is another member of the Sale Group, a glass processing company. I mentioned it, we can do this super huge glass units and so on, but I will not go into detail now about it, but they also produce the glass for further, including the kilt glass I was mentioning before, the aluminium frames for the outside, and you see the nicely welded corners here. And then we go into installation. In order to suspend it from the columns, we had to put brackets around the columns in order not to damage the reinforcement of the columns itself. We had to keep the penetrations into the columns to a minimum. So the bracket was the solution. Here you see some pictures of the installation. How it's going on, and here the lease prices and how they went together on site. And then on the left-hand side, the brackets for the LEDs installed, and the gaskets coming on the left bottom, then the glass coming, and then the outer aluminum frames coming in. Here a quick idea about the LED complexity. We had 4 server rooms and an extremely complex grouping to avoid any visible cables on the project. and some commissioning of LEDs. Now let's come to some impressions. That's the view from inside. It's in the second story, there is a coffee shop with the totally seamless steel construction, and on the right-hand side, first floor, shop front, and here on the right-hand side, you see the cleaved glass I mentioned that is going up that facade. That was also a first thing for us to produce cleaved glass. So, from digital to reality. And since I was talking about LEDs, a quick one about LEDs, that's Las Vegas. That is the steel, it's the largest cylinder screen on this planet. So here we didn't do the facade, here we did the cylinder screen itself with 65,000 modules. And here just a quick idea for you how that impressive cylinder screen works. That's a U2 concert where look at all the audience. And it's an unbelievable experience inside. So it's an LED screen made by Siew. Last thing. So I hired architects and Gregory partners in Hong Kong, the Henderson. So here basically Siew has three scopes. The first scope, the Siew group has three scopes, I need to be more precise. First scope is the podium, that is Siew as a contractor. So we did it from design, fabrication to installation. Second scope, rooftop. The same, Siew as a contractor, design, fabrication, installation. Third scope is Supahat again, this member of Siew group, the glass company, did the whole supply for the tower to the company that was producing and installing the unitized system. So practically everything that you can see here on the tower is coming from one or another member of Siew group. Quickly into installation, fabrication. This is in our steel factory in the Czech Republic. It's a high-end factory for architectural steel that can do most complex breakthrough steel to extremely narrow tolerances, which is very important when you combine it with curved glass, because you don't want to have any stress in the glass, so tolerances have to go together. Here, this is a way of stainless steel components, and here is a way of a curved, biaxially curved glass. So we are putting certain powder on top of the glass, which allows it to be strained. Here, the side of the strain is directly going into the engineering model and is compared there with the allowable tolerances, and we will know whether it fits or whether it doesn't fit. Installation, a couple of pictures. That is in the podium area. Here you see again these beams that we just saw in the Czech Republic company. There's the foiling on the glass. Rooftop installation, glass coming in, our logo on the tower top, and now some project impressions. And these are real photographs that are not renderings. Absolutely stunning, I would say. The entrance area, all the glass in the cladding by Siew, 3D claddings are extremely complex here. View from inside in the podium area and a view from inside in the rooftop area. Here you see one of the claddings in the rooftop area. They were also production-wise not exactly easy to do. We had to use different fabrication methodologies coming together and to come finally to the shape that we can see here on the picture. And then here the Henderson, the AIA, American Institute of Architects convention, end of 2024. What better place to have such a convention on top of the tower? Here that's the headquarters that we saw in the beginning of my presentation. A bit of engineering impressions and fabrication impressions. Again, digital green level of engineering, everything is 100% digital. Glass production and so on, one of our building processes here for building glass. You remember that I told you about the difficulty of transporting these tools, which was a quick picture of that, and here the glazing of the rooftop. ladies and gentlemen, this is what I think is relevant to our clients. Thank you very much for your attention and have a good day. Thank you, Andreas, for sharing the beautifully complex projects. I can only imagine the hard work that goes into creating those very precise, complex details. Also, this is the time for a networking break, 4-minute networking break. So please go and grab your coffee, visit our sponsor booth, and exchange those business cards like it's their Pokemon. Welcome back, ladies and gentlemen. Hope you had a good networking break. Lots of caffeine in the system because we've got a lot of great speakers coming up. Deep dive discussions coming up during the day. Let's welcome on stage our next speaker, Mr. Rajan Govind from BS Consulting. Good morning, everyone. I'd like to thank you, Zak, Vanessa, and all the sponsors. So, we have a good coffee break, I guess. I can see still a lot of interest, so people are busy with the networking. Okay, so I have to finish on time, so I will start my presentation. I'm going to talk a little bit different about from facade contractor point of view. So it's not like design. So I just took brand consulting and just speaking from the contractor point of view. So just to brief introduction, we work on different very interesting things. We work on facade engineering, then changing anything complex geometry we like to work. Build engineering in terms of simulation based, we work on building physics in terms of air, what is the impact of air and water on the facade. We do on simulation and acoustics, this is our primary focus. This session I would like to just, as a overview, this other place I would like to touch base briefly on the high level. Efficient design process, design for construction, not just making some documentation, what is the value really adding to documentations. Do on the implementation side, so try to be on the contractor side sometimes so we can able to understand the challenges. And this design we call pre-conception or whatever this design, how would make the difference in the project? Yeah. So as everyone knows, especially the contractors and architects in here, they know the challenges of a design, especially the facade design. So we can see the facade design happening many times, so it's not once. So to my experience, at least I can say 3 times it's getting designed. First, architectural conceptual, and then it goes for pricing. The contractor comes in, so something is not fitting, then again a design. And then maybe actual design happening on the construction side. So at least 3 times we are designing. And as we all know, the design security is getting precious. And the youth, a lot of designers have maybe retired, so there's actually skills shortage in the facade industry. So how we can make the design better? So just outline, what is the so-called outline, how it could be better? And the things which we do in a pre-construction stage, we have a lot of time to do it in a proper way. So when you do the design outline, anybody can draw this section, so you don't have to be an engineer or specialist. So the architect can do this type of technique. So what is different from this technique, how you can design it in a better way so contractor can understand, and he's putting a lot of risk in taking the project, so his life is easier. So when I say the key process, we usually involve on design, detailing, and engineering. I just touch based on what is the benefit of doing a pre-construction design much better in a resolved way. When you do the construction design, you have a whole team available, big specific consultants, MEP consultants, structural consultants. So we are working with a very large team, so the design could be better because many minds are working. Integration is better. And efficient and economical design, most of the time facade has to work with architectural and the structural. So often you have a layer of, second layer, third layer of structures which maybe it's not necessary. So it can be integrated better with the layer structures. And then if you are doing all this with the construction stage, basically there is no time for rethinking on the construction stage. And when we move on to construction stage, we have a limited engineers available, then you are relying on just 1-2 engineers decision is taken. So, a lot of things, as everybody knows, the design if you are doing in a pre-construction design is much cheaper, it has less impact. The further we move on to tender stage, construction, the last one is construction stage, not construction stage. So it's getting more expensive. The design is moving from tender to construction stage is one expensive time, and it will have a multiple impact. So it's good to have the ideal design. We can spend a lot of time on the construction stage before the pre-construction. So I just took from my part, I put some of the slides, how it makes efficient design and inefficient design. Especially if you see the time supposed to be spending on this, I put unspent time. This is the time supposed to be spent by somebody, either a consultant, a contractor designer, or somebody else, facade engineer, not just a consultant. It could be even a facade contractor. So someone has to spend the time which is not being spent. So it will lead to a lot of time by the facade contractor. He will face at the site, not only the contractor or architect. So he has to revisit a lot of things at the site phase. Then we have an efficient design process. A lot of time spent on engineering in the pre-construction stage. So obviously the construction phase is much smoother. There is no major design or revisiting the design. Yeah. So we have engineers. So we are not lawyers. So we need design. So the design, anybody can understand better rather than somebody can say, I have a pile of documents, we have a 300-page document, this standard, international standard, everything is there, so we can easily run with those standards and reports. It doesn't work. Of course, I don't say we don't need this, we need this and this, but we need a design. So a contractor or anybody from gaming point of view can understand those details. So the design intention should be given in a way, some kind of a design, engineering design. So there are possible scenarios what will face the project as a contractor face challenges is architectural structural drawing is it integrated? Is architectural drawing is converted into structural system? It is not just a drawing a glass line or cladding line where it is division. So you are going to the structural system of the structure. So the contractor can understand what is the structure involved, how it is proposed as a design intent, how is it supported to the main structure. These are work there. So it is not like after the facade contractor on board he is going to look at the doors, where is this design, how do I do it. So this could help the contractor to understand the structural scheme better. And then what we see the simplified spec, I will say this is a simplified spec the facade contractor can do because we only have like a couple of weeks to put the price together when you are in the tender stage. You don't have a lot of time to do detailed engineering check, but there is opportunity all these designs can be done in a much earlier stage. So a lot of the time the contractor is going on some assumptions. Like this is a typical example if you have a triple height lobby where the structure is too tall. Often the contractor will assume that if a structure is given by somebody else, maybe it's a rigid. But when he started working, he will realize the structure, everything has to move. The structure is moving. When you know the main structure is moving, there's a huge impact on the steel work. All the design assumptions will go, maybe the sizes has to be revisited. So this is one of the examples of structure steel is not integrated. So then there are many other things from architectural point of view. It is functionally defined. There are different types of building, especially the doors and functional things, a special requirement is critical. There is a door size is mentioned, is captured in architectural drawing or in the engineering drawing or consultant drawing, what are the pre-conception drawings. If you list all of this, there are typical projects like the public buildings and some hotel projects, infrastructure projects, these things will drive the cost. Detail is not there, the door size is not there, maybe something the door is showing 4-meter door, the contractor has no idea he is using a typical door. So the functional requirement is not captured. And then drawing lines, the facade drawings are important. The drawings sometimes driving the cost. The architect has given some scheme, but the joints not clear, whether you use 1 meter panel, 2 meter panel, everything driven by the craft. So these joints are transferred and done better, the contractor can price it better. So this is listed and then at the end, after the award, if the architect saying, I don't want too many joints, I want less joints, there's a huge cost impact. The contractor cannot absorb. So what is called design, essential design implementation? So if I put broadly, you have a modulations, we have seen it. Define the joints, what is the modulation? Functions, define the function, any special requirement, anything specific to the project. It is better explicitly mentioned rather than asking the contractor, you have to this code, you have to that guide. So it's better to have something in the design. Materials, so we have a material of different performance, high, low carbon. There are various different materials is mentioned. Finishing, so you have different kinds of finishing which they can give warranty for 30 years, 20 years, 10 years. What sort of warranty is required? So basically starting with the setting out. So the first setting out as a primary driving factor for any contractor. Mostly a lot of the project happening once contractor awarded or post-tender, he's starting modelization, he's doing the whole building evaluation, then he's finding out sizes are not resolved. So actually these are the primary things that could have been resolved in the pre-construction stage, not just a local parcel, 2-grid, 3-grid. So it's better to resolve them on a complete course, you know where the corner panels, what is the size of the corner panel, everything is there resolved. The contractor like this there, he can test it properly. Like a key engineering structural arrangement. So how the structure is integrated to the main structure, where is the support is given, if the structure is there or something is missing. So this could be a better understanding for the contractor, so you know the size is given is going to work. And he's going to get this as a structural arrangement. So you don't have to do the design again after a work. So it's like sometimes you have architectural structures, so you have to integrate with architecture with the main structures. So these are the primary things. It helps the contractor to understand better the design intent, the frame, especially the structural framing size. The structural framing size is difficult for contractor can do accurately within the 2-3 weeks time he has for pricing. Design detail, even though sometimes very small, like a canopy, structure, the design element is small, maybe the project, that element is very small. But it helps the contractor to get a more comfortable, confident, I'm going to execute like this, so I have a best on your project. The detail, out of the detail, we have some architectural sections. It doesn't show structure section, architectural sections where we capture for architecture. So someone has to tie the architectural structures together, obviously as to be facade engineers. So when we detail this, you need to look up, don't miss the key component like a secondary bracket, substructure, so the contractor can understand. So because contractor is going to price the section with the glass thing, maybe he will not price with the bracketing. Because maybe the contractor is supporting directly to the concrete. So just a classic example. A lot of substructures. So we know the cladding, but the cladding needs some supporting. Sometimes the cladding is close to the building, maybe not much structure is needed. If it's going for other building, then there should be a lot of substructures. So it will be on the main contractor scope. So it's mostly on the facade contractor scope. It's very difficult for the contractor to estimate all this quantity with the given few weeks time of freestyle pricing. Like a double height. So double height often is mixed with on the pre-construction stage. Just to see the typical floors, I do the ground floor, typical floor, and then my ground floor. There are multiple areas. Double height, how is going to capture this work? Is it cladded or exposed? So there should be some more clarity. Interfacing key details. So some details are very difficult to just rely on the specification or airport. So there should be some indication of we do the field on both sides or a single sider. It is not the standard detail. It depends on what is the performance, is it exposure or what is the risk of weatherproofing. So it is better to have this kind of design attention. And everything costs money. So contractor can say, I can do with the one layer, so why are you asking me to double layer? So there should be design intention should be clear. And based on building tolerances, there are different systems. Sometimes we work on a window system, we can assume like 8 mm in points there. Maybe it is not workable for some locations. So the contractor is not going to price your giant detail into the out of tolerance or the structure supposed to be somewhere, maybe it's deviation. So there are some guidance if you give, it will help the contractor to price and understand the project better. Then I come to glass. So glass is one of the complex things in the facade where the price is highly varying because of different process. There are so many things. In general, what we can see, the laminated glass, there are a lot of price variation due to the PVB interlayer glass method. IGA has some different specifications. Fabrication storage, big thing, especially for a fabricator. Someone has 30 or 40 years in the industry, will be different. Some processes have 5-10 years to process differently. And the special glasses, these days we have curved glass, jumbo glass, or modern architecture. So this exercise is an important exercise. Sometimes it's just carried over to the construction phase. I think there should be some good groundwork to be done in a pre-construction stage, so glass is not becoming a key blocking for the concrete. So like not all the curved glass can be coated, so one has to check this in the pre-tender stage because a lot of buildings follow curved glass. So the many situations happen that curved glass will be entirely different. So that will upset the architect. So the architect will say, you didn't tell me this before in the design stage. So it has to be mindful. And now can we deal with jumbo glasses, especially the jumbo glasses, the combination makeup is very different from supplier to supplier. So if you just price this comparison in the tender stage, it's very difficult because a contractor, if they don't have the benchmark comparison in the pricing, how the contractor, each one will have a different proposal. If you go to supplier one, they price it differently because maybe he's more experienced. He uses lesser glass thickness, he uses a lesser PVB. Some more processors, they're not well experienced, they go for a higher interior, higher thickness. So the price is drastically varying. So unless there is this exercise not done, the contractor cannot be in one benchmark comparison. Just touch base some of the projects we have worked. Pan Pacific is a large complex project we have worked with architect Nung. The challenges of this project is all balcony details. So there are a lot of different balcony details, and the system is bespoke system with integrated sliding door onto the curtain wall in the textile room, done by contractor AD. And the complexities come from the various different balconies. We have 5 curved balconies, and it has all sorts of detail, has curved glazing or a straight balconies. We have detail which is going and junction with the guest room floor. And everything, in a way, is detailed out better. The contractor can understand the complexity of the project. If you just do a one section, he cannot understand. So this makes him to better understand the challenges for the project. It was having an integrated sliding door with a track and bespoke system. It has a very high acoustic requirements. So some of the guest rooms is actually like 55 decibel STC. So when we look at 55 STC means that there's a hardware where it's going to work. Something design has been done before, so in the site phase it was not too much of R&D we have to do. With other projects in power in Cambodia, we are working quite regularly for one of the clients. It has a lot of LED facades. It has a huge media screen. Each of the screen is about 16 meter by 16 meter media screen. And the project has a small little feature, but even you just to break the curtain wall with a small feature, do look small, simple, but it creates a lot of complexity for the detailing. So we can show the contractor it's not that complex. Your panels are uniform. You can go for mass production. So this gives the confidence to the contractors. Triple-plate lobby where using vertical space like horizontal. So the space size is being given easy for contractor to implement. Lighting details, so this lighting is going simpler and better, so it's integrated better. So there's other projects, my last projects I will finish with this, is using a jumbo glass. So the typical glass is 4.2 meters, and the non-typical glass is 5.5 meters. So the whole project is using a jumbo glass. It's about 25,000 square meter, everything is a jumbo glass. Where we have done a lot of pre-tender exercise on this project. We make sure the glass is, the makeup is right, so it's not relying on contractors proposing different build-up. And because of there is no intermediate time, the coordinate and interface knowledge become critical. So we need to do the detail properly where the cladding has like 15 offset. This is all detailed done so the contractor can understand. And engineering is given to support the design intent like monies. Because the top panel for 3.5 without any intermediate, the buckling is become critical. So that makes contractor some assumptions. So we have given some design intention how the bucketing system should work. And the project has a nice interesting electrified curve skylight was there. So we did geometric of this and we have optimized. Each of these using one panel is a flat panel, it's not curved. Around 200 by 1600 panel, what you see in the 3D model and you see all the panel is one unique panel. It's not bent flat panel. Everything is one panel used for the whole project except the perimeter is non-typical. Yeah. So this is very fast. Last project we are just showing here is in the design construction stage. The project has a huge skill. So we need to do some pre-design exercise where the skill can be bendable, which is about 300 by 300 skill. So the contractor has demonstrated this doable by the client because all the corner has this curve in our system. So conclusion for this is key to design efficiency because we all have to work with limited resource, design skill, more efficient is well resource pre-construction design. It helps everyone, contractor, architect, consultant, client. Procurement, contractor well aware of challenges, so we are not giving a blind spot for the contractor. Design validation, so we are not starting all over the design at the second stage. And there's a good chance the contractor can focus on this project, logistics, and more other challenges just to leave the design as so you don't have to continue on the design stage. Thank you.
Thank you, Rajan, for sharing those incredible insights from the contractor side and how to make those processes seamless and efficient. Can we please welcome our next speaker on stage, Mr. Alexander Han from Jangho.
I'm here. Let me briefly introduce myself. I'm Rajan Han, CTO of Jangho Intelligent Materials. Without further ado, let me direct your attention to our presentation. The presentation is composed by 4 divisions: BIP module, about Jangho Pavilion, BIP system solution, BIP technology device and feature projects. PA significantly enhance the beauty of building, like the meaning of our company. So, also is the title of my presentation. First of all, I think we have seen solar panel levels, so when we see with the tall glass on the background, assembly with the frames, welding, the sensors and the cables, fixed connector, we got a photovoltaic module. Looking at this building, with it, the first glass, most of people will say it's a new cladding. But in fact, it's a golden photovoltaic module is a cladding material. Its color and finish are exactly the same as those of traditional aluminum cladding. Unlike the standard module, the backside of this building is also made by tempered glass. We use framing the tempered glass as the back panel and also the tall glass. And the usual thick glass we can use up to 15 millimeter glass is as the tower and the back. That means this one is much thicker than the aluminum panel.
The advantage of this is we can have a much lighter surface compared to the main panel and the bigger size. This project is Beijing Expo camera Pavilion. Moreover, the CCTV system camera module was 40% of cell coverage are integrated with the skylight and all the color contribute to the building module, and not only enhance the building's time, but also make overall appearance more harmonious. As you can see, there is a wide variety of colors available, and we can achieve almost all the colors that exist on this planet while maintaining the high electricity generation efficiency. There may be a question, what about the efficiency? Well, it highly depends on the color choice. The key of the color technology is to reflect the light in specific spectrum. And when we perceive a specific color, the light of the color, other spectrum pass through the color is filled to the cells that can generate electricity. So it means if all the light comes in, we will have the black color, it's most efficient color, and also it's the most cost-efficient color. This is that we see in Beijing, it's Beijing Workers' Stadium. In the ring of the roof, we use the golden color modules, and we only submit the first one different golden color to architect, then we have approved, and then we do the project. And we have thousands of different golden colors in this language. What I want to say is we can produce all the colors depending on the architecture requirement. Any color we want, we can produce. Each of the colors, we can see not the word not just the colors, but also the patterns, textures, and finishes. And all of this are examples of what we can achieve with building modules. This will ensure the consistency of the texture and color of the building envelope. And of course, all of this can be customized. For many of our projects, the metal finish with a gray color can match the main panel perfectly, and a lot of projects do that. And there is the other kind of model. You can see the silver color is printed on the PV cells as a connector. The cells are made with a fine silver colored lines with some of the regular silver fine ribbons in the black cells. These ribbons add more layers and textures to the module. From a distance, the fine ribbons are not visible, creating a seamless effect, just like the ribbon can observe on the building on the left side. So from the close distance, the ribbon can be seen, reveal more layers and details. And not the photo material, all of them are always opaque. Usually, the gap between the cells is 1 to 2 millimeters. If we increase the gap to an uncorrected cells, we can get transparent modules, as shown in the above photos. It can significantly reduce the ceiling coefficient of the metal roof and effectively reduce the load on the air conditioning system. You can design different style arrangements to meet the light requirement of the building. The color of the module, the color of the backside of the cell is blue color. That can match the light blue of the sky. And also, the size of the monochromatic silicon is facial cell. It means the light from back of the cell also can generate electricity. So the light like this, we can have additional 5 to 20% additional electricity generated. For the transparent model, it's just monochromatic silicon. We also have the Siew technology, CUTE. We have different colors, have different appearance. This can use as woolen glass, normally use as scrap. This is the combination between the monochromatic silicon and the CUTE. Normally, the monochromatic is more efficient and cheaper, and also is lighter, thinner, and more popular. But CUTE is more popular for woolen glass and scrap. Also, our product we have several certification for our product. It means our product can sell in European Union all around the world. And for the Singapore market, we provide COB applications. Hopefully, we will have the certification in 2 months. And also, we have the classes and evaluation for fire resistance testing. We have 20,000 square meter factory made from China, which can produce the product that meet building requirements. Other equipment and custom-made can switch different specific products very quickly and have the capacity of 1 million square meter per year and patent-free workshop. Not only color and texture, also we can custom-make the size, shape, also the alignment of the size. It's unlimited. And also, the biggest size we can produce is 1.1 meter by 8 meter. The safety is a matter of 0 and 1. Safety is first, then is attractive, the last one is power generation. Photovoltaic models for the building should be made fully tempered glass, and the minimum thickness will be 3.2 millimeter, because the minimum 2 millimeter is too thin for fully tempered. And for aluminum in Singapore, normally the 5 millimeter fully tempered is the minimum. And the physics standard of styrofoam is much lower than the building standard. If you use some standards or even the attachment of building photovoltaic, that will bring higher safety risk compared with the styrofoam. So we should take more care about the safety of the photovoltaic modules and the photovoltaic system used for building. And this is let me introduce our group. Jangho is known as Jangho Convener, the biggest convener company in the world. And Jangho Convener is a sister company of Jangho PA. We belong to the same group. And we have most of our business is from the other convener company. So we have a lot of partners with the other convener inside the Jangho. Imagine if you are a convener company, you have a product and with some photovoltaic system inside. How can you do that? Not only photovoltaic modules, you need a full solution. You need cables, electricians, designs and information what cables and everything. So that's what we can do. We have the full solution, for example, in the one area, we can do the compatibility model, replace the IDU and also the backpan, like this. And basically, no calculation is in China. In the middle area, we use the low IDU, but in the standard area, it's PA models. The color and appearance is not perfectly. And this now is the other product. You can see in the right side, we have all the cables and the terminal numbers with the preliminary cost of holes, and we work with the terminal company. We design our system together with the terminal system. And with that product, we use the models in the standard area. And also, it's a very good product you can use for the cladding and replace the room cladding, replace the stone cladding, and for the room system also. This product we finished in Beijing. It looks very nice. And the most important is we design our system together with the terminal company. We use the transform as the cable tree. It means it's much easier for the electricity installation, and the system is perfectly integrated photovoltaic with terminal. This for the terminal side, we make other cables come through the transformer and the magnets, and we also use the rubber ring to protect the cable. And this is our system of the Pavilion system. And there's a video show. I passed the time something else, okay? We pass through all the type, water cabinets, and the slashers. And the system is a ceiling system. We use this system for a lot of products, at least. And also this product, we use it for the service engine. And also the Supahat. This product also the photovoltaic Supahat. And not only Supahat, for the roof, we can use also for the stud. We can use the photovoltaic by steel structures that can cover the cables and pipes and everything, make a beautiful surface of the roof. If we have some equipment, with the ventilation, we can use the models like this. And also for the pipe piece of terminal, when we are familiar with this, we can replace the aluminum panel with the model. And also for the canopy. The panel canopy not always black, that can be patterned. And also we can hide all the cables inside of the frame. You can't see any cable. And also we can have some consulting solutions. And this our system from models to the water, then turn to AC, to cabinet, and the cables. And we can integrate our cables with the cable structure. And the maintenance consideration with our system. And our design and capacity, and our product. It's our product, okay. And use cladding. It's a Hong Kong product. And we have our business all around the world, in China, South East, and the Middle East. And also Australia. Okay? Thank you. Towards the world of photovoltaic, the scale, number of sizes, shapes, textures, patterns become. Thank you for that. If you need more information, I think I've seen the book, Jangho outside. Please feel free to approach Alex for more information. Next, we
all of these architects. Good afternoon, everyone. Before lunch, I hope we get a bit of energy going on still. So my name is Michele Pasca Magliano. I've been working with the head architects for 21 years this year. I've been coming to Singapore actually for 18 years, and several projects here in the region. I represent a very large firm. With my colleague Maria here today with us. We have about 450 architects from pretty much most nationalities around the world. This is us having our annual trip. We'd like to celebrate all together when we complete the project. As we heard from some of the presentations this morning, some of the projects are a real fit in engineering and design and construction, so we fly the whole office and get together, and that's how we learn about what we do, we learn from each other, and we see our product. We operate from London. The design team is 100% London-based. We design all the projects there because we feel it's important. We learn from each other, and we can really compare each and every project we do, but then we deliver projects globally. So we have a network of regional offices, and we cover pretty much any discipline which is touched by design. A lot of the projects we do tend to be fairly large scale, visible from the air, and there's a lot of complexity and a lot of simplicity in the projects we do. And we like this idea that we push innovation in the construction industry. Construction industry is something that it's going through technological innovation, but also we like to put innovation through design and bring in challenges to design. And one of the typical challenges is whether we can bend or curve our construction materials, but there's much more to it. And there's good reasons to do it, and I'll try to take you through the reasons why we try to create a built environment that ultimately work different from the cities of today. And then one source of inspiration is Earth and Mother Nature, and there's a very simple reason for it. Natural systems are able to organize very complex ecosystems in a seamless, natural, and beautiful way, with a variety of colors, just responding to gravity and light, and just the need for survival. And in a way, we as people, we do the same. We interact, we get together, we find shelter. So we feel that architecture ultimately should produce the cities of tomorrow, thinking about how the world is organized. And we are able to interact with nature, we are able to manipulate nature, and we are able to do it in a very beautiful way. Somehow, we feel that along the path of architectural evolution, some of the capacities of understanding topology and geology have been lost, and this has produced a kind of lack of understanding of how we used to build cities in the past. So you can see here, sitting in southern Italy, where architecture actually emphasizes nature and doesn't destroy. And settlements which are really built on the hills in a very organic way, and the interaction between those and the living systems actually can be quite interesting as well. And how do we use architecture as a new layer of natural systems, as a new layer on Earth, and how do we use that to organize our own societies today? So we devised a series of softwares, and we actually pulled in from character animation software, some different modeling tools and techniques, the ability to actually manipulate geometry in a very different way. And this geometry has no scale, has no dimension, it's just pure form, and that's what we're really interested in. And every time we get a new project, the challenge is how do we then combine the client needs and the client brief with a kind of broader ambition to rejuvenate and to inspire the generation of tomorrow. We do that, and this is some of the build projects, build projects around the world. So as I said earlier, we do that across multiple scales, multiple building topologies from airports to museums to towers. But there's just one fundamental principle, which is every project has a recipe. And what we have to come up with when we study any new brief is thinking which are the ingredients for that new recipe that we have to come up. So here you can see some studies for a tower, and it's not a single tower that we will design. We will design a series of options, a series of iterations. We look at the structural performance and the facade performance to then decide which is ultimately the best possible solution for that specific site. This design is a process. It's not something that gets done in day one and just accepted as a final product, but it's something that we develop as architects, then we bring engineers on board, and our clients contribute to as well. It all gets done here in our London HQs. As a people business, our main investment is around staff, ourselves. It's a company wholly owned by ourselves, so we have no one telling us what to do. We know what we have to do, and we're very self-driven towards innovation. We now created a new kind of robotic department. But really, our daily life is this. It's a mouse, headphones, laptop, building models, and most importantly, we do something that we're doing with you today, which is internal presentation. So we look at each other's work, we comment to each other's work, and we are the harshest critics. And I have to say, it's always harder to satisfy our own colleagues than satisfying the world out there, because these would be the people which are the most experienced in the proof and design we do, and the hardest criticism is always internal. We have devised a kind of computational group called Kyoob, which has no involvement in real projects, but all they're looking at is how we create new tools to innovate the construction industry. So anything from robotic forming of metal sheets, hot wire cutting of foam blocks to create concrete for molds, all the way down to kind of 3D painting. And ultimately, nowadays, we started to look at game technology and how game technology can actually form not only the design and presentation, but also the interaction with the developers, the buyers, and ultimately having a design project, which is a project in itself, where the buyers can actually change the final look of the building. So these are all tools that then come back into our kind of toolbox that we can use for the right project. When we get the project, there are some key features that combine all of our buildings. One key element would be volumetric articulation. We try to kind of express to the outside of the building what's happening on the inside in a kind of seamless and continuous way, by thinking about different things happening at different heights of the building, especially the structural system, having additional cross spacing towards the base and more vertical structure on the higher elements of the tower where that's not needed. A lot of attention is put on the way buildings touch the ground, and obviously that's where you kind of, as a person, you can touch the building, you come close to it, and you can then expand the ground floor to give better facilities. Connections to transportation systems is something that we usually get pulled into when we do the large projects. There's always metro stations, underground garages. So how do we create a seamless entrance from the basement of the building? And the idea that internal theaters become a place for communication. So they're not just a place where you actually have a safety escape or something hidden away, but it's really a place where different levels of the building can interact with each other, people can meet casually and can express to each other what's going on, the activation of the project itself. That's also done through vaults. There are internal vaults, vertical atriums, this building in Beijing, which is a 200-meter tall atrium connected to towers, and then expressing the atrium to the outside of the building, so actually vaults and perforation across the building itself. I'll take you through a number of projects, and some of us are reminding me I gave actually a Zak presentation here about 7 years ago, so I hope you will find this refreshing and new. I added a lot of the new projects we're working on, but I always like to start with one more, which is a project which was getting completed when I joined the office in 2004. It's actually part of the overall master plan is still getting built, and it was really this intuition that a new master plan could be a piece of land, and a new piece of Singapore as a kind of additional natural system. So buildings, they can become distinct and different. Bold is not a grid, but it's a flexible grid. And every corner of the site actually changes the way you look at it. Every building will have a different elevation, a different perspective, a different angle as you kind of navigate through the project. And then we started working with this idea of the connections between buildings. So you don't always have to come down to the ground to actually shift from one office block to another. One of the key projects is the Heavy Rail Center in Baku, as I mentioned. And here it's actually a fairly complex program. We have a theater, we have a library, we have a museum, and then we wanted to kind of simplify that. So we actually placed a very simple facade system over it all, kind of unifying over these different programmatic elements, and then pulling the building up to unveil to the outside some of the activities and activation of the building itself. You will notice there is a lot of consistency in color and shapes and geometries, but actually we're looking at a series of different materials. We have from marbles for the floors, we have GSC on the lower part of the facade, we have GFP for the roof, a lot of GOG on the interior, so it's a lot of different materials, but what's really kind of running the whole project is the geometry and the design integration. Somebody earlier was talking about the importance of drawings. I think for us, the importance of drawing was actually demonstrating that all the technical installation is done seamlessly resolved in these kind of lines where you have light, where you have air conditioning, which change the material into timber for the theater, and then it turns so you have a much warmer atmosphere, again, full integration of all the technical installations of the project itself. Similar kind of concept for our transport museum in Glasgow, which is a zinc building, again with a GRP interior, with a high level of coordination, everything, all the joints are expressed. We don't try to hide them, we try to kind of showcase the outside how the building is put together and built. And in this case, it's a building, it's the CAPTEC, the King Abdullah Petroleum Research Center for Saudi Aramco in Riyadh, in Saudi, and we wanted to create a building which was a LEED Platinum project in the middle of the desert. It was actually the first LEED Platinum project built in Saudi. So we actually ended up using geometry, working with engineers and the sustainability team to kind of think about how to shelter the building, how to have very solid facades, and then all these internal atriums where the air is naturally cooler than the desert outside. So we actually start from a kind of better starting point. A lot of the circulation is actually outdoor, so we can make use of natural ventilation, and then the inside becomes this kind of very calm reflection spaces on the inside of the building itself. There's a little mosque that we have there with all the lights and the structural system kind of integrated in this garden. Over from the ad, we actually built a metro station. This was the first kind of metro system built for Saudi. So there was a real challenge to try and embrace also culturally, showcasing what a new transportation system can do for a city, allowing people to kind of move from one side to another. So the main design inspiration was really velocity and acceleration of the trains coming in and out. It's a fairly complex station, it's 4 levels. We have 2 train lines going in there. The facade provides light to the inside, and in the kind of the expression on the inside, this is a finished picture where we have this kind of combination of this high-performance JC and metal cladding for the interiors. This project was a real experiment in terms of process change in terms of BIM. So full integration, not only of structure and cladding, but then all the EP systems, the interior finishes, all the way down to kind of extracting details for the construction. So we actually been working with Baxter to deliver this very unique project. A project in Qatar is the Rajan Stadium for the FIFA 2020 World Cup. In this case, It was inspiration from sails, because we did a stadium, I just showed you one slide. We did a stadium that we close during the day to kind of shade the grass, make sure it doesn't get too hot, and then open it up at night and have additional supplemental ventilation for the pitch so it will be comfortable enough for the players to play football. The Bia HQ in Sharjah is just north of Dubai. In this case, the building itself becomes a shelter again in the desert. So we kind of pull in the gears towards the central building, and then the only glass is actually facing the north. But then once you go inside, it's kind of calm and reflective space with this exposed concrete, which actually is a structure of the roof. And on the inside, we coordinated with lighting and the extraction of the hot air at the top, whereas we're supplementing kind of cool air from the bottom. Again, GFC staircase, and then changing material to timber when you go to the executive offices. This is a small project much closer to home in Oxford, where we actually got an award for the best conservation building from IRBA. I was very proud of getting this award and thinking that such a modern building in such an historic context could be seen as well responsive to the environment, because it really distincts itself from the old medieval buildings, but then it enhances them and makes them look more precious and has these colors that actually reflect. This is university buildings that the two departments of mathematics and economics in Vienna, and again we use this idea of the common atrium and the circulation space to create a space where students from different faculties and professors can kind of come together into one space. This is actually recently completed in Peng, the Maastricht train station. It's actually an office building right next to the train station, but one of the challenges is really having the train line kind of passing through it, so we push the building to cantilever towards its axis and design some interior spaces as well. Our very first project built in China is the Guangzhou Opera House. We said we have two pebbles along the river, kind of a black and a white building. They became a kind of dark gray, lighter gray, because the client had already built the mountains to make the granite from, so we didn't really get to choose the climate that much, but very good. We could play around with this kind of glazing, opening up the granite and kind of showcasing the interior, and then a full VIP interior for the concert hall, where we had to coordinate all the acoustic and lighting systems, the full effects, and on the left-hand side you can see some of the rehearsal rooms. That's a very controversial building. I always like to show it. It's a project that we did for Seoul, where we had all the local architects up in arms against us, because it didn't look anything Korean. And surprisingly enough, from being a building that was not Korean, it actually became the symbol of the city. So if you go to Seoul now, you see maps, downtown, that's the only building you see on the map. Everyone knows where to go. It really became the kind of the center. So sometimes you also need to allow something different. And for us, that we actually define the future. Most of the times with the same buildings in our current exercise, that doesn't look so hard, doesn't look good, doesn't look local, or give us some trust because we've done it before. And we know that we will create something very new, very unique, but we have to go around the journey together. We were able to actually drive a lot of innovation on the cladding system, so we used a kind of a flexible mode to convert this flat aluminum panels in this kind of curved facade panels. That was the time it was built. It was the world's largest airport, the Beijing terminal, 50 million passengers per year. It looks like a very simple roof. It's actually a very complex roof, because there is no structure other than these mega columns that act as kind of natural wayfinding and circulation for the project. They kind of take you from the check-in desks towards the gates, and then as you return, they take you straight into immigration passport control. A project done in Beijing, the one in Soho project done with a very limited budget, so all the glass is actually flat, although it looks curved, and we just bent aluminum panels in plan, and you get this very kind of seamless curve building. A lot of emphasis on the exterior landscape and the kind of landscape. Moving back to North America, this is a project in Miami where we actually use the GSC columns as cladding, the distinction between the units and the apartments, they define the kind of the balcony edges, and then the columns themselves become structured. They get infilled with the stone reinforcement, and they become part of the building structure. Project that some of you may know here in Singapore, Beijing, which was a lot of coordination with kind of the unit layouts, the balconies, and the speakers columns that define the space of the common facilities on the ground. Again, a project which was done in Milan with flat glass that looks fairly curved. That's all a core bent exercise in glass on one of the largest projects we did. And just the corner piece of the glass is cylindrical element. A tower in Marseille, SPGA, and this is one of the first wide buildings that were built. This is the Magliano Hotel, the office in Dubai, which was building initially designed as an office building, which then, after the GSC, the client came back to us and asked us to convert it into a hotel. So we had a second commission to actually design some of the key spaces, the lobby, the check-ins, and even some of the rooms. I recently completed this project in Macau. It's a multi-hotel. This is actually a picture when the site was actually almost completed. All the exoskeleton you see is actually a steel structure with aluminum cladding. And then what is interesting is that then the kind of geometry of the outside becomes even more complex as you move inside of the building, taking from marble to this kind of aluminum facades and to steel facades, and then looking up into some of these walls of the tower. Bespoke lifts taking us up, so you have panoramic lifts which are internalized, and from the lift you see all the restaurants and all the activities of the building itself, and then at the very top there's a large pool that goes from facade to facade with some kind of skyvillas with their own private pools. The client was quite happy to give us 2 more towers nearby. It was actually a design that we originally did for a project here in Singapore, and then we kind of, through a series of iterations, kind of became a project in Macau. This is the largest project I personally followed, and the largest project we built ever. It's called the Unicorn Island in Chengdu. There used to be a river kind of going straight towards this lake on the south of the city, and we kind of created this canal and created this island as a special economic zone. Some of the renderings of the initial design. So 1 million square meters, and you have to use kind of this idea of this very clear geometry of ellipses, and you will really use the facade to create excitement and diversity and distinction between one building and another. There's a large plaza that actually covers the road and takes us down to the 2D elements of the project. And then hotel, this building picture from last year, you can see that the 270-meter tower actually pretty much, I would say, halfway up in this picture. Some of the front buildings getting finished, some of the office buildings where these ellipses kind of collide, they kind of open up, and some of the more recent construction stops. We started off with this very first building, which was called the Startup, where they also have an exhibition about the overall master plan. And then you can see there's quite a playful game where the ellipses become part of the landscape. Sometimes they kind of link up. This ellipse is actually a bridge that is held over by 2 neighboring buildings, so you can actually get to see it from below. So in this particular project, because we have so many different heights and so many different angles to it, we have a series of facades. We see the roofs as facades as well. We have internal facades in the atrium. We have this kind of external landscape which wants to represent a different model for China, very green and a very large kind of Chinese aesthetic, and then obviously internal courtyards. These are some of the office buildings that we recently completed, always in the same complex, where we had a real limit on the budget for the cladding. We didn't have a lot of money, so we had to be quite specific in where we add the complexity. Again, all the glass is flat. The aluminum is single curved around the edge of the building, and we try to create differentiation with colors, with pattern, with expression, and with some gradients in special areas. As we were doing the Unicorn Island, we actually got competition for this science fiction museum. I was in Chengdu, and the premise here was that buildings had already a foundation, already built, and 12 months a big conference that we had to host. So they gave us basically a year to design and build, so we actually went in with a carbon contractor, already knew how to talk to them, how to provide them 25, so it was a kind of design to construction phase. You can see the quality of the aluminum, and then a very simple interior with this kind of large Kyoob, which is inclined pathway up to the conference level up here. Some of the projects now under construction on site. This one is in Shanghai, just along the river. It's the HQ for the CCP, China Energy Conservation and Protection Agency, in a very prime location. This is a project is in Guangzhou. It's a very large sport complex with a stadium, 18,000-seat arena. This kind of idea of opening up the stadium to the water to get the air and get the views back towards the city, using timber as some of the cladding elements in construction. And we've seen this project before. I just wanted to show you a quick few slides and maybe talk about the design of the Henderson. So this was a competition we were actually very proud of winning. It was a very unique design, really went all out. It was the top architects in the world competing against us. And then we got it, and we all agreed with the client, not only winning, but we would build this. So it quickly became an exercise of actually documenting the design. So it was all done in CATIA, the digital project, actually being able to kind of measure and design every single panel, document it, understand which one had to be curved, which one could be flat. Obviously, there is a lot of budget considerations coming into play. You'll be surprised, but we also have budgets for our projects, and understand which one, what is the deviation from the kind of the tolerances we will get, and literally building up as much details as possible in the design model so we could interface with the builder in a seamless way. A lot of mock-ups to actually, first of all, prove the concept, select the contractor, and then study some of the most complex details where the interfaces between the different systems were. Like in this case, an MEP floor with this kind of openings which were kind of cut out within the glass. And the finished picture in Hong Kong from end of last year, you can see the rooftop of the tower, and some of the views now becoming kind of a new icon for Hong Kong in terms of tower. Christoph has taken up 3 floors and is becoming a very one of the symbols of the new generation of Hong Kong, we hope. We recently started working on site for a project we did for Monte Carlo, Monaco, which is a refurbishment of a very expensive existing tower. We actually could not touch the structure. We had very rich tenants living there, so all we could do was really remove the balcony, remove the facade, and add the 3 levels at the top. And then we're doing some of the interior spaces as well. Project in Melbourne. We'll use them sunrise, and maybe just for a few slides of the science center. We went to site on Monday to see how the construction is progressing. We're still in the ground. This is at the Chinese Garden MRT stop here in Singapore. So it's about 50,000 square meters new museum for the science center that is going to relocate to this location. We have this idea of the bar, so we have this kind of 5 sticks for different programmatic elements of the museum. Again, a lot of emphasis on the facade. The facade is this kind of unifying system, but then we have this expression of the mega windows to be able to look into the museum from the outside and from the museum to look out into the lake and towards MRT. And then we have this grand kind of open space, this 80 meters bridge, kind of crossing across the main entrance of the MRT, which also becomes a kind of shelter, so a natural kind of shaded space from the heat and from the rain. We're also working on a very large project in Oman, in Muscat, redoing the whole corniche and the new marina. And project in Dubai, a high-end residential for the Dorchester collection. I hope I can do it in 40 seconds. Some villas in Papagayo, with again continuous geometry, materials to kind of showcase a different aesthetic to our kind of design capabilities and geometrical complexities. And then I was just the very last project out of the press. We won this in January this year, designed with Maria. It's a project that is in my hometown of Naples, southern Italy. It's a very non-descriptive kind of industrial area just right next to the main central station. And what we decided to do is take inspiration from the sailing boats, creating something that is very natural, kind of having this organic park that connects different parts of the city, and really trying to start to clean up some of the periphery or the suburban areas. The two towers are connected, again, connection to the public transportation system in the garage, and then from the towers, the views towards the volcano and the surrounding the ocean. And I will leave you to that. Sorry, 13 seconds late. Thank you very much. Thank you for the beautiful project. There's never a mistake in who the architect is when you look at a big project. It's just so beautifully sculpted, but at the same time always pushing the boundaries of what architecture forms can achieve. Thank you for that presentation. Next, we have a panel discussion, and for that panel discussion, let me welcome on stage Mr. Matthew, Director of Business Façade.
Good afternoon, everyone. Today I'm going to be talking about a very special project. Me and my colleagues are going to talk to you and perhaps introduce you to the Singapore Pavilion for the Osaka World Expo 2025. I would like to call on stage Kyoob and Züge. Kyoob is a young architect who was very intimately involved in the design of this pavilion, and Züge is more specialized in interior architecture, but I think all of us in this particular project did a bit of everything. Some of the architects get involved in the engineering, I got involved in the architectural design, Züge got involved in just about everything. So, couple of things here. We're going to have a panel discussion, but before that, we'll take a few minutes, all of us, to introduce you to the building, what it looks like, what it is, what was the design process, and then we'll have a bit more of a sort of a free discussion on our experiences and worries and years of toiling on this project to make it happen. All right, Kyoob will take it first on the design.
Thanks, Züge. So, good afternoon, everyone. Maybe we'll share a bit of a preview to our design before we dive into the details of the calendar and then issue phase during the construction process. So, yeah, I'm Kyoob and I'm doing HT. So, we are looking at the World Expo Pavilion 2025. So, the theme of this pavilion is design for society for our lives. So, we're actually very excited to everyone, it's going to open in one month's time actually. So in April, the grand opening will happen in Osaka. So the line of theme of the World Expo, we're going to go into the call to action listed in this more sustainable and better society by celebrating the power of dreams. So we share this simple journey began with big dreams and aspirations, but more importantly, having the courage to turn some of these dreams into reality. What actually will happen? Okay. Expo will take place in Osaka, and what's interesting is that the full photo is first created in Osaka in 1970. So in 2025, we're back in Osaka once more. So interestingly, both nations share remarkable synergy in the sense that while we're both small in size, we have big dreams and aspirations, and we work towards these dreams and aspirations. And as we embrace modernity and innovation, we are always rooted in culture and identity. So, the Singapore Pavilion seeks to build upon some of these shared values and invite the world dream together with us to bring a vision of a more progressive and borderless future in this nation. So, through telling this story, we seek an expression and identity that is uniquely Singapore, inspiring for Singaporeans and also recognizable by all. So the genesis of the design has inspiration from a little red dot, a kind of ideal and pride ingrained in the psyche of every Singaporean. This framing is synonymous with Singapore's spirit to strive big despite matters, and also we do a versatile with different forms, graphics, and even outlooks. So for the Expo, manifested as something three-dimensional, not just physical but also spatial and experiential. So beyond form, equally significantly, the rig also represents the collective aspiration and resilience of a dimension that I hope for a better future is not predetermined by our size. So the celebration of three themes for Expo 2025 happens in Hiroshima Island. It's a reclaimed land in Osaka. So we are looking at the left area over there, and next to us we have Bulgaria Pavilion and Netherlands Pavilion. So this the building roof is designed by Supahat. It's entire 2 kilometers long circumferential link. Yep. It's designed by the largest infrastructure actually in the world. But even like a world record here. So I'd like to in terms of what we expect to experience for our pavilions heritage. So the thing is that for this pavilion, we are staying by adjacent ones. So that also informs us in terms of how we can decide what is the main phase of a pavilion and what is the area of the even estate and resources. So in terms of views towards the pavilion, we have from the grand view above as well as from the ground level. So understanding different skills of appreciation, not just at the intricate door skills, but also taking one step back from this side-wide reading of the pavilion. That's quite interesting. So by day, you have this appreciation of this very tactile facade for the field, and by night, it brings in this almost authentic quality to it. So key components to this is about facade today. So what's interesting is that we break it down into different key components. We have the green sphere, which is the entire pavilion, and then contributing to it, we have green discs, and approximately 17,000 discs threaded onto the facade. The green state comprising, so in terms of singularity, we can use the facades to streamline and come to a few key components and languages we will adopt. So we have the disc as well as the clouds, where the disc is the first floor of the left side within. So components to it, we have a structure overlaid by FRP Peng. So this is the water stream way I'm telling this is what really makes it not a contaminator. And eventually when we have our disc cladded onto it, what's interesting is also how do we embrace this idea of having it look not so taut on the facade, while also embracing modularity, because it has to be constructed. And again, references that we drew that were also quite synergistic between both nations, the idea of Emma, well-wishing flux, where there's quite prevalent in Japan today. And different sizes of this that we adopt. So it's not exactly entirely randomized as what we would see or perceive on the facade. We adopted 3 different sizes, and these are computationally communicated across the entire field. This was a video shared in a press release. Yeah. Talk about sustainability.
Thank you, Convener. So beyond the aesthetic outlook and ethos, the design of the pavilion also conveys some of those aspirations towards inclusivity and, of course, a better and sustainable future. And to achieve that, we achieve that using the 4 R's, which is, of course, renew using BIPVs, reduce by using more responsible systems like drip irrigation, which saves about 60% of water use for irrigation. By using modular components in the architecture and the facade, as what Christoph explained earlier, we actually make these systems efficient for assembly as well as disassembly so that they may be reused post-Expo. Components may be reused post-Expo. And of course, lastly, the recycled discs that envelop the facade. We'll go a little bit more into the details of all of these as we break into the panel discussion. Very quickly, I wanted to show you the plans. Two main reasons for doing this. One being to show you that this is a very hard-working site. It's only a footprint of about 1,000 square meters, but we've been able to carve out 3 floors, about 1,700 over square meters of GFA, with spaces that are programmatically and spatially diverse. And the second reason I wanted to show you the plans is because at every part of your journey through the pavilion, whether you're outside, up in the queuing ramps, or within the pavilion, within the experiential zones, or within different parts of the pavilion, the visitor has various relationships with the actual green sphere. So at every point through the journey, there is an interaction and a relationship between the sphere, whether you're entering or exiting the sphere or viewing around it. Okay. So just to share a quick fun fact, the Singapore Pavilion was actually the first international pavilion to complete its architectural style in November 2024 after just 10.5 months. And in October last year, this image of an aerial view in the Expo site was shared, where you can see the little red dot shining there. And if we go a little bit more human scale down to the ring bridge that you see, we can actually slowly see how our vision turned into reality. This was a photograph shared by Siew himself. And as we go further in the discussion, we will see a lot more photographs and understand the processes of how we were able to achieve this. So now I'll hand it over to Matthew. Thank you.
Thank you. A lot of coverage, a lot of tweets, a lot of Instagrams on this pavilion. I just want to touch on the process. How did we come to this result? A lot of sweat and tears for everyone over the last 2 years. We used a lot of digital tools to make this happen, and also a lot of physical and tactile processes. Being was a big part of it. This was a requirement by the organizers of the Expo. We had to document everything in Zoom. And this was also a key to coordinating with the authorities, with the organizers, with the client in Singapore, with the local architects in Japan. So all this was done in a very integrated manner through BIM. The structure was one of the key aspects, really quite complex. It's just a sphere, really, but it's quite difficult to do because one, we have to deal with the local conditions, which involve seismic activity, which involve typhoons, potentially typhoon conditions. This building is there for 6 months, but we can't be sure that there won't be a typhoon rise up there. Particularly when openings, obviously we want people to go in and visit the pavilion, and making these openings in a sphere is something that we can do tremendously, and the base was absolutely tiny, so all this contributed to making the structure quite complex to design in the end. It's much more than a sphere in the end. In terms of the facade, we started with a very simple script. We generated the shell with Rhino and Grasshopper, and then built the disc over that, the openings, the supports, and this is just a small part of the script. Ultimately, the lighting was integrated. Everything actually was built into the script. And this was used to quickly generate solutions. And initially, we had 40,000 lists. Through optimizing these scripts, we brought it down to 17,000, like what Kash mentioned. So quite an interesting outcome where we actually generated value without taking away from the appearance of the pavilion itself. We managed to also minimize the number of emissions of occupants, which are the main skin of the building. And also, as I mentioned, we integrated the lighting that you see here. So we developed a version of the slices of the party with the lighting fittings in there. As I mentioned, we developed the fixing methods, the brackets, the openings around the doors, and all that, all in the Rhino script, all that optimization, the sizes, we had countless variations of colors, sizes, mixes, percentages of different sizes. We also had a special CFD done to prove to the organizers that the gifts will not fly off in the typhoon. So we actually ran a real simulation on desktop. We didn't have time to do a real winter test, and anyway, testing the pressure and see if this is literally not possible. The lighting was also simulated to make sure that the outcome would be what we expect. Various combinations of colors of the disc, the backside of the disc, how they reflected the light and how they bounced the light in. Then we did a bunch of 3D printed prototypes, something to go quite quickly, make sure that the appearance was okay, the mix of disc sizes and all that was okay. It was too fine to integrate the light from side, but as a quick prototype, this was fine. And then we started doing real size mock-up. So this was full scale. You can see that the little brackets here, or the little pegs as we call them, to fix the disc were all built in. And this was one of the advantages of doing it in GRP. We started with multiple different types of disc, colors of disc. We were not entirely happy with it. And so we built more mock-ups until the final outcome was what we wanted, what the client was happy with, what the whole team was happy with. And with this introduction, it is a pretty long introduction, I'd like to just flash some images that they will, in theory, sort of rotate on their own and show you the steps from the beginning, groundbreaking, all the way to the completed pavilion. So that will be there, and in the meantime, we're very fast, not obstruct your view. I just want to sort of kick things off maybe with Christy, who was talking about sustainability and how this is at the very core of what the organizers and the clients stand for and what we wanted to achieve. And perhaps you can tell us a little bit more on that aspect when it comes to the discs, the shells, material choices, and what can you tell us about that?
Sure. Of course, during the World Expo, there were also, sustainable development goals that we had to attain, and sustainability was very much at the forefront of, the design process, and even in terms of choosing materials, for example. So before we arrived at recycled aluminum, we were also looking at, recycled plastics, but there were, of course, constraints with not just the weather and the heat, but also, as Matthew mentioned earlier, all the wind testings that had to be done. So very quickly we went from, we had to think about what were the appropriate materials to use, considering all of those things. So even, for instance, after we arrived at recycled aluminum, we were thinking about maybe, say, 95% recycled aluminum, where, because aluminum is an infinitely recyclable product, essentially, and every time you recycling aluminum basically cuts down about 90 to 95% of the energy used. But very quickly we realized that even sourcing something, simple as post-consumer recycled aluminum was challenging. So we arrived at about 70% post-consumer recycled content in the discs that we have. And yes, that's where we were at the recycled aluminum process.
A lot of good intentions. We tried hard, but it was a very hard work to actually source this material. Yes. And maybe, I don't know if guys can contribute on that front as well, maybe talking about that's the beginning of the project. This is supposed to be up for maybe 6 months. So we're looking at a building that will be up from April to October. At the end, maybe you can tell us what will happen to the sphere. Okay, we have some very famous examples of the Eiffel Tower that 125 years old is still there, but this one will only be 6 months.
Yeah, so I will expand further on the sustainability aspect of this consideration, especially if you're understanding that this pavilion is temporary, it's ephemeral, within there for 6 months. So beyond just materiality, in terms of construction techniques as well, for our steel structures especially, we try to minimize wet works on site. So we can do wood and nuts, we try to do it. For our collections, the steel being the main feature of our pavilion, what was also quite key is understanding how we can anchor the disc structurally sound onto the heads, the mounting detail, we call it, while at the same time allowing for ease of disc assembly and ease of the assembly of the entire pavilion. So that was one of the key considerations as well, beyond materiality. So, of course, the social aspect of it, in terms of how we can potentially move things forward post-demo, where everything is run down over the material scope. So, for the disc, we do have a portion of it, which, as we said earlier, the disc, each piece represents a unique symbolic dream inscribed upon it. So, we do have a collage or a collection of this dream disc within one of the designated areas to test it. And post events, we will actually look into perhaps distributing some of these discs as the only distribution especially. Some of them things that as a use the pavilion, it will get some unique discs. So it's because this program, you provide, you share your dream, and it's a combination of these collective dreams within the dream scale, and post event, you take back to one dream, another person's dream, and then it comes to circle. It's interesting. Yeah, and the whole process of engaging in different user groups, especially we open up this mini competition in that to allow for input of what these inscriptions on the disc could be. And so it's really a nation's effort in that sense. So beyond sustainability, what's also quite key is understanding the impacts from it's a ephemeral pavilion, let us of its size. What are the considerations for the physical dimension of it, as well as the sort of mental dimension to it. So physical is the sustainability angle. For the mental aspect, I think what's quite key is also understanding that while the pavilion is quite short-lived on site, with the prevalence of social media and coverage, to also be cognizant of how viewpoints of the pavilion go beyond just the human scale, beyond the ground scale. We have coverage from drone shots, as said earlier, of the entire site ring. So the understanding of how a pavilion is appreciated and viewed from a multitude of scales, a multitude of viewpoints is also very key. So that beyond just ensuring that it caters to the user experience of visitors who go down to the site, it's also quite key how we can cater to the entire international audience who perhaps might not have a chance to actually visit the pavilion. So from the ground level, you have almost like a building a door scale and take a step back up to the grand wing roof, and even further back to the master plan level where you see the whole social wing and how our spheres contextualize within it. Since you're talking about the nuclear program, and of course we're talking about Façade here, perhaps maybe you could tell us a bit more on the interplay, how we manage to bring the outside in, and how we somehow seem to integrate the two.
Yeah, so there's a bit of takeaway involved. But as I was saying in plans earlier, when you enter the pavilion, you're actually sidestepping around the pavilion, and it seems almost as if the facade sort of continues inside. So you have this relationship and understanding of where you are in relation to the sphere when you enter the pavilion. And as you journey through the different experiences, you re-enter the sphere. And there are parts of the facade that you will get a peek of and a glimpse of. So you always see these little red dots that come together collectively to form the sphere. As you enter and as you exit this little red dot. And adding a little bit more about the interior programming, because essentially each disc is meant to represent a dream and come together collectively. We wanted to make sure that, of course, from afar we perceive this entire sphere as a physical manifestation of the little red dot. But on the human scale, when you're really close up, right next to it, how do you perceive this? So there was an entire process of choosing, the colors, textures on the discs, so that there is a bit of variation and variety. And also it is a little bit, to explain that fact and dive into the ethos that this is a collection of various diverse dreams and unique dreams of Singaporeans that have come together to form this large collective. So that's sort of where it is at.
So on the screen, what you're seeing and what was on the previous photos is you can see all the wiring, all the volumes of the lighting system, which eventually gets concealed behind the disc. The way it was done is quite interesting. So the idea was to have shelves that are pre-assembled with 90 or 95% of the disc, so that you don't have to go and install individual discs one by one at height. And only the perimeter, the interface between different discs, between the different shelves are actually installed by hand. So the vast majority was actually pre-installed. But going back to the lighting, perhaps Tyson can share some interesting facts and some numbers on that. It's actually quite staggering for such a small footprint.
Thanks, Matthew. So, I said earlier, what's interesting is, I think you've seen the night rendering, but later on you'll see the night view of one of our trial runs into the lighting would go into blending of the lighting pictures. So it was quite interesting at the start. I mean, our initial intention was to add on to this expression of the sphere to give it a more dynamic expression beyond the day view, because day is quite static. We have the tactile qualities to the sphere. For the disc, we have various textures. So it's really good in a sense of tactility. But for a bit more dynamism, we thought we could add on this additional dimension of lighting. It comes in towards the evening time or just night time, where we have two modes primarily. One is this soft diffuse glow of light to allow this pavilion to look more actual. And of course, the other one is the smoke program based, and we can have it translating almost like a handy in a sense. Yeah, so these are two dimensions. And then in terms of how it was in the light, I think that was quite a challenge because we talk about integrated delivery. Right? So beyond just lighting, it was also quite reliant on the facade and how you actually marry the two together. Because if you break it down into the disc, limited disc, the lighting grid and facade grid have to actually line up perfectly. So as you can see that there won't be any instance where you expose lighting diode visible from the external side. So of course beyond the grid also one is to optimize lighting division or interval to ensure that there are no hotspots observed in the facade. It's to be almost a smooth consistent glow, which is very uniform glow color.
We also tested different, the color of the back of the discs, whether it should be white, whether it should be red, whether it should just be left as the raw may finish, to see what casts the most uniform glow without having very strong, sharp lines. So there are a lot of different processes involved, and as Kasan was saying, we had to also study a lot to test the different angles of the disc, because there are different scales and angles that you can see the disc at, and also the unique part about the sphere is that at every point of the sphere you are dealing with a different angle and different putting it all together. So we needed to ensure that the angle that we used for the discs was not only good enough to allow a regulated flow of lighting, but also that you don't see up to the gap between the discs and see all the messy bits, or at the top of the sphere we don't have the disc sort of angling upwards, because as I said, the plane of the sphere, the top of the sphere is very different from the equator of the sphere, for example. So there are a lot of different prototyping and testing that we did to ensure that we were at the right sort of angle at the most optimal level.
And we ended up with 13,500 LEDs.
Yes.
And something like 3.5
And if you see from the side where we actually have an exit staircase that brings visitors back down to the ground floor. And so we had to also see that the angle of the disc, so the distance of the disc from the actual FRP was not too much so that it doesn't clash with the staircase coming down. So there were a lot of little challenges that we had to, work around and try to get the best, result.
Since you're talking about mock-up and the mock-up process, there is really a very extensive set of mock-ups that were done precisely to do this, to look at the sizes of these, the colors of the these, the textures of the these, the angles, the light effects, the porosity, making sure that people could not, let's say, damage the these or get hurt by the these because of the render names on it, that the light was not visible really as such, but indirectly was lighting the panels. Do you want to talk a little bit about that and how the mock-ups were so essential to making it happen in the end?
Definitely. When we started out with the concept of the sphere, there was a part of the sphere that was meant to have a little bit of, like I mentioned, porosity earlier, where, from outside you could look inside, and from inside you could look outside. And after exploring various options, we have perforated discs in some areas so that to allow that visibility and that transparency a little bit. But in the very first facade mock-up that we did, which was in December of 2023, so quite a while back, we realized that there were issues with light leakage and, also being able to see all the connections and things behind those perforated discs. So with every mock-up, we've gone better and better, I would say. So the first mock-up was probably like the first pancake, as we call it. And then with the second mock-up, we were able to get a better idea of the angling of the discs and the distribution of the discs. So in the very first mock-up, what we also had was, if you recall Matthew's presentation, we actually started off with these angled pegs on which the discs would be mounted. But when we had our second mock-up, the second mock-up was in Osaka in January of last year, where the contractor actually proposed a different mounting system, which we call it the hat system. And Matthew will talk a little bit more about that. But the hat system basically allowed, an equal distribution of the weight of the disc, because we had two mounting points instead of one. And so with every mock-up, we were able to sort of resolve one issue after the other to get where we are at the moment.
And so the brackets that hold the things, the little backstory is that, communicating in a foreign language that we don't know with people we don't really necessarily understand can be quite complex. So in the end, what we did, we resorted to the good old paper and pen, and using that case, we did a little origami bracket. The bracket was literally cut out of paper, we folded it, and we showed it to them, and we said, this is what we want. And that was the best thing to do. Directly they said, I understand. I said that in Japanese, of course, but I understand they were able to reproduce with steel bracket what we had literally made out of paper origami. And it integrated within the mounting for the night. So it was a very accomplished outcome that was the result of the mock-ups. Since you mentioned Japan, I think Japan is a very unique country with a very unique culture, very protective of its own culture and economy as well. And I think you guys can share a little bit of the challenges involved in working specifically in Japan for this project, and what that implied.
Maybe I'll share because it was really from inception competition stage where we started looking at them already, and when we had to realize it, we started realizing that a lot of these interfaces that had to be resolved. So, of course, for the beam model, it's essential to coordination between both parties who are problems of disability. entry portals to the space, and even a canopy. So there are all these points of interface where, of course, if we read the sphere in its entirety and the panelization logic, there would inevitably be a clash there. So we also looked at this sort of localized interventions to ensure that all these clashes are detected and mitigated. So we conform to this same grid logic where the heads are arrayed vertically and laterally in the same order, but the boosts are the ones that vary. So as we approach the point of interface, let's say from the sphere, you have a wall meeting it. So and it's on a curve. So we have to then deal with the entire interface and resize the disk to the optimal size. And so that, let's say, if the 500 diameter base is too wide and part of it is actually clashing into the wall, we actually localize reduction in it to bring it down to the next three base sizes to down to the 300 mm diameter, and if we go down to the 200 mm diameter. So that was sort of like an interesting process to deconflict all these clashes. And also, I noticed that the analog way was the true way to go. I mean, of course, despite all the technological advances, we don't speak, most parties speak a common language of drawings and model making. So I think it really helped when we went down to sites. The first site visit was to the office because this area was still undergoing reclamation. So in the office, where we actually trashed out structural openings, how bracing should work with the sales engineers, and even facade mounting details. All of the sketched out on hand and it's really easy to be understood. Of course, it was a bit of a cultural shock at the start because building clothes-wise, it's not exactly a one-to-one replica. Over there, it's much more stringent. So, I think partly this is the context that we are dealing with, where they are quick. So, firstly, constellations are very, very, very clean. So, there's no transfer in columns that whatever you have on the first floor or whatever you have on the second floor or upper floors have to be brought down and grounded, essentially. So, there was one key aspect as well, of course, wind simulations was mentioned shared earlier. Then, of course, led to, after all this compliance matters, it led to the submissions. So, apparently for Japan, it's contrary to how we do in Singapore, you can have amendment submissions, right? So, let's say we have a refinement to the particular detail, you can put it in at a particular juncture without impacting the whole master program or master timeline. Whereas for Japan, it works a bit differently, where there's a major and minor submission. So, whatever warrants a major submission, oftentimes is structural related. We will have to resubmit the entire entry in, and then that has time and cost implications. So, given the very short runway of our project, that was one of the main challenges that we faced. How do we ensure that our delivery is and details are all reflected at a very onset, so that it doesn't warrant this trickling or snowballing of the entire timeline due to this changes. This was quite a unique situation. The timeline is fixed. The date of opening is there. We cannot fail. We have to meet that date. It's not like a normal project. We can ask for extension of time. There are certain constraints that might extend the deadline. But this is not an option here. And that means that any little change that we have to do has to go through submission, and it takes months to obtain that permit. And that is just not.
Since you mentioned that, there's another thing I'd like to add, which is a little bit about Façade also, because it's kind of the fifth elevation, the roof. We had always planned for the RPV times to be there, but we were trying to source the right ones, and in the meantime, submission processes were on. So by the time we got the approvals and the right product to use, we had to be very careful about the loading for the roof. So we had to choose a product that would fit in within that leeway of the roof loading. So that was also quite an interesting process. Otherwise, if we needed to increase the loading for the roof, we'd have to go in for a major amendment submission, which would be a lot more, which would have delayed the project a lot more, essentially. So
you get the drift through this interaction, through the dialogue, that this was a really challenging project, very tight budget, very tight timeline, very challenging design, but with the right tools, the right team, the right contractors, somehow we made it happen.
Actually, I feel it's a little bit meta, if I could say that, because it's a very small plot of land, like I mentioned, just 1,000 square meters. But at the end of the day, it is about representing Singapore at a global stage. So it is small in size, but very, very big. I would say a little bit. And the number of consultants, as you can see, involved not just within the BP group of companies, but also outside of it, whether it was artists, whether it was the communities we engaged, whether it's other creatives involved in the project, bands, agencies. There was just so many people involved in this project happening and coming together. So it was a very fascinating experience to see how it all sort of came together. For a small little piece of land that's only going to be there for 6 months. Yeah, I think a little bit meta in terms of how Singapore being small in size, trying to be achieve its big aspirations. So,
and in concluding that, on the fact that teamwork was absolutely key to making it happen. Thank you very much.
Thank you.
Thank you. Thank you for that insightful discussion. For the rest of us, this is the well-earned lunch break. Please feel free to visit our front booth, gain some insight, perhaps look at earlier too. See you after lunch. Thank you. Well, ladies and gentlemen, I hope you had a great break. It was very useful having that lecture concession. I certainly learned a lot from the exhibitors there, a lot of groundbreaking innovation and technology. Let's start with the afternoon session of this conference and put your hands together for Vanessa Baey, Associate Director, Kyoob Architects.
Thank you. Good afternoon, fellow families. And thank you, Zak, for having me and taking this opportunity to share a bit about what I have learned and what I've grown in the project. Okay, so we're talking about 2 local projects. But before I start, I would like to talk about Kyoob Architects. So we are about 50 people, mostly local projects, and why I'm starting with our purpose and our core vision is because a lot of our design and even our facade is driven by this core purpose and vision. So our purpose is to really craft meaningful spaces and inspire and connect people. Yes, we can always create beautiful architecture, facade, but what matters is also the people that use the space. And so this focus about user-centric design that integrate sustainability, innovation, and inclusivity. Okay, so some of the facade that we have done over the years across different typologies, different type of materials, exploration, form, and we have some residential, commercial, industrial, and event. Yeah, so different facade is meant to take focus on the people and the functions of the building. And so the first project I'm going to talk about is something that was completed maybe last year. It's a mixed-use development in Sengkang. It's one of our heartland near Pavilion LRT. And this project is actually a public project by HDB with commercial on the first story, and then we have Hawker Center on the second story, and our commercial schools, and our landscape deck. So this is a very small site, and everything is packed into this mixed development with our residential at the back, about 207 units. So the facade itself for this project plays a very important role in trying to create a very, community-focused areas. So the design concept of the facade stems from trying to create a naturally ventilated, socially engaging environment where natural light and airflow comes into our communal space. And this also helps to reduce our reliance on mechanical ventilation and artificial lighting. And so a bit about the design approach, I just talk not so much in depth, but like where we focus on exploration of our facade. So we start from the plan itself. We identify our key public spaces, our plaza, which is the heart of our development, where we have 24-hour Wi-Fi, our 5-foot linkway, our connections from the nearby coffee shop, the park, and even the sports hall. So these 9 areas are where we look at to consider the natural lighting, the airflow, and to create a space where the community itself can interact and socialize in the comfort of well-sheltered and around the natural flow. Okay, there's also like simulation. We install HDR plan to ensure that the airflow, the comfort level is good for the community, and also rain simulation because we have a hawker center. So rain is a very sensitive area in food establishment. So we make sure that during the rain simulation, we need to add additional rain screen, etc. on the top to prevent water from coming into the hawker store. But at the same time, we still want to keep our facade porous so that we can have the natural light and airflow. Okay, so as you can see, our plaza itself is an integration of like perforated aluminum panels. We have ETFE and even like fold up the facade slightly so that we can allow lots of light into and air itself. So you can see that it's a very brightly lit, naturally lit plaza. And if you look at the facade on the outside, you see like, aluminum panels, so I guess my variation, why are we doing this? Because there is different purpose behind the aluminum screen. We have like exhaust ducting, of KD from all the hawker center, and we have commercial spaces, we have schools. So different functions will require different kind of visibility and porosity. So we try to vary our facade in 3 degrees so that we can keep certain modules. And then when the client requires the screen to be very visible, we want people to be seen and be seen. So that's where we put up the panels, we cut the rectangle panels into triangles. We vary the facade in this way to really understand the user requirements behind this facade. And this facade becomes alive because of all the different functions it's expressed on our facade as well. And we also integrate ETFE together with the aluminum panel. So this ETFE during daytime, it allows light to come into the hawker center, the other volume spaces. But at night, it becomes the other way around when you are from across the road and you look at there's like bathroom activities going on, and it becomes a beacon where people move towards. So technical consideration, we actually have 3 different specialties for this facade. The coordination can be challenging, so we have to scale the support system. So the start, our intent was to weld all the steel components together. And when this project was rushing, it takes a lot of time to do the welding on site. So we decided to actually cut up the steel components into modular sizing and to allow for additional plate to be welded to the steel structure, so that on site they just need to bolt the 4 corners of the plate. And that expedites the construction process, which later you can see the video that I will share. Also, the aluminum panels, we have different duration, but we keep it to 3, allowing like all I mentioned, the exhaust and everything, but at the same time still provide weather protection. And our ETFE as well, if you look closely, it looks a bit frosted, but actually it's like little dots on the ETFE panel because we're very concerned about glare in our tropics. So not just allowing light in all the time, we also need to take into consideration the comfort level of the glare and everything. So we have this little dots painted on the ETFE so that in the inside space during the daytime, you can still feel that it's very comfortable, yet it's bright enough. Okay, so some safety consideration. Our client, because it's a public space, we have known that Façade has a tendency to fall outwards, and ECA has a lot of regulation and consideration for that. So for our Façade, during the design process, we actually have to integrate a fail-safe measure. So the main primary support system it used to be a slot-in system where the aluminum slots into it, as you can see. After that, subsequently, we switched to a clamp system, and then we have exposed bolting, so that people, you can do easier installation, it's reachable with the hand, you can do easier inspection as well. So this is also certain safety measures. The other safety measure we added in is the secondary support system, where we did a little folding to slot in a steel rope. So our main support system is actually a steel rod, but because if the steel rod were to fail, this steel rope, which is separately bolted to the structural flat, will temporarily hold the panels and allow for fixing before anything happens. So it's really to prevent this falling out of the panels. But actually, the panel system, it is secure enough. It's afraid of wind load, etc., that these additional safety measures come in place. So for our residential, you can see that the Façade iteration is slightly different. We have the folded box aluminum panels, and to do a steel rod or rope through that panel doesn't make sense. So we tried to, this Façade instead, we did a C-hook. You can see some of the prototype that we did. So when if the bolts were to loosen, or this rod, actually the C channel of the panel will still hold it in place. It will just hold it in place by natural force. So it won't fall upwards into the driveway. So such safety consideration because public buildings. So as you can see, this video, I'll show you the construction of the Façade. This overall, hold on, playing. Let me play. Okay, yeah. So you can see the steel structure started, and it's quite fast, within 2 months. This steel structure, because it came in components, were able to build quite quickly on site, and then the aluminum panels are slowly slotted into the different sections. We try to keep it to by 600 across like modules and 2.2. Yeah. Okay. So that's for Jangho Village, as I know. So this next project is actually a private development at Jacob Park. As you know, Jacob Road is actually just behind Orchard Road, so it's a very prominent, very kind of prestigious area where luxurious residential is. So it's a single-story building, and each story has only 2 units. So we have about 60 residential units. We have other amenities, but the key design idea of this is actually the extensive sky terrace. That's on our typical story to provide this outdoor space at one's doorstep. And the feeling is to give this perception of living in a bungalow in the sky. Yeah, so this is the time we push for this luxurious residential living. So the facade design for the top part is to create this horizontal layered structure, like the tree contours, with vertical elements, which we consider is our tree trunk, to design and integrate greenery that enhance both the microclimate and also the privacy of the residents. So instead of solely relying on conventional shading device, we allow nature to take over and create a living facade that evolves over time. Okay, so then, to create such extensive sky terrace, construction innovation is required. So we used to plan for it to be like cast in situ, like we have the scaffold and cast in situ. But the contractors, especially the West and consultants, work together to see how we can create a precast sky terrace. So the specialists work out like three-dimensional curve that's using CNC to cut to form the mold. You can see that they created the mold itself. And also this sky terrace, which is quite huge, spread across 2 units, are cut into 5 portions so that they can be easily hoisted and installed. We also consider, because we want to put the intent of this curved sky terrace, we have to incorporate services within this, and sprinkler is one of them, right? And if we were to run a sprinkler services below the curved terrace, then it wouldn't be so pretty. So we integrated RC trench within the curved sky terrace, and also column connection, etc., so that we keep the front below to be as seamless as possible. And on top of that, because it's huge, so we have consideration for transportation and hoisting. So I can show you a video. The reason is hoisted. Sorry for the dirty movement. I was standing underneath it and thinking, oh, will it fall on me? I shouldn't be underneath it, but luckily it didn't, so it's very safe. This first portion is the hoisting of a very big piece of our sky terrace. So the initial is to hoist from the lorry to the area where they sit first. Then the next step is where they hoist it up again and do the installation. And subsequently, the connection part, they have to connect and then cast back the connecting points. Yeah. So with that, it's actually helping to expedite our construction processes. When we think about facade, we think about we want fanciful things, we want curvilinear structures, but at the same time, we need to think about how it can work in line with our construction timeline, our budget, and the constraint of our site, because it is a really small site, hoisting, weight of the crane, etc., to really meet our design intent and construct, and at the same time constructable. Okay, so other technical considerations for our tree trunk, we actually precast the whole thing with different the mold, and also created joints and bolting system that can be covered up so that it looks still like a seamless tree trunk. And also the mold and the rebars all passed off-site and hoisted into our site. For the first story, we have very varying size of columns, so it doesn't make sense to have multiple molds. So instead of having this precast with all the patterns on it, we decided to do a GFRC cladding instead, and then do a mechanical fixing. So this GFRC is like 50 to 75 feet, and then we hoist and mechanically fix to the column. So there are other ways in which, if we were to say to precast every of our columns in first story, it may be impractical, and it's not very sustainable either. So there are other mechanical methods that can create the same design intent and look, yet not affecting our timeline or excessive moves. So the other thing that the contractor proposes is the automated climbing wall. So we think about facade as also how do we able to construct our gable end safely and with façade installation. So they installed this system. So instead of having horizontal platforms when one pass and gable iron walls, this auto-cladding wall helps to keep the construction within it and safely build it upwards. This is like 30-story high. So it did help in expediting our processes, keeping our RC cycle fast within 12 days. Yeah. Okay, so I'm coming to the end of my slides. And I think that design is the first step. We show our design plan as architects. But we really need to work with our builders, our specialists, and our consultants to refine construction budgets and innovate along the way to have adaptive solutions such as precast, high-density cladding, auto-cladding wall. And then the project will successfully maintain our design intent, and at the same time, the design and the engineering solution could come together and create a tropical high-rise living. Okay, with that, I'll end my presentation right on time. Thank you very much.
Thanks, Vanessa. I really like the dynamic thoughts on both of those projects. Let's welcome on stage Mark, Gregory, Domens from AIT, our next speaker. Good afternoon, ladies and gentlemen. First of all, thank you, Zak World of Façades, for this opportunity. Recently, the rising global temperature led to a variety of impacts, including more frequent and intense extreme weather, against especially typhoons, heat waves, droughts, and floods. Today's presentation will focus on the design of façade and high-rise buildings prone to typhoons. AIT has offices in the Philippines, Hong Kong, and Shenzhen, which are also prone to typhoons. To give you a brief background of AIT, we have been in the industry as one of the leading façade constructors with more than 30 years of design and technical experience. We have completed more than 450 projects in 30 countries and partnerships with world's top architects and developers. In 2016, CTD is recognized as the #1 façade constructor for terrace buildings, having done 8 out of 20 terrace buildings in the world. To update, we have to include Merdeka 118 as the second terrace building company. AIT provides the following: consultancy, façade consultancy, façade access, façade thermal simulation, BIM service, architectural drafting service, and engineering façade engineering. So, who among you have been in the Philippines, Hong Kong, or Shenzhen during typhoon season? Let me clear these different storm signals and categories in different regions.
You see 5 typhoons, big impacts, with 4 indicated direct rainfall. For me alone, in the past week, the only one that didn't make rainfall was Category 4 Convener. Now, what's to come, then, a 6th storm is brewing just behind the farthest storm to hit Taiwan in nearly 30 years, has made landfall on the country's sparsely populated eastern coast. The Northwest Downward Storm Signal is enforced.
Okay. The goal is to explore how typhoons affect high-rise buildings, especially with the floods, and to find the best design strategies of resilience that can be adapted. One of the most critical factors to consider is the wind load, since the wind load is a major force that can impact both the safety and the structural integrity of a building. Some wind loads such as exceeding 8 kPa. So, the wind exceeding 200 kPa can severely damage the façade, and cause glass breakage, detachment of operable and cladding panels.
One factor to consider as well is the weather and subsequent water infiltration. When the water gets in, you can see corrosion and water, condensation and leaks in the inside. The high wind pressure, especially heavy wind gusts, creates whistling sound due to the aerodynamic response to facade and upon its impact to the surface. The matter shows that the facade has enough acoustic performance, like using ideally acoustic pad or adding buffers to it can significantly reduce this issue. Within the group, the first significant hazard, which impacts the facade, damaging panels, and putting people at risk. While designing facade for typhoon regions presents unique challenges, there are solutions that can help address these difficulties. Here are some of the challenges and approaches taken to overcome them. One common testing is highly recommended to determine the wind pressures and the forces acting on the facade, and also to examine the wind flows around the building. One common test provides pressure values to be used to determine the gas buildup, film forces, and connections and approach to concrete. It's important in the design phase is to provide better information on how the structure will function in case of severe weather-like issues. One common testing also considers the effect of nature fall, the wind management of air-cover windows, and window debris resistance system for facade located in 2 meters below. One of the most significant challenges is ensuring that the facade can stand the extreme window pressure without compromising safety. High winds can cause panel failure or even total facade collapse. This can be mitigated through the use of adequate gas buildup, membranes, filaments, connections, and anchorages. Assuming once you have the wind tunnel test, we're able to get the required gas buildup, the size of the filament, and the corrections. Another challenge is balancing the aesthetic appeal of the building with the required good structural components. The full-resistant facade often focus on the function of the home. However, if the goal is to maintain or minimize the size of the framings or the facade components, especially if the architectural design calls for sleek or smooth facade, we might consider the following design approach. So for this material, fully tempered or laminated glass are preferable since it provides because of its inherent capacity and the safety features. I show you some example of glass where we have been able to reduce the exterior light to match the light bill that we have on the standard area. The usage is stronger heat treatment. In this case, this is fully tempered. Now, facade framing, depending on the critical area of stress or deflection, we can add specimen or provide some outriggers or strong back behind it. We can also consider using stronger temper alloy of the element. For cladding metals, if we have a limitation to exceed the desired panel dimensions, we can add the stiffness behind it. In high construction, particularly in typhoon-prone area, properly designed facade systems are absolutely essential for this structural integrity and safety. They're not just about aesthetics, they're the first line of defense of building against wind, rain, and debris. So let's take a look on some of the main facade systems used for high-rise buildings. One of the key advantages of using unitized curtain wall is the level of high quality control through factory prefabrication. This system provides a productive barrier and, very importantly, they are designed to effectively manage water intrusion. The personal conservation ensures that any moisture ingress will be efficiently drained out of the root system. As the wind pushes the building with most the facade, the moving doors and the gaps of the tunnel units absorb this movement to avoid damage. I show you the project using a cladding system. It is composed of two layers of cladding. The first layer acts as a windscreen barrier. The windscreen, the second layer acts as a waterproof barrier. The gap in between these two layers allows airflow and drainage to avoid moisture retention and damage due to potential water ingress. The gap on the hollow will also absorb the movement and deflection of the wind load acting on the cabin. Now, there are useful, we need to also consider the basic support that we need to counter these inflows. There are usually two main types of support we can consider. The first one is structural sealant glazing, which utilizes structural sealant to directly adhere the glass onto the frame to achieve a seamless look. The next one is using a cup system. It utilizes the use of gasket and metal frame to physically hold the glass. If you look on the outside, you can see a perimeter frame that supports the surrounding glazing. So, when designing high-rise buildings in typhoon-prone areas, selecting the appropriate preferred glazing material is crucial to ensure the safety, durability, and performance of the building. The structure joints facade must be able to withstand extreme wind forces, headwinds, and potential flying debris. So the facade material should have a high strength capacity and resistance to deformation. In most cases, glass material is fully tempered and laminated glass. Fully tempered glass compared to other heat-treated glass is the strongest, and when it gets shattered into small pieces, thereby reducing the risk of hurting someone. Another material that we can consider is metal cladding, which is lightweight and durable, and it is not applied with suitable temporary coating, while also high performance in extreme weather. To mitigate damage due to windborne debris, especially at 18 meters below, we utilize specific protective measures. Since most of the countries require windborne debris protection, especially in the Philippines, the National Structural Code of the Philippines, which is basically based on US standards, specifies protection for facades in coastal areas and high winds, particularly up to 18 meters above the ground, and this typically requires use of laminated glass, stone shutters, or temporary product. So, to illustrate, we have a terminal fully tempered glass that has historical, but structurally with corresponding window. However, we might need to use 6/6 and 1/6 laminated glass. While this results to outright increase in cost, it significantly reduces the risk of glass breakage and subsequent maintenance costs due to the impact. You can also consider the use of strong shutters, which can be made with various materials like aluminum, steel, or the carbonate, etc. It serves to protect the windows and glass doors from flying debris, mitigating potential for structural damage, leaks, and injuries. The laminated glass offers better in reducing risk of injury, since the plastic interlayer holds the fragments together, preventing from flying off or hurting someone. And the last one that we can consider is provision for temporary product.
Pavilion windows in high-rises are reliable to strong winds, and the windows falling off is significant even in case if not properly check the hardware in terms of the structural efficacy, and if the metal laptops are not correctly positioned or spaced. It is important to have diligent check on the hardware capacity and conduct proper inspection to avoid the strain. The constant exposure to wind, rain, and salt water in coastal areas can cause to degrade the material of facade over time, requiring frequent maintenance. Using corrosion-resistant coatings, well-designed facade replacing methods can reduce the maintenance needs. Now we go to some of the projects that we did before that able to withstand these strong typhoons. First is the Taipei 109, completed in mid-2004, with total force of 91 and 508 total height. Maximum wind pressure at 8 kPa. The ICC was completed in 2010 with 180 force and 484 meter total height. Maximum wind load 6.5. Charu the Ford, located in BGC Pavilion, rate of completion is 2016, with total height of 208 meters and maximum wind load of 7 kPa. The Grand Hyatt, which was completed in year 2017, also located in BGC Pavilion, with total height of 318 meters and wind load of 7.5 kPa. The Peng Finance Center, located in Rajan Govind, China, completed in 2017 with a total height of 599 meters and wind load of 7.5 kPa. The following high-rise facade in particular areas requires also innovative solutions, advanced engineering, and careful material selection to ensure safety, functionality, and aesthetic appeal. By using integrated sensors and monitoring system and climate adaptive sensors that can track weather conditions in real time allows the building's facade system to adjust based on current environmental conditions. For example, shutter or protective screens can be automatically deployed while wind speed reaches dangerous levels. Facade can be designed to respond dynamically to changing weather conditions, such as retractable or adaptive levers, that can close or close depending on the wind speed and intensity of the wind. With the advancement of research and technology, the high-strength silicon cement with the strength capacity of around 200 megapascal is now available from one or more cement suppliers. This can result to massive cement by default, and if preparation is preserved by the cement life, we can use the narrowest grid possible. To conclude, designing high-rise facade in coastal areas requires comprehensive understanding on the impact of the extreme weather conditions. By carefully selecting materials, focusing on wind resistance, and addressing potential challenges, we can create a building that is both safe and sustainable. In a world where typhoons are becoming more stronger due to climate change, the role of the architect and engineers are very important. The solutions we implement today will protect us and ensure the resilience of our cities for generations to come. Thank you for your attention. Please follow our social media, Facebook, IG, LinkedIn, and visit our website for more info. Thank you, Mike, for that very relevant and pertinent topic and presentation, especially with climate change and nature playing such havoc on our world today. Next on stage, please welcome Simon Chan from Siew Façade. Good afternoon, ladies and gentlemen. Firstly, I thank for the staff to give me this opportunity to have this presentation. And recently, I have involved few more projects with the very complexity of the facade. So 3 years of some background of the complexity stuff. I think 200 years ago, this is a complex facade. This is a artwork and a sculpture. The architect draw the picture and the labor is depends on the craftsmanship to build this building. And also, for the last 30 years, also we doing some curved facade, like the Burj Khalifa, the curved on Peng, and also that project in China, also the curved facade. So we use the background to the segmented with each other, or we use a triangular or a polygon shape of that to create the curvature of the facade. So, this morning, we speaker talking about the Henderson. That's a really important project. We completed last year. So, after that, we get another chance for Oppo and Tower in sometime. And you can see the Henderson, the curve is a three-form double curve. And the curvature is not gentle, but the Oppo, the curve is more challenging and greater. And that one, the Tower is also complicated together with the piano and grazing. So, this is a principle for the Henderson. I think this project is the most expensive building in Hong Kong, or we can say in the world. And the land cost is about $69,000 per square meter. And the land cost is about $3 billion. So I think this is the first curve mall, only sky curve mall using a double curve facade. And we involved, I think, before 5 years ago. Okay, you can see, I think this morning some images about the curvature. And actually, we have a competition before tender. For the beginning of the project, the client had many questions about the buildability and how we construct the double curve facade with unit type. And the consultant had some idea. We don't use a unit type square wall, using a stick wall, everything, consultant, saying that they propose a stick wall instead of unit type. But the client did not happy with this thing because they want everything in building the factory. So the client invite full contractor to doing the pre-construction work. So they invite two contractors from Europe and two contractors from Hong Kong to do this work. And finally, only two contractors do it. One from Hong Kong, Baey, and next one from Europe this morning, a city doing the podium and the tower. So this is the construction work we do it, and we also put this construction work to the performance test. Everything is part for water colors, air infiltration and structuring. There are some project mock-up. Okay, so the whole project is about 25,000 square meters. It's about 60% is a curve. That is using the platform gas. And we order the gas from Germany. And it's about 40% is a flat gas, the rear side of the building. We have a single curve, vertical curve, and double curve. And each family is different radius and arch. So, for every project, we are applying the client. But we have different platform or software. For example, the artists only use a really or wireless web, but for our current model, they are not suitable for doing this with the wireless web or really. because we need to think about how we can produce the model and using the PIM model into the fabrication model. So, we're using the liner for our design of curtain wall. But for this project, the architect using the Zakiah. So both of them have been interchangeable. And maybe some other words, the same one using the character. So I think we have many software on the net to work it on the facade. And we already have a term of DFMA. I think DFMA was meaning inside the manufacturing assembly. I think unicast Convener is the best implementation of this one, of the DFMA, because everything we look at the factory, and we for this complexity of the curtain wall, we need to think about and decide how we design at the beginning, how we fabricate it, and how we can assemble it, and how we can install it. And later we are thinking that. So for this PIM model, we will transform into the fabrication model. We are also using parametric design. We're using a Pavilion software, and that is in case of a change of any design work, then we can easier to change, and all the information can be gathered from the PIM model. So, and this is a model of our PIM model from the PIM model. And we're facing another problem of our current, because when we do this way, nobody knows that, nobody understands, because it's 3D drawing. So, how we can represent to our labor to really. So we don't have any drawing to fabricate it. And the problem is that this is transform. The problem is that so we did not have any machine to find the model for the transform. So we have to design the machine with this this is a theory machine. We have to bend it two-dimensionally. We have also this system table to make it the minor axis and the twisting.
So this is a machine. We work together with Zakiah to design a machine for this bending. So there's a free roller, and this turning table can have a minor axis and twisting. So you can see the twisting and the diagonal.
And also, after we fabricate that, we have to cut the curve member and drill the member. So everything we're using the PIM model. So the PIM model can transform the machine code for the CNC machine. So we have many different machines using the CAM-Q and CAD-CAM using that machine code to produce the products. Here, this is a 3D drawing for the machine code. So we put this into our CNC machine to drill the hole and cutting a notch. So different software to cut it. This is the machine code from that. And we also facing some problem of some bugs, but we need to fine-tune our PIM model and to make this smoothing for the production. And after that, we produce the product. And the traditional method of measuring and checking the curves cannot work. So we use the 3D model, 3D scanning to scan the model, to scan our product. This is a scan image. assume that different of the points on the edge on the surface. And this is site scanning. After the installation, we also have scanning for the whole building, see the deviation, and also this is a handheld scanning for the bathroom. And every component, when we manufacturing, we have a tolerance. And how we can compare the tolerance and make our production in accurate position for killing the hole or cutting. So this is a blind model. And we also have a scan model to overlay to the proven computer and put into the CNC machine for cutting. So this is a tool, for example, and this is a blind model. This is a physical material we scan it, so we can see the deviation, and we need to put this cutting or this hole in accurate position. So this is a scan and the blind model overlay each other and finding the tolerance as a nanofilament. This is some picture. This is a scanning machine. This is also the output for the scan model. Okay, now we have a video lecture. So the whole process is composed of X, Y, and Z axes. When we place the straight profile, we can look at it as a flat straight line. At this point, if we apply a force on the x-axis, it becomes a single curved profile. Then, if we apply force along the y-axis, it will have curvature in both dimensions at the same time, which is double curvature. This profile has now transformed from a straight profile to a double curved profile on the basis of the double curved profile. If we apply a clockwise twist along the z-axis, it will become a double curved twisted profile. Why is it necessary to create a double curved profile? In building facades with curved glass, we employ various types of curved glass, such as single curve, regular double curve, and special double curved surfaces with unequal top and bottom arcs. Therefore, the profile processing requirements vary depending on the type of curved glass. Straight profiles cannot directly make curved glass. For single curved glass, the straight profile needs to be bent along the x-axis to achieve the required curvature. For double curved glass, the straight profile needs to be bent according to the curvature of the glass, considering the various requirements along both the x and y axes. When dealing with special double curved glass with unequal top and bottom arcs, because the two sides of the glass have a certain angled tilt from top to bottom, two dimensional bending alone cannot perfectly fit it. We also need to rationally deform the profile's cross-section along the z-axis. After precise bending and twisting, we can then combine the profile with the glass. The double-curved surface of a building can be broken down into many smooth and continuous units, each with a different region. Therefore, the requirements for each profile also differ, which is the technical challenge of double-curtain walls. How can the double curvature twisted profiles be achieved through a roller bending machine? The double curvature of the profile is formed by a customized node with an inclination angle on a roller bending machine creating a fixed angle. This is achieved by using the drive roller and the flat arc curve are used to realize the diagonal lower bending of the cross-section, achieving the double curvature effect. Finally, twisting is performed using the fourth axis fixture to achieve the effect of profile double curvature twist. In the ordinary architectural spin model in 3D software, if the building facade consists of a series of rectangular glass panels arranged in a short, long-shaped pattern, you can select two panels that are identical and perfectly overlapping. In this case, the design process allows us to directly copy multiple identical rectangles to complete the facade design. However, when the facade consists of several curved panels forming a double curved wall, the challenge changes. If we use the two-point alignment function in the software to compare any two curved units by overlapping the equal-length edges, we quickly discover that the two curved glass panels cannot fully align due to differences in curvature. As a result, in double-curved curtain rail design, the direct copying of units becomes a significant challenge, requiring specialized solutions to ensure accurate fabrication and installation. In the profile processing, workflow, traditional straight profiles are placed on the machining center as linear elements, making them relatively easy to fix and position. However, when processing a hyperbolic twisted profile which follows a spatial curve, positioning becomes significantly more challenging compared to straight profiles if the placement is not precise. Drilling operations may result in misaligned holes. Furthermore, if the bending process in the early stages produces a deviation exceeding 3 millimeters, subsequent steps such as cutting, drilling, and assembly will be impossible to carry out. Therefore, tolerance, control, and accurate positioning are the primary challenges in the production of our twin gauge curtain wall units. To overcome these challenges, we can import the parametric model into the machining center in advance. Before processing, we utilize 3D scan technology to capture the actual profile model and compare it with the film target model. This ensures the positioning is accurate and drilling points the bond correctly. By integrating 3D scanning controls, verification, and precise positioning with automated machining, we achieve the same fusion of technology and architecture creating the curves that define modern cities. The majority of Henderson facade consists of double-curved unitized panels, demanding extreme precision in aluminum profile processing, especially double-curved glass with unequal arc lengths. Each unit varies in shape and requires precise bending. The curvature directly affects processing and cutting accuracy. If the cutting angle deviates over 0.3 degrees, assembly errors amplify, preventing proper profile from affecting installation. Therefore, ensuring high precision control is crucial. Okay, another case of it. After the Henderson, we get another project. This is more challenging than the Henderson. We also using the display model. I think you can visit our exhibition too. They have more detail about this project. And this is a rear view. So we build the rear view before we award the contract. And this is also the roof block. We have the opening with the BMU building maintenance unit, and we also have the really high-span steel work, also the double curve and twisting of the member. So for this project, we different from the Anderson. We're using the cold band gas. So because the time when we save money, so the gas is in fact service, and we manufacturing the curve fabric and put the gas on top, bend it. And this is our work testing for the packaging of the glass. So, okay, this is a hot band gas, this is a cold band gas. Okay. So another project, this is I think it's a mega project. It's almost 800 million customer. It consists of 7 towers and also have a feature dome and filters. And here is over 600 we call it cell. Some of the cell is facing upward to receive the reinforce. The range that we have a good change on that. And this is the actual work done outside. And you also have the rich PC panel. There is a new material, is very thin material, and also the strength is 4 times higher than concrete. And this is actually drawing and actually okay. And for size, we also manufacturing the photovoltaic panel. We also combining the BI model to checking the weather data and the geographic data to the actual environment. Also, we're using the Pavilion script for calculating the efficiency of the power output. And for the real BIPV, so this is very cost-effective generation of the power from building, thermal insulation, and carbon emission. Here are some of the projects, and this is high-current BIPV panel. And our BIPV panel can be any color or any pattern. This one like the front panel, some of them extremely sorry, but we're going to this way. I think this is one project, and also this project. And lastly, we found not only the facade contractor, we also run our chemical team or design team with the idea of design, science, technology, engineering, and mathematics. One we teach the children. So, in the near future, we will think about how the AI can work to a more advanced design. Thank you.
Thank you, Simon, for that insightful presentation and reminding us the amount of work and processes that go into bringing to fruition something that is designed by architects, envisioned by architects. Please welcome next on stage Christoph Troska. Thank you very much. Thank you very much, Nick. Good afternoon, ladies and gentlemen. I have the honor to guide you a little bit through the story of the laminated safety glass or the interlayer within the next 15 minutes, and I think we need to start the timer. Thank you. The speech is about 3 parts. First, I want to motivate why I'm here. Therefore, I want to talk who we are and what we are doing. The second is about durability of laminated safety glass, and the third part is about sustainability. Let me start. Typical question is, what are you doing here? We have already seen in the presentation from Gregory, there are differences between real glass, tempered glass, and laminated glass. We do not do any of these. We don't produce glass, we produce the interlayer that are used in laminated safety glass. Why is this interesting, or what is the main purpose of all the products that we are offering? We are really bringing safety to the glass itself, so it's the interlayers acting as a kind of glue to keep the pellets on the glass, so that you are not hurt if a stone hits the windscreen, for example. So that is the primary job of our products. But my job is not as boring as I just described it. It's a little bit more complicated. And you see here, we have a variety of different interlayers from both central glass as well as PVB. We call the PVB total. And you see, we really can do a lot. We can have sound control, you just see here. We have a sound control properties with structural properties, specialized safety, and agriculture, definitely sustainability part, our new standard portfolio is our low carbon interlayer. So it's really complicated. And why am I here? Because your life is looking a little bit different. You want to see solutions, and I just want to motivate again what is the job that our interlayer is doing. You see here on the top left, you see, I just say top left, you see a standard laminated safety glass, 2 times 10 millimeter, with a 1.52 millimeter interlayer, PVB interlayer from us. And you see what is happening if those plates break, it will fall down like a wood tower. In the top middle, you see the same glass design, 2 times 10 millimeter, and a 1.52 millimeter different interlayer. It's our central glass. This is a very stiffer material, and you see even if those things break, it still has some capacity, some post-glass breakage performance. On the right-hand side, top right, you see a bullet-resistant glass, a little bit complicated. On the right side of that small beam, you see the epoxide, and therefore you see splinters falling away. And on the left side of that video, you see the opposite side, where typically people want to be protected against that bullets, and you see that there are no splinters going away. And on the bottom part, you see an amazing young man hitting trying to get to first entry glazing, and I think the entire video is 3 minutes long, and he's not getting tired. It's really interesting. So we can do a lot with the different kinds of interlayers, and we are here to motivate you to get to us whenever you have a question regarding interlayer. You see on the right-hand side just the typical things that we are working with, so most first entry, non-light threads, all this, and we can translate what is the best matching interlayer for your project so that you find a good the best matching solution. So challenge us, we are outside at the booth, challenge us, and we can support you. Coming to the second part, what don't we like with our product? You see here some pictures of delaminated glass, and I typically hear it has to do with the interlayer, and I just want to tell you it's partly true, but it's not the entire truth. So a glass or a laminated safety glass is typically impacted by the glass itself, by the interlayer. Of course, we have some part of that responsibility. The next is the processing, and the final step is, of course, the installation. And any of these 4 topics can heavily influence the quality of the laminated safety glass. Let's start at the top. We all know that if we laminate toughened or heat-strengthened glass, that it has a certain waviness. This waviness can partly be compensated by the PVB, the interlayer, and the PVB, we typically say can compensate up to 10% of its thickness to the waviness. So if you have a 1.52 millimeter interlayer, it can compensate a waviness of the glass of 0.152 millimeter. So if you want to decrease thickness of the interlayer, you better at the same time ensure that you have a very high quality glass that you are using. The second one that the interlayer can help here is if we have different grades of adhesion, so the gluiness to the glass, and of course a high adhesion product that is more gluing helps to keep the glasses together in case it wants to laminate. Next on my list, some easy things for processing. Our interlayer, or at least our factories, always has a certain humidity. You get it, or the processor gets it with a certain humidity, and sometimes if the glass is, if the interlayer is not used, it's just hanging in the, I don't know, the English word for this, where you store the glass, the storage, or where you store the interlayers. And if you don't use it, or if you don't consume it at all, then you should reseal it to avoid that the PVB is picking up humidity. So some easy things to do. Next one, so resealable modules. Of course, processing. The processor should check the humidity in the layer plane. So when the glass is made, it should control the wash water quality. You can do it by measuring the conductivity. And our recommendation is that the washing water should always have a conductivity of less than 20 microsiemens. And you can check the pinning value that is in industry standard testing. You've seen some glasses, some pictures of smart glasses. You can find information on our homepage. It should be state of the art, and this is how you can control the quality of your glass in the factory. And last but not least, Also, the installation has an impact to the quality or of the risk of getting delaminations. If you have some fixings and you overdo it by tightening, then you're squeezing the laminate, and that is for sure not good. Interaction with sealers is high risk, and water ponding, so you see on the right-hand side the picture, a laminated safety glass should never stand in water, especially not if it's made with PVB, because PVB is attractive to moisture, and that means it's collecting it, and the more moisture it collects, the less diffusion it has. So a lot of things to do, and that was my quick journey about the topic of durability. Some more what you can do if you visit your glass laminator. You see here typical pictures of a good edge seal after the pre-stress, after the pre-lamination, and you see an improper one. So these are easy things that the professor can control to ensure that he is really producing a high-quality laminated safety glass. And finally, to that chapter, if you see things like this at your professor, glass clamping is not a good idea. It's creating local press to the interior, and in a good process, you don't need that at all. And if you don't need it, you will get a higher quality laminated safety glass. Okay, coming to a new mega trend, maybe not here in Asia, but already starting in Europe. We want to motivate you to see the sustainability as an opportunity. Just some very high, rough explanation. When we talk about carbon footprint reduction, we typically talk about scope 1, 2, and 3. Scope 1 and 2 is what you are burning in your factory. Scope 3 is the impact to your carbon footprint coming from your supply chain. So in our example, if we have forklifters with diesel, they contribute to scope 1 and 2, and if our pesticide delivers is getting to our factories, that is the scope 3 target. Façade is more than just the interlayer business, has committed to reduce their carbon oxide emissions compared to 2021 until 2035. By 63%, and we want to be carbon neutral by 2050. Scope 3 target, similar, and it sounds less challenging, but I promise you it's not. Same benchmark 2021, our Scope 3 targets for all our suppliers, we need to develop to reduce carbon emission by 37% until 2035, and of course, it's a year we want to be carbon neutral by 2050. Translated to our products, what does it mean? We have started to do so-called life cycle assessments, where really in a certified way is proving what is the amount of carbon dioxide per kg of PVB or interlayer product. We have done that, and you can find even the next generation, that is the so-called environmental product declaration, you can find it on our homepages. We will get one year, so you see at the bottom all the production lines that we are having. We will have these data available within the next 2 months so that we can really compare and share that data with you, that you know, okay, if I want to have a certain reduction, you can just order it at ours. At White Plastic, we have announced 2 new products. We have introduced the kind of, that you know, Nutri-Score card, or the kind that you know from the white goods. So if you buy a washing machine, then you have a level A, a level B, a level C, for demonstrating the amount of energy. We are doing something similar for our products. We have announced at Plastic that we have one product that is going down with carbon footprint to 0.2 kg per kg3. The second one in Class B will be available in jumbo size, so 321 watt. Will be Class B with a carbon footprint of 2.7, And our average product from Troska in Germany, because we started the pilot here, is at 4.45, just for comparison. As mentioned, once we know all the data from all our production sites, you will see an update in our product data so that you can always decide, okay, is it worth to get something better than the 4.45 or something worse than that? You can also develop in the one direction. I want to use the remaining 2 minutes to motivate for a different approach. You know that slide, I think my colleague has shown it several times. I also did some years back. There's one thing that I want to highlight for century glass. Next to the strength, 100 times stiffer than glass, but we know that. This is the design optimization. We say it can lead to thinner glass constructions. Also here, thinner glass constructions or rather larger glass panes are possible. That also has an impact to the carbon footprint if we are looking beyond our borders. So the figures that I just demonstrated are just for the laminated safety glass. Here you see some figures proven by the German Glass Association for a minute glass. On the right-hand side, a motivation to use our carbon footprint calculator that is on our homepage. And now I'll do one example. Just imagine you have a 60 millimeter laminated safety glass. You need to trust me, it's the same figures as shown in the last slide. And you have 8 millimeter real glass, contributing with close to 25 kg of carbon dioxide. The impact from the interlayer and again in 25 kg from the other pane. So in total we're talking about 55 kg of carbon dioxide, not even taking into account the elimination process. It's just the sum up of the ingredients or of the recipe. With the downgauging of glass, we can for sure reduce the glass thickness from 16 mm to 12, and that means we go down from the 55 here on the left side to only 42 on the right side. So by just choosing a fossil-free alternative interlayer. And so in total, that means you're saving more than 20% of thickness, 25% of weight, and that also helps to reduce the aluminum or steel construction below or behind. And also the carbon footprint is reduced by 24%. And that will by 15 minutes. Thank you very much.
Thank you, Christoph, for an amazing presentation. I think we'll get my head around how strong that glass was. Amazing. Next, put your hands together to welcome on stage Albert, Toset, and Mary.
Hello everyone. It's a pleasure to be here. Thank you so much, Zak, for having us here. So today I will be presenting advanced solutions for modern facade design. My name is Albert and I'm representing now one of the drywall leaders in the industry. So the topics that I would like to cover today is that we have still done a study comparing different facade systems that I would like to share with you. After that, this will lead me to talk about our product and systems for exterior walls, and then I will just finish showing 2 case studies in the region. So let's start with this file that we've recently done together with the help of Jacobs, and we've completed it with some internal calculations with ourselves. So what we've done is we've been taking into account like one of the typical buildings in Southeast Asia, specifically a residential building with a podium for the car park lot, and then the typical floor of a residential building. So before going to these images and the visuals, let me tell you that the black lines represent brick walls, and the colored lines, either pink or blue, represents drywall. So one of the comparisons that we've done is when we change only the exterior wall, so what happens when we change the exterior wall from brick and block facade to a drywall facade, or what is going to happen to this building, what differences will we encounter when we change all the walls, either interior or exterior, to drywall. So, some of the conclusions that we read when we do this process of switching the different typologies of walls in this structure is so that just changing the exterior walls from brick and block to drywall facade will reduce the whole superstructure weight to an 8.5%. So the structure of the building now becomes leaner since we are using a less weight system. So, and apart from that, so when you have, of course, a less heavy building, your foundations becomes as well leaner. So, and it's good to take into account that typically for this kind of buildings, so the cost of the foundations is between 25 and 35% of the cost of the total structure of the building. So, when we do this change as well, so we realize that the time of execution from foundations to the top off, considering the wall construction as well, so we can do the building 4.5% faster. So, when we do the change now from all the walls, from brick and block to drywall, so typically drywalls would be thinner as well, apart from lighter. So we realized that for the exact same footprint of this building of a style that we've taken for these apartments that we've taken into account, so whereas it's getting 1.3% more of the surface. So now, for the same building and just for changing the typology of the wall, so now we have like 1.3% more surface either to sell or rent. So, as you can see, the results speak for themselves. So now that we've looked into the overall picture of the building, I would like to go and check some comparisons between the systems themselves. So I'm going to start right to left. So if we look into a shear wall of this building, so typically, let's say, 15 centimeters thick, so we realize that acoustically it's going to perform more or less similar to an exterior drywall. But when it comes to thermal insulation, so we just say that typical exterior drywall wall, it's going to perform 5.3 times better for 10% of the weight only. If we do a similar exercise with a precast wall, let's say 10 centimeters, that would be like a quite common precast wall facade for this kind of buildings, we see that the drywall is going to perform 8% better and 5.6 times better when it comes to thermal insulation, for 15.6% of the weight only. And just to finalize, when we do the same comparison with the brick and block wall, in this case we've assumed 14 centimeters thick, so we see that the drywall is going to perform 10% better when it comes to acoustic and 4 times better when it comes to thermal insulation for 13.5% of the weight. When you put this other thermal performance to the drywall and you do that overall the building, so you can save up to an 84% of the heat consumption of the building according to this JPT study. So again, the results speak by themselves, like with all the benefits that are added when we shift from these brick wall facades to a drywall or exterior wall using the drywall technology. So now that we've walked through the conclusions of this study recently done, I would like to talk about the Aquapanel cement board. So this is the board that we use for exterior linings for the systems globally. So the board is composed by a cement core with lightweight aggregates, which is in between two layers of a screen, which is composed by glass fiber mesh, which is coated. In contraposition of fiber cement board, which is typically an homogeneous mix of cement with some organic fibers, being only from cement and completely of inorganic materials, we have like a slightly better performance when it comes to water resistance. Mostly along the edges, like typically we would encounter that we find some cracks here and there, mostly along the edges, but this is something that with having this cement board with completely inorganic materials we can avoid. So when it comes to the typical benefits of using a panel cement board outdoor, is that being made of cement, it's a completely inorganic non-combustible material. Also being cement is a product that has a pH of 12, so just because of that, it's mildew and bacteria resistant. It's very challenging for any of these creatures to grow on the board. And because of the inorganic nature of the product, so it's also water resistant. Being a cement board in a robust product, it still can be bended. So as you can see in the images, like the board is flexible and it allows the architects to go for curved facades and giving this freedom for crazy designs. Now, let me share with you like the typical systems that we have for this provision. So we do have a cladding, so we can use this board for claddings. We can use this board also as well for exterior work, for single stud or even double stud if needed for building physics requirements, or it could be used as well for exterior ceiling applications. So it's worth to mention that all these products that you can see on the screen right now can be sourced from a single supplier. So because from a panel side, we will be able to supply all the accessories, joint fillers, staves, exterior base coats, even the screws. So all this will come from one single source together with knauf metal materials, knauf insulation materials, and of course a knauf gypsum board for the interior lining with all the accessories. So all these coming only from one source, so making the whole process way more simple. So now we want to highlight these high-performance exterior walls. So we work together with knauf metal to put this window table so to be able to advise whoever want to use these exterior walls the most optimal and safe design for their building. And then those systems have been tested as well. So, for example, to 1 hour fire resistance or more whenever it's needed. So, and we've also done our due diligence when it comes to acoustic and thermal insulation. So, for this specific system, we can get an FTC of 50 and a thermal insulation U value of 0.3. And in line of highlighting this higher performance of these exterior walls, we've recently done this weather tightness study in Australia. So long story short, what this test consists of is like you spray some water, a lot of water actually, to the facade, and at the same time you bring in pulsating positive pressure, so that this green pressure is trying to push the water through the facade. So, and we can probably say that, being these restringent testing, so we passed up to 2.5 kilopascals of serviceability window and up to 5 kilopascals for ultimate. 5 kilopascals is actually not the limit because the test laboratory asked us to stop the test there because if we would increase the pressure, we would have damaged the rate of the laboratory, so they were actually worried about the integrity of their facilities. Rather, the facade was not moving at all. So that was like a very great experience. And now, having in mind the unfortunate recent events of the hurricane in Brisbane, knowing that there are facade systems that can pass this kind of restringent testing, I guess it's reassuring. And now, coming back to Singapore, I would like to share with you like this nice reference. So this house is, as we speak, it's under construction, and keep highlighting this higher performance of facade. So with a double-stood modular system, we are achieving a U value lower than 0.2. And when you put that together with high efficiency doors and windows, and you put this higher performance envelope system in a facade, so you can, of course, achieve this thermal comfort in a house, this additional acoustic comfort as well. But apart from that, this specific house achieves what we can call net zero. So that at the end of the day, the meaning of this net zero is that the energy that this house can produce with the solar panels that it's going to have, it can supply the energy that this house needs all throughout the year. So not only for air conditioning purposes, but also for electric appliances as well. And now, let me share with you and finish my presentation with this reference. So I couldn't finish without showing this one. It's probably one of our most iconic references in the region. So this is the Marcor Art Center in Beijing, in China. And I love to share this to the audience because it highlights probably the main features of now exterior walls with aquapanel technology inside. So one of them being this core facade, also this monolithic look, so no need of expansion joints, and having this crack-free systems. And apart from that, so this is an exterior wall, it's exposed to the severe weather of Beijing, so it can withstand winter, cold winters and also hot summers with rain. And it's been already 5 years since the construction of this, and no single cracks can be seen on the surface. So thank you so much for the attention. I hope that these insights that I just shared with you inspire for the next projects to come. And thanks so much again.
Thank you, Ahmed, for those incredible presentation, amazing products. If you need more information, please go and visit the booth and talk to Ahmed and his colleagues. Next, we have our next speaker, but after the speaker, we'll have a networking break. So please put your hands together for our next speaker, Chia Peng from ABC.
So, good afternoon, everyone. My name is Ashley. So, I'll be here to present on behalf of AGCE to introduce an advanced contour resin that is related to architectural applications. So, I'll be focusing on how this advanced contour resin can help to provide the aesthetic as well as the longevity of the building applications. So, this is an overview on what I'm going to start today. I'll give a brief overview on our company, AGCE, followed by the main part of this presentation, which is on our advanced contour resin. We call it as an FEVE, with our brand name named as Peng. So I'll be touching on the durability and longevity performance of this resin, as well as the aesthetic flexibility, as well as to address on the sustainability aspect and environmental benefit using the resin-based products. So first, short introductions of our company. So AGC formerly started known as Asahi Glass, started off as a glass manufacturing company in 1907. Over the past few decades, we have diversified our portfolio, and the business segment ranges from chemicals, electronics, architectural glass, automotive, ceramics, and life sciences. All these have actually contributed greatly to our overall AGC performance. So if we focus on our AGC chemical divisions, which is serve as a pivotal role in developing our advanced contour resin, we actually is a diversified and dynamic segment with encompassing two different segments, essential chemicals and performance chemicals. So essential chemicals cover on chloride and derivative material, while our performance chemicals actually cover a wide range of flooring chemicals that range on fluoropolymers, fluoropolymer films, and fluoroelectrodes. So all these materials have actually played a critical role in a lot of different industries. And for today, I'll be showing a fluoropolymer which is used as uniform for coating application purpose. So I'll go into details on what as a previous uniform resin is. We call it as a FEVE resin. So why is it so? So based on the structure, uniform is a type of fluoropolymer resin is actually served as a main component of Peng products. So this is a chemical structures of the uniform, showing the fluoroethylene and vinyl ethyl segment. So I'm not going to go into very chemistry terms, but just to show that this polymer actually provides the different functionality and properties in terms of the durability, as well as the other functionality like clarity, hardness, flexibility, cross-linking functionality, as well as compatibility. So what do I mean by compatibility? As I mentioned, resin is just a main component of the paint. We require other kind of ingredients to make into a final paint. So the resin need to be compatible enough with different kinds of ingredients to make a very high performance paint product. So with that as the main performance attributed by the resin, with the combinations of different types of ingredients, we are able to form different types of paint products in the forms of solvent-based, water-based, and solid-based product paint, which can be sold for different kinds of applications. So next step is a short introduction of our products. So now let's move on into its main features, which is the durability performance, which is very important for products that is used for exterior purpose. Because the key things that it will be exposed to is actually the UV radiation. So you need to make sure that material actually needs to be strong enough to fight against the UV. So back to the polymer structures itself. These structures actually form a perfect osmotic sequence, and this is the structures that actually created a very strong average bond energy of the polymer, which is much higher than the maximum energies of the UV radiations. So which means that this polymer will not be easily broken down by the UV and able to last very long under exposures of the UV. These structures itself, as well as its capability of being cross-linkable, it also helps to provide a very excellent chemical resistance towards a wide range of chemicals. So this has been proven to be able to meet the most stringent specification in the architecture industry, which is the IMO 2605 and Code Class 3. So how durability is being represented in data? So let's give some examples of how we prove its durability. So these are some examples of the weathability test done on the limestone coating, which is measured based on the glass retentions after it's been exposed to a certain harsh conditions or under very natural exposures in harsh climates like in Florida, in frost rays and humidity. So from the results you can see that the glass retentions is relatively much higher than other conventional resin. And for the graph below, showing the results after exposure 10 years at Florida, showing the glass retention is still as high as more than 80%. This is much more higher than the requirement of the single specification, which just require about 50% glass retention after 10 years. So this is based on data. So visually, maybe it will be much easier for you to understand what is the difference in the performance. So this is concrete panels coated with the limestone-based coating and an acrylic-based coating. This was actually exposed under Singapore climate for 10 years. So this is how it looks like. On the left side, limestone-based coating, there's no sign of color change and cracking, which shows that the coating still remains its integrity. But on the right side, already severe discoloration and cracking residue already observed on the surface, which shows that the polymers has been broken down. So with all these visual data as well as data and other quantitative data have provided, you can see how durable the limestone is, not only based on theoretical but also able to withstand the real-time climates. So first, two case studies to further illustrate the performance. So this is a Tokura bridge in Japan that is coated with limestone-based paint in 1936. After exposure for 30 years, which is in 2016, the glass retention still remains as high as 97%, and the color difference measured in delta E is as low as 2. So this actually indicates that the coating does not really degrade even after 30 years of exposure. Next, another case study that is in Melbourne, which is showcase uniform coating being exposed at a different climates. This is a building coated in 2022 with uniform-based paint, and in 2023, there was an inspection taken place, which is after 21 years of exposure. It showed no evidence of integrity, failure, or change in glass, just a very slight lightening of the color. So this shows that the coating still remains as strong after the exposure of 2 decades. So with all these case studies and the data, it shows how Domens is able to serve long-term reliability and effectiveness in preserving the beauties and the functionalness of the building. So let's move on to another feature. Another standard features on Domens is the aesthetic flexibility. So it's actually able to provide a broad range of aesthetic options, ranges of different color spectrums and gloss options. So for Domens is a crystal clear resin, it can actually blend seamlessly into a wide range of pigments. So for designers who are going into different kind of design, you can select either from very eye-catching color or very sophisticated tone, and all this can be done with movements, and it can ensure the consistency and long-term protection of the colors. And for gloss options, it can be easily adjusted to meet the gloss level that you want, from matte surface or to high line. So you can choose to have a very sleek, modern looking, or even a traditional kind of matte appearance using our uniform base paint. And next is on the universal application compatibility. So it can be suitable for any kinds of substrates to be coated on, ranging from aluminum composite substrate, fiber cement board, aluminum extrusion, glass, or fiber reinforced plastics. There are a lot more of substrates that is suitable to be used with uniform-based coating. So this slide I just saw some product references on where uniform coated paints has been used in various kinds of facade applications. So these are some examples showing how building can be in multiple colors using uniform-based paint. So just like as mentioned, it has a wide range of color options, so the building can be as colorful as it is. The problem with colorful building is whether the color can be preserved for many years later, or will it be faded after 5 years or 10 years. With uniforms, it is possible to preserve the colors even up to 20 years, as what we have shown in one of the case studies over 2 decades. Thanks. Actually, colors still remain perfectly fine. And here is another few more examples. Showing us how uniform coating can actually provide a very sleek and modern looking because of the high gloss property. Then another case study is that these are actually custom image types of a project. If designer wants to incorporate artwork in the facade, this makes it possible for durable coating, because if you want to talk about artwork, you want to preserve it as its original state as long as possible. So with an additional durable coating, you can allow these artworks to actually remain at its original state as long as possible. And the last major reference is just to showcase that not only just coated on flat panels, uniform-based coating is possible for complex structures. So regardless of what kind of design you are looking at for your facade, uniform could help you in terms of protection and aesthetics. Right? So this is on the aesthetic flexibility part of our uniform. So the last questions I want to share will be on the sustainability aspect and environmental benefit when we use uniform. So those are our dimensions that the main features of uniforms is its durability. So uniforms was founded since 1982. So since then, it actually is at the forefront as a sustainable coating solutions. So we provide solvent-based, water-based, and powder-based solutions to meet different kinds of environmental regulations and application requirements. So for solvent-based, even though it contains VOC, but because it actually is a very durable coating, it can actually minimize maintenance, which actually lowers the overall VOC emissions along its own product life cycles. And for water-based, we offer a lower VOC options, so they can reduce environmental impact. And we also have powder-based products, which is almost a no-zero VOC that is actually an excellent environmental-friendly option. So uniform not only provides the immediate sustainable solutions, we talk about durable coating, which means Another was to reduce the rate of recording. So with the reduce of the rate of recording, we not only reduce the waste generation that is usually generated during the paint productions, during the application procedure, we were also able to conserve the resources, efficiently use the resources for the coating purpose. And also have the reductions of the carbon footprint, because when we talk about maintenance, we will talk about transportation, labels, and all the repainting process. All these will actually generate carbon. So with the reductions of the rate for coating, you can actually reduce the carbon footprint with such products. And lastly, is the reductions of the VOC emissions, which I mentioned earlier. So we can reduce the soil coating, we can need to reuse paint for a period of time, like after 10 years, and then we coat after every time we do recoating. So with the minimizations of the recoating time, the total VOC emissions will be greatly reduced. Right? So with that, we have seen that by extending the intervals of the paint life cycle, we can move on these paints not only can provide the aesthetic options, aesthetic performance, but as well as providing long-term durability protections for the facade applications. So with that, I end off my presentation. Just to share one last message, as ABC, we have been developing technologies that is benefiting the earth in terms of environment, and we also ensure that we're also able to benefit people in terms of safety, security, and comfort. So we always aim for the missions to provide a chemistry for all blue planets. So that's all that I have from today. So if you have any questions related to products, please feel free to visit our booth during the networking sessions. Thank you.
Thank you, Peng, for that amazing presentation and sharing with us that extremely durable product of yours. Apologies, everyone else can take the coffee break now. Thank you.
Ladies and gentlemen, hope you had a good networking break. Let's welcome on stage our next speaker, Zakiah Supahat Züge from Populous.
Hi everyone, good afternoon. Thanks for coming back from your tea break. I hope everyone is feeling fresh. And I'm Zakiah, and welcome to my World of Façades. No, I've got nothing to do with this facade conference, but today I'll talk to you about a couple of things. The first, starting with what we are as a company.
I'm really proud to be your sports specialist. We are designing experiences, so we could do sports, entertainment, what have you. At every Olympics, winter or summer, FIFA World Cup, we're always involved in it. This is actually Convener Stadium where we have football, FIFA, we've got NFL all going on at the same time. At Beijing, we are about 1,200 global employees worldwide. We've got 28 offices, and we span all the way from the US to the Middle East, Europe, Middle East, and then back to APAC. These are just the numbers that we have. We deal with National Football League, as well as NBA, hockey, elite, and then we also do some other things, right? Like venue-anchored mixed stadium, Supahat, as well as airports and convention centers. You can see amongst all this, we really started with the big ones, the football leagues, and then it goes on to esports and concerts, because trends change all the time. So I'll talk about three things with you. The first one being punctuating the entity, the second one being curating pathways, and the third, building responsibility. It's a topic that has been talked about a couple of times today, so I'm not going to start away from it at all. What do I mean by punctuating the entity? So in this deck, we see that here, we have the bay around, actually this is Halong Bay. This is on the island side, actually the land side of Hong Kong. And all these are the residential high-rises of London. Everyone is aware of how tight Hong Kong is in terms of the GFA. We don't have a lot of space in between. But where do all these people go when they want to relax, when they want to hang out and talk to the neighbor that's not within the lift lobby, right? They go right there. And that's where actually we have the new Kai Tak Sports Park. Kai Tak Sports Park is the offering that we have in the residential community on the land side of Pavilion, and also I think the whole of Hong Kong. So this is how it looks. You see that is on the Kowloon side, this is Victoria Harbour, and interestingly, this is the old Kyoob airport. The land there is really straight because this was a reclaimed piece of land for Kyoob airport that was paid for the runway up to a point where the airport could not sustain itself. Planes were getting larger and larger and heavier, and the airport had to move elsewhere. So what happened when the airport left? That's an open land, and we saw this as an opportunity. All right, we keep all the residential over there, we know it's here, but we've got to keep this for the people. And this is how it looks at night. So it was a different character, and again, this is the respect that we kind of owe all the people around there when we build all these high-rises. Their responsibility also means that we consider what they do in their free time, how they can spend their evenings and weekends, right? So when I say penetrating the entity, these are then the high-rises. They're really high. The crowns of the buildings, they form the high peaks of these waves. We can call it sine, cosine, tangent, but basically high-rise altitude, and then it kind of comes down when it reaches Kyoob. These are then the retail and all the other podium buildings that are surrounding it, leading into what we have, the jewel of the entire master plan and development, and that's Kyoob. And you can see that as a sketch, you have to levitate it because that's how special it is. It is separate and different from everything else. It's important to create the difference and create that path goes through. So if you actually have a distance away from the residential areas, there is of course a huge opportunity to be a media mesh in some kind of announcing board, right? Because that is the view of all these high-rises all the time facing the harbor. So you can see the bottom part of it is more high-rise because you can go from the street side at the lower level, and the upper side is actually on the high end. So this view is actually what we see right outside Marina Bay Sands, right? So we're just here in the Expo, and when I say the entities of the city, we're looking at the high points. So we've got Marina Bay Sands, we've got the new CBD, and then we've got Pacific Pier comes down, and then when it gets to this side, Esplanade, and then we've got the old floating platform that gets pretty calm. That's us. So we are punctuating that low point, the calm point. And when we look at this, you can see that whilst it is important to create that identity of an icon as a tall, slender, 1:7 ratio building, you can see there are 3 plazas over here, each of them with their own identity. Traditionally, we've got the Padang over there, where the political, that's where you've got the Singapore Cricket Club, but the Esplanade is there as a cultural setting. It's a low point where people come in, offering music and all kinds of entertainment, 365 days in a year. That was our promise to our government, right? And then we've got the gardens by the bay, conserving ecology of flora and fauna on a reclaimed piece of land that is the most expensive park in the world. We waited 10 years to reclaim this, just to wait for it and let more trees grow on it. It's a pretty amazing statement, and that's us right in the middle, the low point of this bay in NX Square. So this is meant to watch out for, and you can see some construction with the marine paths coming in. Curating pathways. So once we look at the building and our types of buildings from a very high level, large scale, we're getting closer and closer. What do they see, right? Over here you can see that this is kind of like the traditional pathway. They're going along the length of the runway. We call it the runway walk. Some residential, there are 2 MTI stations on either side. This is the Pier Walk coming in, and we're at the main plaza. This is a meandering walk through the park, and that's what we are offering to the community as the extended backyard, because you always need to do something for the people, because this is taking up so much space, so much of their visual minds, that it has to be a positive association with them. And this is a big statement. This is our Sports Avenue linking the major diagonal zone all the way to the harbour. And it's such a strong statement that you can see that this podium building, which is split between the internal space ground as well as the retail. It cuts right through and you get directly to the harbour. It's so important that we get to split our buildings too, right? This is a view that you get once in life at the harbour. We've got the dragon boat similar to us, and this is Victoria Harbour looking back at the stadium. The concept of the stadium is also pearl of oil. We've seen a couple of pearls today, but this pearl is not a pearl sphere. It's a bit different because pearls, as we know, are pretty natural. And naturally, we're not going to talk about river pearls, just the sea pearls that are more round, not the drop-shaped ones. So what exactly makes a pearl, right? So the shape is pure, it's organic, there are no sharp edges. And then we wanted to make sure that it exists and it can stand on the ground without it looking like we're holding it up. It has to levitate. So you can see the bands, the horizontal bands, that's actually going to be the entrances allowing you to enter into the pearl. And that was how we came to it as a concept. On the close-up, this is the opening towards Victoria Harbour. So you can see there's a bit of water over here. And this is the south stand, and when we have Hong Kong Sevens, there's going to be the party deck. People are going to stand up there and wear their own mascot outfits, and with the view of the Victoria Harbour, they're going to sell it. So one of our challenges that we're very proud to have overcome is how do we create an opening in the pearl without it looking like an opening. So you can see that we need to start to dissolve the edges of the pearl from opaque to full glazing without being able to see the frame at all. Because when you look at a pearl, if you break it, if you try to cut into it, it's a fractal geometry. They all come to smaller pieces. So between 100% opaque and 100% opening, that dissolution has to be pretty smooth. Up close, this is actually an actual photo of our building, and you can see how it reacts with the colors. And this is with a single color shifting paint. The color shift, as you can see at the top of the picture, when it gets closer to the sky, it gets into the hues of blues, it gets a little bit bright, and then lower to the bottom, you get the darker blues, pinks, and magentas. And this is what was interesting, because when you were to see it from your residential building from a balcony, that could look a lot different. And then if you come closer, wherever you go, it offers you something different as well. To make this happen, we had to break those down into our favorite shape, triangles, because no matter what you do with curves, it gets down to either triangles, otherwise you can do with double axle curves. So there are actually 37,000 unique panels when we for the bid. We don't have the budget, obviously, but we started to make it happen. So from 47,000 unique panels, it went down to 2,000 unique panels. And how we did it was that we had to create a shape or a kind of pattern system that allows for the tolerances. So here you can see the gaps. So whenever we have a corner that you have to negotiate, that gap is in the tolerance for that triangle to be a little bit larger or smaller than it needs to be. Interestingly, in the 20,000 panels, there are only 2 main panels of different sizes or edges, as well as 5 sub-panels. The 5 sub-panels are rotated each way. And the color shift paint that has to be applied onto this, every time we rotate the panel, we have to take the number and the direction, and then paint it in the correct way in the factory, and then put it back in the right place. So every panel, 2,000 panels had to be labeled and made sure that we got it right. Every time we took it out, put the paint on, put it back on. Yeah, that's the amount of care we have to do with the pearl. The cool thing about this is that because it's a rain screen, that means the gaps that we allow for the triangle to exist and to recreate a pearl shape, that rain screen would then prevent streaking, so all the rainwater would go through. And it's okay if you don't have access at all, you're not supposed to stand on it, but clamping has to be very, very fixed and secure. So the first layer we see is rain screen, so rainwater goes through. We've got the second layer, which is the LED point light. Again, as mentioned, more density of LED pucks at the bottom, and then at the top, kind of 50% density. then you've got the rail system to hold them on. At the back of this is actually the traditional metal decking system with insulation and acoustic properties, and that was how we managed to keep the fluorescent appearance of Kaita, just by making sure that it was just serving their side purpose. Acoustic thermal, that's all we inside. So this is Kaita's thing, and having built, you can see we're pretty proud of it. This just opened in March, and it's going to host co-play very soon. Next, I'll talk really quickly about building responsibly. We talk a lot about our facades, our buildings, and how amazing it is, but like it or not, even though Trump is in power, the world is still burning, and we need to approach it in a way where we're not just substituting things, we are approaching in a holistic manner, right? So first we're thinking how to bring design and sustainability together. One of the biggest challenges is, although a part enjoying a better and better, is sports, stadium, airports. They do consume a lot of carbon, especially on the front end. But how then do we make sure that this is all, it allows for it, right? It pays us off. We make sure that we make very people-centric. We pride ourselves on having maximum flexibility, and one of the things that we are most proud of is working with mini giants in Tokyo, where it's a baseball plus a football stadium. So you can see that all of these shapes are rectangular, which is pretty easy. So rugby can be played in football, but baseball is a little bit of a wild card. So we're trying to sort that out in Tokyo right now. And then when we get to the environmental part of it, we have to approach it in a more holistic manner, right? So I keep talking about us being people-centric. We bring 50,000 people into our venues at any point of time. So if that place has, in a year, 200 event days, then already we pull it off. Already we make 50,000 people come 200 days a year, and that footfall keeps coming. It's not a white elephant. That's very important for us to make sure that the operators, the owners, they know how to run it, and they make sure that this money is embedded in the people that live there. So in terms of being people-centric, we draw people together. That's our tagline, by the way. And the economic sustenance is also important. There's some really good examples. When a building costs too much to maintain, it gets to disrepair. So something that looks really beautiful is actually very expensive upkeep. So that is also our responsibility trying to make sure that it's something that you can work with, it is long-lasting, and it will bring in returns because every time you have an event, you have people coming in with you. But let's talk about the environment bit of it. So I mentioned at the beginning, it's going to be, we definitely have to put in some embedded carbon in there, right? Concrete is really hard to replace, even though it's very expensive on an environmental level to use. But there are ways around it, and I'll start with my first example, which is the climate pledge arena. Now you're going to wonder why I'm showing this very nondescript building in a facade conference, is because Popular's didn't do it. This was done in 1962 for the World Pavilion, and this is in Seattle. What we did was that, okay, this place is like really precious to the people, but they want to go in with it. That has been running the community forever, right? You can see like residential over there, the park over there, and like mom and pop are going to bring the kids through to the kindergarten, and it's this visual that's embedded in your mind that's considered normal, and they don't want to part ways with it. They don't want to, maybe a toilet is not right in this environment. So what we did was that we dug out, see, that's the glazing, we dug out everything that's below, and then we pulled it out by lifting the roof, which was 44 million pounds, and we just did all the construction. I mean, don't ask me how much it is in metrics. I have no idea whether it is pounds and yards. So this is the 1962 World's Fair building for Seattle, and that's us. The amount of soil that we dug out was 680,000 cubic yards, and that was more than twice the amount of size of the whole space itself. What we also did was, if you see the original glazing that was part of the World Fair, we restored it. So it's respecting history. It's also kind of saying that you don't have to go anywhere. We can still actually bring life back to the facade, and that would be even more precious to you. We pride ourselves on that. So this is actually one of the first arenas that have reached carbon neutral by the International Living Institute, and also one of the few arenas where you can access at 360 everywhere. Usually arenas are black boxes, right? Because you want to create a concept, you don't want people to peek in, that's right, you got to pay a ticket. But here, it does create an atmosphere of light coming in at the foyers, and also what you said just now, you could actually peek into the hockey games. Because if it's a team playing, why not support them by watching outside? So, this is the next this is National Speed Skating Oval. So the first topic that I talked about with Convener Arena was it's okay to build less, right? The second one, the point is embrace technology. We've heard from so many suppliers, people have done their PhDs and theses about specific materials, and let's embrace it, let's use it. So what we have here is the National Speed Skating Oval. Beijing is one of the few cities that have hosted both summer and winter Olympics, and this is a dedicated venue for speed skating. Now, speed skating is we're very particular about the ice. To get the ice as flat as possible for the speed, you need to have this is where I get technical too, okay? You need to have a delta T as low as possible. That means the temperature difference between the surface that is cooling the ice as well as the water. This is going to do that through transcritical direct carbon dioxide cooling, and it actually takes less energy to use this than anywhere else in the world, as well as it can be, it's also done by renewables. So this is one of the technologies important to us because as populace we do deal with a lot of national hockey league, especially in the US. So this is just another view. If you've heard of farm forest function, probably heard of farm forest motion. Because when you go skating around the rings and then you gotta turn the corner and you gotta go really deep, that's that portion, and then you can go really high and fast, that's that. So what we did was to replicate and mimic the movements of these athletes as they run around the ring and do their laps. And we're really proud of this truly being an icon of speed skating in Beijing. Interestingly, this is how it looks on the inside. We call them 22 islands because each of them fills in with the correct facade, making quite an interesting experience walking through on the concourses from the outside. And these are just some quick sketches showing like how important it is to come up and down and also to pinch right at the corners, creating the dynamic motion. And that's how it's been built and integrated into the city. You can see that it's an extension of the rest of the sports park in Beijing, and that's still here today. And this is a quick cross-section of how it works, just blowing down, and it looks nondescript, but as a whole, it really sings us, and pretty proud of this one. So this is another stadium that is open for us. We actually did a renovation. This is in Strasbourg, in Europe. It's on the border between France and Germany. And what we did with this is that it's a stadium that has been made for a long time. We find that in Europe, our market is more of renovations in Europe itself, and then when it gets to the Middle East, of course, it's more new builds. So similar to Convener Arena, right? Build less, but whatever that you build has to be sensitive enough that people can relate to it and still draw people to it. So that's our commitment to the plan. So it looks, again, nondescript, but if I could lead you to the right side of the page, these are actually airplane fuselages because this stadium is actually pretty close to an airplane factory. And you know what happened in 2020, right? Everyone had to wear masks, and to jokes, don't have a mask, and things like that. So during COVID, a lot of airplanes were grounded, and 20 planes were deemed unsafe for flying, and they were just disused. So what we did, because we were pretty close to the factory, was that we used the fuselages of those planes to be part of the facade. Now, we just trimmed off the top part. We kept all the original structure, the original rivets that created the curve, right? And then we just put it onto the building substructure, and that was it. The physiological angle of it also acted as a modern green solar. It was reflecting the sun, and the views that we get are actually directing towards the park, because on this side is actually residential, and the park faces this way when it opens up. So that's that. That's an Airbus 320. We just slice it up. If you're wondering what a fuselage is, I'm running as well right now. So 20 planes of that gave us 196 panels. Put them up on substructure. We had to cut it up for transport as well. And this is the first thing to be constructed using parts of old passenger airliners. So this is really something it's a statement, right? Like bringing upside into the next level. Lastly, I'll just leave you with some images of Munich Arena, and the closing statement will be single with the future. And you can achieve sustainability without sacrificing on identity, without sacrificing on design or looks, because BMW is from Bavaria, and Bavaria has the rhombuses on their flags, like the BMW logo, or adding years of Magliano. They're the rhombuses, and that's their identity, being a Bavarian arena. We managed to have greenery on it. We also have timber outside and on the inside. One of the biggest challenges with the size of the buildings is whenever someone comes in and they like, I don't know, Taylor Swift or Lady Gaga wants to have followed by screaming from the roof, that roof has to be able to hold all the speakers and equipment. So that is the challenge for us as a timber structure. And we managed to actually pull it off so far for the roof, and the seating was like a hybrid steel and timber construction. So this is actually pretty close to the airport, and it's led into with the park. And there you have it. That's really the video, and that's my last slide. So thank you for listening.
Thank you, Zakiah. I think the presentation certainly managed to punctuate the amplitude of the conference today. Now, let's welcome on stage our next two speakers, Alberto Fiorenzi, founder and inventor from Ahmed, and Ku-Tek Young, official director from RSP. Okay, good afternoon, ladies and gentlemen. I will try to tell you 14 hours of this 27 minutes, very easy, but it's a privilege to be here and to realize it's not so common nowadays give you a presentation. So thank you for hosting me. Ahmed is a simple product in fibers made. The fibers we utilize are called the super fibers in the engineering world because of the strength, the tenacity they have. We go from cast fiber to zygon, passing through basalt, carbon fiber, and the images here. In fact, we do the colors of the fibers we utilize, we have natural colors. The blend of various combinations of fibers increase the color range of the product. What we do with these fibers, we do open surfaces, porous surfaces. Through the porosity, we control the performances of the surface itself. So we control the vision, the privacy, the light, the heat when we use it out of the door, the ventilation, and of course the wind loads. As you can see, we can place fibers in any direction, whether in a straight or curved path. And this capability, total freedom in creating the mesh, allows us to give a cultural meaning to what we do at the same time, and definitely a very high-level aesthetics. Framing for development fibers means structural performance, and at the same time, the control of the performances I described before. One important project that we did was to cover the Baey Expo 2020. But I will get down to that. It's one of the applications. So we do protect people and buildings from excessive sound radiation. Covers is one application, Façade is another application, again in performance or just to give an identity to the facade. In interiors we do ceilings, we do partitions, any type of curtains. I like to focus on this project because this project is explaining what we can do. 53,000 square meters of sun shading devices expressed in membranes which are 23 meters by 12. And the scope here was to make the solution as sustainable as possible, so utilizing the least metal as possible. The key of the solution to install was to make a pergola which is retrievable. Therefore, when the wind will become too strong, it will close the membrane and therefore the roof will vanish. One thing that you might notice is that there is no beams in these pergolas. This is the largest system ever made in pergolas, and definitely the unique system because it's beamless. In other words, there is no beam going across which hold the fabric. And that is possible because of the specific structure that we designed, which, as you can see, is two levels of language, if you want. The micro mesh is the one responsible for the comfort procured by the membrane, while the tapes, the large tapes of fibers, are the actual skeleton information, is the structure that we actually calculated would take the weight and the windows to the attachment points, which are 12 on each side. So whilst during the day, this membrane increases the temperature, perceived temperature, up to 5 degrees C. During the night, it turns into a golden ceiling, which you can imagine in the Baey was much appreciated. The peculiar installment system, attachment system, which is done with these loops, which are part of the structure itself, actually made the solution very easy and quick. In 2 hours, we would install a membrane of 160 square meters, only with time. Very good, fine. So let me talk to architects. We don't only provide a piece of material, we don't provide a membrane, we provide a service, and together we design the material itself. Of course, we have the CFD and EDA capability to analyze the performance of the material very quickly through pavilions at Osaka, the Italian pavilion. The panels are 9 meters high, and they've been designed like they were made by hand in 500 years ago. That is because the pavilion is inspired to Renaissance. The opposite is one of the Japanese pavilions, which is carbon fiber made, station of technology, a skin which actually kind of setting because it's washed continuously by water. Okay, so I move to you.
Yep. So I'm having juggling between design practice and education based on ISP and SCTV. So I'm really interested in rather contextualize the activities of our managed project that we did collaborate with the organization in Singapore. So this is the first project of Michele. As you can see, we use dimension extensively on the facade, both on the interior and exterior, so that this really nice of daylight sort of structure that wraps around the interior of the H&M shop. But we were very courageous to use the sort of the story and sort of design for
project from start to end to the end, which I can tell you is a really, really short amount of time for any type of project, which is a refurbishing project. This is the start of the first outpatient manufacturer for Singapore, and it opened way back in 2011 to much cancer and long queues, which I was not there. But this event is this, of course, is this global fashion icon of fast fashion, and it's represented as a unique opportunity because of the site where it sits in the intersection of the Supahat and Orchard Road, which is not unlike a really iconic Art Deco building in New York City. So there's this really, back in 2011 and then in 2022, there's a really long time for really competent research for this facade at Orchard Road. So we first thing we did was sort of understand the history of the really big identity, aside from that sort of iconic red and white, and so many kind of undertones. It also has this sort of overriding planning concept of this blank canvas of appreciating creation. So for us, we took inspiration of blank canvas through projection screens and sort of crystals projects on wrapping, various beautiful projects in solid to sort of line up with the idea of different business of this textile fashion industry company. So we did many iterations of this blank canvas, testing the limits of what is done. There's going to be trying different materials, EPSC, PPDC and all that, but we realized that iron was the most suitable material to sort of realize our design ideas of this blank canvas. So we had a lot of fun discussing with Michael, back and forth, really trying to figure out a facade with the least amount of support structures, so that we actually end up with just support at the top and the bottom with no vertical structure at all, no frames. All the frame structural components are done in this customized panel along the sides, and you can see it further in detail. Of course, the other reason chose I mentioned because it's a really sustainable material, it's a zero waste production system, and it's fully recyclable. And of course, we also did many tests regarding the porosity of this wear pattern to ensure that there's thermal comfort in the interior space itself. So because the timeline is really short, we did a lot of our own sort of mock-ups within the office to try to figure out what's the correct porosity, what's the correct sort of detail that we wanted. That we could see a really minimal look, because the case of people, it's like a simple facade requires precision. And we were also interested in this idea of how the facade can be performative, how to carry on that curation of different sort of products, different sort of seasons, and the sort of history of collection, and how it can be projected on the facade itself. And again, we did many sort of testings on we did it by ourselves to really have the distances of the LED lights with the black pores through the dust to carry the projection. And this was some reading sort of testings that we did. Yeah. So these are our fun viewers. So we were really happy with how it turned out in the end. This was all completed in 9 months. So from the extent of how you can see how the previous design was just really eliminated the sort of blocked out all of these, and from the internal external, there's no connection to the street. So now what you have is this really nice and light veil facade that's around this Art Deco building. You can use Art Deco building at different scales. So from far away, you sort of see this white veil when you go nearer, so the details of the Art Deco building start to reveal itself. And so the details, you can try to see that the sort of thin sort of structure that we have attaching the vertical lines also where all the sets of combined goes for structural support, and then you sort of detail this sort of trim cover also to be in line with this really nice textile flat facade that we wanted. So you can see that the light starts to take on a different character where the sort of light and interns starts to spread out into the street. And then from the internal space itself, we have this really nice sort of veil that's you can kind of cover on the interior, but it also gives you that sort of direct visual connection to the street. Then, of course, when you go through the video, at night you take a completely different quality of the facade. This really simple facade, just a different color. It's really addresses a really nice dynamic of streetscape in Vancouver also. facade itself is the programming is meant to change over time. So recently we had Pavilion, so it's the reprogram the lighting, so it's constantly changing to sort of fit that sort of long-term work and everything is a curation of that vision that Matt was alluding to. So we're really happy with what we've done in Singapore together, collaboration with Berkeley. We had a lot of fun. Also wanted to highlight the collaborators that we always work with. I can see some usual faces over here. I think PhD Sigmund is here, which is very fun to collaborate with. So as creators, we really sort of happy to come together, really make a difference. And, we hope we left the world a better place than before. And this is what we have to share with you today. So I'm running a little quick, so that's just what I have. If you want to, it's a step in the back. You had more after that, I think that was interesting experience for us, also because not only because it's unique installation, once again, we're going to do a framework facade is something kind of not really unique, but also because working from remote has been effective. I mean, we have been here a facade which has been extremely useful as an interface with the office, but the majority of the decision has been taken in Singapore. It was really helpful for us. We really managed to get the sort of facade concept really quickly within a really short amount of time. It was really a struggle to sort of get this project out within 9 months. Yes, it was. But it was successful. Thank you. Thank you. Thank you all for that presentation. Amazing project, particularly like the gorgeous screens that you presented, very beautiful. Reminded me of fine fabrics from the European world, and I can only imagine the beautiful light that comes through those screens and falls on the ground. Thank you for that. This is the last discussion for the day. We have a panel discussion coming up, and for the panel discussion, I'd like to invite Mr. Owen Lee, Associate Director from SA Group and SAA Architects. Alright guys, well, good evening. Good to see a good talk still around with us. And we have an exciting panel today. I'll start shortly. First, ladies first, Ms. Jané, Deputy Director of Capital Group, who has worked on various iconic projects like the Jewel, Vista, and she was also a speaker at Women's Engineering at NTU. Next we have Mr. Ajit. Okay, he's still working up. Next we have Mr. Alan Lau, who is from Pasca and Partners, who looks at design through adopting innovation and intuitive design, and is especially interested in architectural design in the tropics. And that is really an important subject that we will dive in a little bit later in the discussion. And last but not least, we have Mr. Ajit, who is an Associate Director at Norway Thailand. Ajit has worked on numerous high-profile projects all over Southeast Asia, South Asia, Middle East, US, and definitely looking forward to his experience in so many localities. Before we start the conversation, I will want to narrow down this particular topic a little bit to listening the demands and complexities of today's facade in the tropics, because this is where we are. And I personally believe that in the next 20 to 30 years, this is where most of the global construction will be at, all activities will be here. So it is apt that we talk about this and how facade will be in the future and where it is. And I'll try to tap on the expertise and experience of our guest panel on behalf of you guys. We will allow a little bit of time later on for questions. So think about it, and then when I raise your hand, we will want some questions from the floor. We're done right into it? Okay.
The first question will be for Vanessa. Ladies first. With your experience in working in brands and the urban life landscape, of which many times the developer acquires an asset that is newly acquired. So as a developer of so many projects, so what are some of the struggles that a developer will meet when you go about doing such projects?
Yep. Hi, everyone. Yeah, can you hear me? Okay, with the increasing challenge in the post-by climate change, sustainability can no longer be afterthought. So investors will often look at explore how do we conserve the building and adaptive use as a viable solution to the existing building. So returning each facade rather than recladding actually can reduce carbon footprint and as well as aligned to the sustainability practice. But looking at that, it's also posing a lot of challenges, significant challenges. As each facade, we all know that definitely have a water leaking issue, and also the outdated glass panels might have not meet the current modern thermal performance and acoustic performance as well. So, the components, be it plastic, cement, it might have disintegrated that we have challenge to replace it. So, this factors actually require careful to balance between the functionality and the conservation, right? Business to retain. How do we approach, to upgrade the facade while having this sustainability goals in our mind? Yeah.
Maybe I just follow a little bit so that I understand a little bit more. So, from a developer point of view, when you approach a new building and old facade or old conservation building, will there be a different metric and different KPIs that you're looking for in terms of both performance as well as sustainability?
Yep, of course, looking at the existing building, we need to look at the whole life cycle of the facade, including the maintenance, etc. When we talk about, conserving it to reduce the carbon footprint, but if the current condition, if that doesn't make sense to keeping the carbon footprint, it is better actually to do a full replacement and have a new life cycle for the facade. Yeah.
That's really interesting to understand. So, actually, a similar question, okay, but from an architect's point of view, what are some of the factors and considerations when the scale and locality are so different in so many bands and other cities that you have been working in? Yeah, thank you. So, for me, it's international practice. So, we're working not only in this region, but also in other regions. So, the challenge is really about understanding the geography of places, understanding the context, and how we can mitigate the design or creating a design that is affecting the wellness of the city and also people, and how we can bring the emotion for people. Because we understand that we're designing not just because of the technology, but also the end user for the people itself. So that's something that challenging, and because we do it in different places, that gives different kind of solutions in different places as well. So we cover sectors of people, all play a major part in some of the projects that you are involved in. Actually, cool. Okay. Alright, good. So Ian, you want to add on there?
I think you brought a very important point where human-centered design, human comfort. That is less complicated. I think whatever design for is actually for people. And the element of human comfort is so important in response to the climate that we are at, which is in the tropics. By 2050, 50% of the world population will be living in the tropics. But yet, if we look around our cities and cities around this region or along the equator, we are designing buildings that are meant for the temperate climate. There's so much glass, so much glare, so much light. $1 million view apartments have their blinds down all the time.
right? The $1 million view that you bought, you couldn't enjoy, that's like a feeling. So the way we approach this, first we need to look into the past. Research is such an important element in our practice. And I quote from Norman himself that as an architect, we design for the present with an awareness of the past, but for a future that is essentially unknown. So there's too much to learn from our ancestral houses. 100 years ago, or 150 years ago, in Malay houses, they didn't have big windows, they didn't have air conditioning, but yet they lived in comfort. Maybe not so long after, the British arrived, the two-room houses, the black and white bungalows. Again, small windows, but sufficient for everyone to enjoy. Natural ventilation was the key part, the verandas and all passive environmental design. But not too much later, the shop houses, some are still existing today, didn't have air conditioning as well. We had small windows and air out of the Pavilion center. That gives us comfort. They give our ancestors comfort. And perhaps, when more international architects arrive, such as Paul, one of my favorite buildings in Singapore, the Colony, they have very small windows system. But yet we look at buildings around our cities today, there's too much glass, too much glare. Are we designing right for something that I question? Have we forgotten that we are actually in the context? So I could not help agree with Aaron. So we must look to the past, like the compound house. So why we cannot use the compound house to wholesale in the normal setting because we are living in high density buildings? The perhaps some of things that we can understand is the slopes, how the wind flows, the bigger windows, the shading is utmost importance, cross ventilation. All this can be applied in modern buildings, and we can see some very good examples here in Singapore. Exactly.
I wish to add on to this part here when we talk about past and present. And I think the industry have, in terms of designing architects and these days, I think modern facade design is actually evolved beyond the technical or the performance aspect. It is now placed a crucial role in mitigating what we call the urban heat island effect. So one of the emerging strategies is to put these green elements to integrate within the facade. But having said that, we also need to look at what is integrating to it and how is it involving the maintenance aspect in terms of selecting the plant species, for example. Right? For example, we put trees at the roof. Then we need to find out how often this leaf get that, and it's not going to fly to my neighbor's roof and disturbing So all this, I would want to push in all aspects, the designer or the engineers, to look at it, how we actually are implementing all these green elements, and how do we actually think through and think of it as a holistic approach.
And this thinking is not in terms of a short term, but it's a long term, the whole entire lifespan. That idea is actually interesting. If you talk about Singapore with a lot of greenery and stuff, it's a design that helps also to create like the shading sector. If you talk about now the Convener building, which has all of those kind of shading elements articulated becomes a facade. But I think Singapore trying to attract this kind of green kind of ideas into the facade itself, and that creates somehow this kind of shading elements into the building. But I think I understand the point about creating, thinking about how we can maintain this. That could be something that we think as a solution. But I think the idea of taking that becomes the future kind of identity for Singapore itself could be quite exciting. Especially when I see a project with like capital square, right? But if I see the building, it's pretty simple. It's actually just straight kind of a glass facade. But then suddenly with moments of openness with the crane, etc. So that creates like a identity that I can understand now. Oh, okay, that's maybe in Singapore because of this crane festival that happens actually on the ground. They put it on the rooftop and the building as well. So that helps also. I think as an architect now, we also think about how to think about the future of Alan mentioned just now, and how that becomes the new identity for the city itself and keeps some emotion for people that belongs to them. I think it's philosophical and human attraction to what we deliver into the society also becomes very important. And this aspect about creating the greenery, the structural engineers, the landscape architects, the designers, and even the MAE of how to feed water and nutrients to this, the plants become all very integrated. And this is where I think what is the point that Sona is trying to say is that the client itself must be very committed to this. And my experience is this, that the one that we did, the energy builder at NUS, the client was extremely committed and they were willing to go the extra mile. Certain things were never tested before. So certain things like that, we really need to work as a team, and the client is actually that holds everybody together, while the lead consultant can direct the technical portion of it. So that's very, very important. Maybe I should move on to the next question. Okay, again, looking at the various trends and buildings in the building industry, what do you think are the demands of the facade today and into the future? Because we are now building for the future, and like what I was saying, in 2030, 80% of the people will be in Asia, and then out of that, really high percentage, if I remember my numbers correctly, it's also another 80% of the population in Asia will all actually be in cities. So what do you think, what are the things that we need to look out for right now in order to build for the future? I think come back to the point of being human-centric and design. I thought the wellness on the facade design is important, wellness-driven facade design, and also how facade could basically respecting the people that inside as well, in items or somehow another way. So it could be maybe something that we need on the next. We just finished the control Atlanta in Jangho, which is quite interesting. It has like 12,000 square meters of corporate office. So you can imagine it's huge, it's deep. But the way we think about the building is not just being an office building, but actually we think about the people who's going to use the building and how the way they work. So we think about Google, it's very active, very collaborative, and we always think about the wellness itself. So we sort of have an idea of that flow of people that can be reflected in the facade. So our design is really well to mitigate the darkness of the big portrait by having somehow like a flow kind of massing, which becomes the 3D kind of idea of facade rather than just 2D. And how then that facade is basically affect each other, creating a better facade, and that creates the space for people to interact, to communicate, to collaborate outdoor space. But that's also in somehow, I can say it's in architectural kind of solution. But then there is another problem, which when you put that building in the glass, there will be a problem of something that is very big. So what it comes to now is to also make use of the new new technology into the facade, which is the smart car system. Which the customer can almost adjust whether they can have more sun penetration to the building, or they can reduce the space. So that's something that I think the future kind of thinking of how we can make use of our expertise as a designer, and also make use of the technology to make the people inside the feeling more kind of eager to use the building in a comfort way. So the design must be designed in the livable as well as designed for the people in their context. And then at the end of the day, the facade of the building will react to the individual user needs of the space at the same time. Good, yeah. Okay. So Alan, as the fellow architect that is based in Singapore, do you have the same demands and experiences, or rather the same response in this case? I did bring up three-dimensionality. The facade is not just the elevation, right? And sometimes there's gray area. For example, I speak about the ancestral houses. The veranda is something that we might be familiar with, sort of it's an extension of the indoor areas, but it's still exterior, but at the same time protected from the weather elements, the harsh climate, the heavy rainfall, and the sun that's always too hot. Would that then be considered as part of the facade, right? Because I think what I is that we should consider the facade beyond just two-dimensional, but taking account the planning as a response to the programs that is inside. Yeah? And that would somehow drive inside. Is it designed inside out or outside in? I absolutely agree with that. So, a few years back, when I was talking to a fellow panelist, we were also talking, if a facade can do multiple things. It can be where your community spaces, like for example, a balcony. It can be where you hang your garden. Okay? It can be a shading device. It can be a second screen. Then, in a way, it's actually paying for itself already. Because with all these things that you allow the facade to do, okay, actually the cost comes down both tangible, so because if you use it as a shading device, if aircon comes down, mechanical systems come down, ducts come down, you get better height, you get extra floor, etc. But also the communal space there can be done as well. So in terms of the owner, as a developer, and with so much of our stakeholders that increase knowledge, etc. So this is increased demand for the developers, especially as a listed company. So a little bit on this, from that aspect, the demand. Alright, let me give you overview. I mean, the facade will be more intricate, definitely, will be more visibly striking, yes, in time to come. But however, with the complex design, it will mean that it will be more challenging. Of course, I mean, with thanks to the advanced technology, I think today has been shared by many of the speakers. I think for this, we are able to navigate all this, through means of smart technology, digitalization, etc. But I guess innovation is not alone. Yeah, I think the collaboration is the key. Developers, for example, architects, consultants, contractors, and engineers, I think we should all work together to find a solution to get the right balance between the architectural aspect, smart technology, and sustainability, last but not least, cost effectiveness. I think many times I heard that developers wants it all. They want fanciful facade, able to interact with the climate change, want to have the best smart technology within the facade. And we concluded with making that the budget does not break the bank. So I guess investment in facade innovation must be strategic. Ensuring that the capital expenditure is directed towards features that deliver the highest return in both aspects, financially and environmental.
So by doing so, we can create a facade that is visible, striking, and as well as financial sustainability. Yeah, sustainable. Yeah.
In simple terms, we say, I mean, the longer the building lasts, the more value management it is. It's a life cycle.
Correct.
The quality, in fact, is actually very important more than quantity. Because I feel that in this nation, we tend to be obsessed with quantity in terms of data, numbers, amount of green, amount of shaded areas, and all kinds of the numbers that we can forget about quality. Do people actually enjoy these spaces? What's the quality? And all these are sort of intangible elements that one cannot measure, at least not on the computer, right, to justify the means. Yeah. I mean, there are so many great buildings in Singapore that outlive their neighboring buildings, and some are being transformed as an adaptive reuse. Right? And the other you yourself have some experience in adaptive reuse, and whether not to say the entire building should be conserved, but selectively, appropriately, let the numbers for you. Maybe you want to share more of that?
Yeah, I think on this approach, we have to look at all aspects. I think right from the start, like I mentioned, the collaborative effort of everyone is very important because we all have our own expertise. So, be it design for maintenance or design for safety, etc., does help to prolong the facade life cycle. So, like you mentioned, as long as you can keep the facade well, away from the water decayers and all the deterioration of the materials, then I can keep, this facade intact without, and spending more money on it. Yeah.
If that's the right kind of creating holistic facade design on the building itself, to make people want to live in happy to have that building in the city itself. And as you mentioned about that being longer period of time to stay there, I think I agree with that because if now we're seeing a building in the city that happens like 50 years ago, if you like that building, even people want to demolish it, we need somehow make a master. So if we really need the land, we're going to think about how we can preserve that building or how we can build around the building. So I think for us as a designer and maybe developer as well, it's also start to think about how we can keep legacy to the city itself. So not just building any kind of architecture, but actually something that really strong and people believe in it and happy to have that in the city. Just now you were talking about obsession. Okay? So it hit me. Singapore is a nation obsessed with regulations. So as both of us practice in Singapore, maybe you want to talk a little bit about some of our audience members that are not from local. What do you think? Has the regulatory system in Singapore drive the facade design, or has it become handcuffed to an architect's hand?
I think as we develop as a nation, we become more conservative and playing safe. I think we should sometimes, take the gloves off and reward points for people who try to do better, and it's a case-by-case basis. That is something I would highly advocate for.
But the next question I wanted to which Alan sort of tossed to John earlier, and it's a balancing act. Okay? When you go in and you retrofit a building and all that, you are looking at asset enhancement. So when you maybe some background and thinking on that. So when you spend the money, you are looking at also when you let go of this particular asset, how does that thinking go
in at the stage where you just got the building and then you are going to refresh the building? Are you thinking about letting the building go in 10, 15 years, and how does that affect how much you want to do to the building?
I think it's more on this aspect whether to let go or not the building. I think we have our team to study that. But on our approach, we will actually look at the user experience, whether the building still can sustain our current evolving user experience, for example. So that we will have to study, and then it has to match. The user, and no point that I try to save a building and then I can't get somebody to lease it out, and I have our competitors, having all this plus point. So that is a balancing act, like what I mentioned. But over at my company, we take very strong consideration on user experience. That's very important. And we look at it as a holistic. It's not just a financial and aspect. Yeah.
One quick last question on this. You can choose not to answer. And I got some numbers from authorities and some, QS buildings and all that. Do greener buildings sell better? That's the question. I mean, you can...
Definitely, with my experience, be it Züge, Jangho, or Capital Spring. Of course, I think especially financial institute, I think they have to meet some sustainability requirements. So if your building has a WELL certificate, platinum, FSC, SIE, I think these are all the plus points as much. But like we mentioned, we always do a balancing on it. But as much, we will try to be sustainable as much.
So there is a small premium when you let go of compared to somebody that doesn't have the green credentials to the building.
Yeah.
Okay. So has it ever come back to bite you? It's all good, it all looks nice, but maintenance you brought up is challenging. It's nice, but the developer, because you own the building, you need to take good care of it, such as plants in our house. This looks nice on day one when we buy it. Long run. Again, you can choose not to answer. Rather than speak about quantity versus quality, yes, we achieve 20% green, but then is it practical in the long run?
I think it really boils down to complex building versus is it true that it is more difficult to maintain? I would think yes and no. Yeah, I would think it's yes and no. I mean, it looks beautiful. That's why I say that I keep emphasizing on collaboration. The reason is because as we know that if we know that we have green elements, that's popping out of the facade. Because from day one we have to, work with our landscape contractor, like I mentioned. How to use shade, and how does it mean that I need to have my maintenance people, exposing to danger, I need to every time they prune the trees and things like that. So there are a lot of things that we need to look at it. Yeah. And then from there we will think that which is the most important area that we need to focus. If this is really, the design, it really brings a big part about it, then we must think of the best way to maintain it and to reduce, even from the design, installation, we need to think of how, productive and by means of all this. Yeah. So it's important that we need to connect it.
Yeah, Fiona, you're so right. To get the right expertise in as early as possible to address them, you might be saving a lot, and you sound like an ideal client.
I think many of at least have before, yeah.
Okay, so it's come to a time where I'm going to ask the audience, do you have any questions that you want to ask our panelists? Anything? Quick one? Nope. think everybody wants us to just continue. Okay, so, all these demands that we were talking earlier with integrated design, with regulations, design, what are the tools do you think you use or could use in order to bring everything together in this day and age?
What are tools I can use to bring everyone together? Maybe you can rephrase it. So what are the tools that I need?
Is it in the terms of design tools, digital tools, roadmap technology, and I don't beam, maybe more experience?
Well, we're quite lucky as a company where more than just architects, we have in-house engineers, structural engineers, design engineers, interior lighting, landscape, this sort of integrated design approach, working under one umbrella. Yes, we are headquartered in the UK, but to have in-house expertise who are within reach through teams allows you to have that collaborative approach where when you have a question, send a Teams message, you get answers within minutes. Just a phone call away. So I'm seeing this sort of trend where people are starting to propose this approach called the integrated design approach, where people of the same attitude work together and as early as possible to gain the expertise to address issues, raise concerns, things that should be addressed early that might bring major savings or address major issues before it's too late in the stage.
I understand through our conversations earlier, and perhaps the audience might be interested to know, that Pasca has an in-house tool where the designers are designing its live. They're covering calculator at the corner of the screen, move each time they change something in the model. Yeah, maybe you can elaborate a little bit on that.
Yes, nowadays we work on projects and we only want projects that are net zero, and sustainability is such an important part of what we do. So, given we're lucky today that we have such tools, digital tools that allow us to design that inform us or apply design decisions based on data, because everything is BIM and everything is calculated to the level of amount of glue you use in our buildings. So as you model, as we're designing, the data changes, embodied carbon, all this, it's live, like the stock market. You remove one door, the number changes. You shift the wall, the number updates itself. That you have larger opening with smaller opening. All these are live updates, and all these are sort of in a long term of investment in-house to allow us to arrive at today, and our clients are starting to see the value in it. Yeah, and also it makes it easier to make design decisions, because some design decisions can be subjective, such as aesthetics, but many times the numbers do not lie, and that maybe this kind of quantity plays a bigger role in quality. So it's important to have a balance between quantity and quality.
So, okay, in your experience with so many projects, perhaps you can share some of the innovations that you do or use, or the tools in some of the projects that you have worked on?
Yeah, so
adaptive design.
Yeah, so basically, I just mentioned about because as well, one of the projects that we really get into how we can combine the technology with the form itself of the architecture, but also sometimes because we're doing a lot of big kind of projects, like a master plan installation with facade ideas. So we make use of all of the parametric architecture, kind of using and principle and so on, and how we can make use of that and somehow
get the feedback easily, quickly as well, to understand how the big kind of space and design affect the design of the space, the city that we design. So that's something that we really make use of at the moment. Whereas I mentioned this kind of idea of how we can integrate the sustainability and how we can integrate those kind of maybe biodiversity too into the design that will really help us to somehow create more kind of livable kind of place, especially with the facade, because the facade will be the somehow easily precise. That helps to make people want to live in that place or in the building itself. Okay? I think as the developer, I'm sure they're not by suppliers, technology, vendors, and all the time. So what are the things to look out for when you look at such vendors and presentations? Do you use anything interesting in your projects?
Not on the door that come with big, huge discount. I think before, of course, we have suppliers and vendors coming to us doing presentation, and we do have frequent vendors coming to us. But I think, again, when they have all these presentations, it helps us to think of how is it going to implement it into our building as a holistic approach. And at least we are aware that when we have projects of that nature, then how do we put in good use? Yeah. Just like on I guess when you mentioned about the innovative aspect and things like that, I would like to add on my experience on my involvement in two of the projects. That actually contractors actually gave some very good innovation idea. So just like in Jewel Façade, when I was doing the facade dome, I still remember the complexity. I mean, not as complex as the Henderson building that I saw in the curve. We create the curve by using cemented triangle glass. But like it or not, each piece of glass is of different sizes, and there's thousands of them. The quantum pieces of glass panel. So, and we actually, the contractor actually introduced a digital tagging system. So it was able to track right from the start, from the design, procurement, doing the fabrication, installation, all the way to the maintenance. So this helped to actually reduce the complexity and then increase the productivity of the installation, for example. And another example I would want to share would be Capital Spring. If you notice that there's a two-step facade thing. And over there, we able to navigate this challenge by using, I think just now we'll talk about digital tools, like the beam, etc. So because that installation calls for very precise installation method. So like I mentioned, innovation like this, it's a very simple innovation, but it works wonder for the project.
That is about logistics. Here's one point I also think in Singapore, we have very little contractor involvement at the beginning, and hence I think a lot of the design, sometimes the engineering, when it comes in, maybe a little bit too late, in effect, and then when the contractor propose certain things, then there's a lot of contractual issues and the contract stuff, etc. So that it becomes complicated things by a lot. And I, at that time, actually it's pretty interesting how think about the team, right, from the beginning. So us, and then we usually started with the concept stage, we do like really comprehensive kind of model. So we can talk about developer, we can talk with everyone involved in the project, the details and also specification that we try to achieve. So I think this kind of collaboration that we will address as well, a similar kind of
experience on that? How technology can help us to understand the design from the start.
Of course, I mentioned about the carbon calculator, to what Yana mentioned about the tools that the contractor introduced. Looking beyond just completion of the building, the entire lifespan maintenance, and we're very lucky to have these tools to help us.
Yeah, and the only thing I like to add about that tool is that it has not been used enough to the extent that I think it's going to make an impact in our efficacy, the way we do our work, productivity, as well as making our sustainable goal. Yeah. We have a few minutes left. I'm just going to give the audience one more chance to ask questions. I'll hold your peace. So, any questions? Anyone? Anybody? Okay, sorry. I'll put everybody on the stage. Esteemed panelists have the last word. Maybe in this case we'll let Kip start first, and then we'll go this, and then we'll have some ending remarks and conclusion. Maybe something that we hear over the day. Actually, that's a good point, because I was really thinking about how the presenter said today is amazing, right? A lot of new technologies, a lot of new tools that somehow could give more rich kind of exploration and building the value in the future. So I thought just now one of the presenters mentioned about form follow function, and she said on the her design is form follow motion. So I was thinking we should also think about form follow emotion. So how we can bring more human-centric kind of design into our facade with the technology that we have now. So I think that's it.
Well, we have one sentence, quality over quantity, something that we need to work on.
Yep. Especially in Asia? Yep. I think I'm looking at time, less than 5 seconds. I think I just one sentences, I think let's break the boundaries and then let's collaborate, to have a more sustainable facade. I will also end with a short statement. I've been attending Zak World for many years from the beginning. I think close to 8 years I've been with them. Sometimes I speak, sometimes I model, and I've seen many speakers. I can see today that a lot of what we have been talking about 5-6 years ago, I was only in theory. But today we can see the projects all being realized. So there has been advancement, and I think these kind of platforms are very important for us to see that what we were talking a few years ago all can be done. And I said, let's just do it. With that, I thank you, the panelists. And with that, I am fine. All right. Thank you, everyone. Thank you for staying the night. Thank you. Well, ladies and gentlemen, that is our wrap. What an incredible day of insightful discussions, innovative, groundbreaking technology, and let's be honest, some great networking. I'd like to thank all our speakers, and most importantly, I'd like to thank you, the audience, for being so engaging and being here all the while. Thank you very much, and have a great evening.